In this episode, we're going to go through the snapped phishing line room, which is a part of the phishing module of the SOC Level 1 pathway of TryHackMe. And in SOC Level 1, they actually added a few extra rooms. And this is why we're doing this, because I had originally finished this playlist and they added some extra rooms. So we have this extra one that's in phishing, which is the snap phishing line. And then we have a whole new module, which is the SOC Level 1 Capstone challenges, which is going to be a series of just challenges. There's no instructionals or anything like that. They're just going to put us through the ringer and see what we learned for the SOC Level 1 pathway. So I'm pretty excited about going through all of this stuff with you so we can wrap up the SOC Level 1 path of TryHackMe. And hopefully you have gone through everything so far, which is inside of the SOC Level 1 playlist, and you know exactly what's going on and what we're doing. And from here, you can kind of just pick up where the new additions were. And then right after this one, we're going to go through the simulations for the SOC. And then we'll go to SOC Level 2, and then we'll finish that up. And then we'll go into the pen testing stuff and everything else. So this is the snapped phishing line room. Now, there is literally nothing in here except this one task, which is the challenge itself and the scenario. And then we'll read through the scenario and see what it is, which is also going to be fairly a short scenario. And then from there, we'll dive into the questions that we need to answer, and we'll get all the flags that we need to get. So it's going to be a good one. I'm excited to go through this exercise with you. If you're serious about your CySec training and want to get access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master, and each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, Python automations every single month, live streams, so much more. So to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us actually jump into the snapped phishing line challenge. Okay, so here's the scenario. First, we have a disclaimer. It says it's based on real-world occurrences, and this scenario presents a narrative with invented names, characters, and events, and the phishing kit that's used in this was retrieved from a real-world phishing campaign. Hence, it is advised that the interaction with these artifacts be only done inside of the attached VM, as it is an isolated environment. So these are actual attachments that were created or used inside of an actual phishing campaign. So you don't want to download them onto your own computer and launch them, because they will most likely harm your computer. So the scenario is this, right? So an ordinary midsummer day. As an IT department personnel of Swift Spend Financial, one of your responsibilities is to support your fellow employees with their technical concerns. While everything seemed ordinary and mundane, this gradually changed when several employees from various departments started reporting an unusual email that they had received. Unfortunately, some had already submitted their credentials and could no longer log in. So you proceed to the investigation, and this is what's going on. So there's the analysis of the email samples provided by the colleagues, and analyzing the phishing URLs by browsing it through Firefox, retrieving the phishing kit used by the adversary, using CTI-related tooling, which is cyber threat intelligence, to gather more information about the adversary, and analyzing the phishing kit to gather more information about the adversary. Connecting to the machine, for me, is going to be through the actual Linux box that they provided as the virtual machine for this task. And this is a subscriber-only room, so you do need a subscription to TryHackMe. So this is, let's see, where were we at? Yeah, right here. So you can also remote desktop into this. You can RDP into this, secure shell into this. You do need to have a connection via OpenVPN to pull that off. So if you don't have OpenVPN, you won't be able to do it. And apart from that, if you do connect from your own machine, again, just be very careful opening these attachments, because ultimately it will be launched on your actual machine, on your computer. So my recommendation is, since you need a paid membership to TryHackMe, just use the virtual machine that's inside of TryHackMe, so you don't accidentally download something onto your own computer because you connect it through VPN or something like that. So that is my disclosure to you. Now, the phishing emails are to be analyzed under the phish emails directory, and usage of a web browser, text editor, and some knowledge of the grep command will be helpful, and we are going to use all of those things. So I already have it opened up inside of my browser. So this is the beautiful machine that we have available to us. And this is the phishing emails folder that contains all of these phishing emails. And I'm just going to open up my terminal just to kind of make life a little bit easier, because it says if we do need a text editor and if we do need access to the actual, the grep command and all that, then it would be useful for us to go ahead and open the terminal already and get ready to run. So here we go. Let us jump into the first question here. It's probably better to actually read all of the questions just so we can understand what is being asked of us, so that if we run across this information, we can pull it up real quickly. So who's the individual who received an email that contained a PDF attachment? What email address was used by the adversary to send the phishing email? What is the redirection URL to the phishing page for the individual Zoe Duncan? Or Zoe, I guess, Duncan. What is the URL to the .zip archive of the phishing kit? What is the SHA-256 hash of the phishing kit? When was the phishing kit archive first submitted? And when was the SSL certificate, the phishing domain used to host the phishing kit archive, first logged? And what was the email address of the user who submitted their password twice? And what was the email address used by the adversary to collect compromised credentials? The adversary used other email addresses in obtaining the phishing kit. What is the email address that ends in Gmail? And what is the hidden flag, the final hidden flag? So the first couple of questions I did already, just because I was kind of just trying to maintain my streak inside of TryHackMe. But these are also really easy to gather. So let's actually jump into our file right here. So what we can see is we actually have 5 .eml files. So when you look at the extension of all of these emails, we see that we have a .eml file, and they belong to the different employees. So this one belongs to Derek Marshall. This one belongs to Michael Ascott. This is Michelle Chen. This is Zoe Duncan. And we have the quote services that are available here. So that's it. I think that's it, right? Yeah, that's all we got. So those are the emails themselves, and the EML files, I should say. So the first question is, what is the one that contains the .pdf? Now you can always just open this up, right? And you can go through each one of these: Derek Marshall, Michael Ascott, Michelle Chen, Zoe Duncan, and who do we have? The quote services rendered, which I think is actually, this is like the last email that shows us the name of the person, because each one of these have the name of the user in them. This last one doesn't have a name of a user, and that's the one that I believe the answer was in originally when I looked into it. So the first way that I want to try to do this is I want to try to see if there's a way that we can just write a quick little script inside of secure shell for us to process all of the data for these EML files, to basically parse through the data of the EML files so that we can see which one actually contains whatever that we need, right? So this is the desktop where the fish emails directory is at. And then so what I'm going to do is I'm going to just do, we'll do like an email search.shell file is what we're going to create. And then I'm just going to write this real quick. And from there, we'll kind of run it and hopefully it'll work. If not, I'll just do manually and we'll just go through all of those files manually. So let's try it and see if this works. Okay, cool. There we go. We start with creating an email directory variable where we will actually store the path of the fish emails folder, which is where all the phishing emails actually are. The output file is going to be the PDF attachment results.txt. This command right here clears the output file just in case there's data inside of the output file. In this particular case, there isn't, but if we run this script more than once, then we're going to have results inside of the output file, so we want to clear it just in case. And then we have this for loop, which is basically where the bulk of the work is being done, or like grand majority of the work is being done. So for each file that is inside of the email directory that ends with .eml, what we want to do is if we want to check to see, number one, if the file itself actually exists, right? If there is a file type that exists over there, what we're going to do is first we're going to concatenate that variable, and we're going to search through that variable to see if there is something that is attached to it that has a content type of application or PDF. And I think it's actually supposed to be, I don't think it's supposed to be application, or maybe it is supposed to be application. So application /PDF. And then from there, we're going to also, so this is like a double requirement. So the first requirement is first we're going to grep to make sure that there is something called a content type attribute that actually has a value. And then we're also going to look at the file again, and we're going to see if there is the file name, whatever the file name would be. And this is specific to, what do we call it? And this is not supposed to be a plus sign. It's supposed to be an equal sign. So the file name value is going to have the regular expression of anything that ends with a PDF, essentially. So we're first looking for an actual attachment, and then if there is an attachment, we're also going to grep through the attachment to see if there's a .pdf extension inside of the attachment, because I've looked at the emails themselves, and there's a bunch of .html files that are in there. And then we're going to, if that actually is the case, right? So this is where the end of this comes in. It's kind of slow going, but when we look at it, we say, okay, so if those two conditions are met, if there is actually an attachment, and if the attachment has a file name attribute that ends with PDF, then I want you to do this other thing, which is this part right here, where it's going to concatenate the file, and it's going to grep for that content type application and put it inside of our output variable, which is the output file that we have. And then it's going to also concatenate the file and take the file name attribute that is ending with a PDF, and it's going to put it inside of the output file that we have as well. And then finally, it's going to just echo onto the screen for us that this is the file that was put into the output file, and then we're going to finish those two if statements, and then we're going to finish our for loop, and it will be done, and it's going to say echo search is completed, and that's it. So I'm going to do Control O to save that. I'm going to do Control X to run that. So I don't know if this is going to work, because the last time that I went through this, I did a manual search, but I do sometimes when you go through a bunch of different EML files to search for something, it's going to take a while for them to load, and it's very time consuming. So if all it takes is to spend 2 or 3 minutes to write something like that, and then you can go through essentially hundreds of .eml files, because assuming that you have a large employee group, you will most likely have a lot of .eml files. So if that is indeed the case, you want to do something that's a little bit time saving, right? So we now have the email search shell file, but it's not executable yet. So we do need to actually turn it into an executable. So we're going to do chmod plus x, and then we'll do email search.sh, and we're going to now turn it into an executable, and we can see that it's been turned into that because it's been turned green. But you can also just do lsla, and then you can see that this actually has the executable permission attached to it. Let me kind of zoom in on this a little bit here. So now we actually have all our executables. So now I can just run this thing, and let's see what happens. And it says the results have been written to the PDF attachment. So cat PDF attachment, and there's nothing in here. So we do have a PDF attachment result. So let's now go look into the nano PDF attachment, and there's nothing in there either. So that it leads me to believe that the script didn't work, because I do know that there is actually a file that ends with the PDF. So that's the part that seems to be a little bit interesting. So let's see if I can do a quick troubleshooting of this, and then if I can't, then we'll just manually look at them. So no big deal. Okay, so here is what I learned. So I opened up one of the emails, and then I looked at the source of it, and I'll show you how to do that in a minute. And what we found was that the attributes were different. So I just kind of assumed, based on previous exercises, that the attributes for the attachment is going to be something like this. And so I need to modify it so that it actually finds the given attribute that we're looking for, including the value that we need, etc. So it's going to be a little bit more complex than what you just see right here. But I mean, in the event that you would be interested to create anything like this, I think you will be happy that we go through this kind of an exercise. So I'm going to create it, and then from there we will analyze it a little bit, and then we'll hopefully get a chance to actually run it, and it will give us the results that we're looking for. So that's the goal here, and I'm hoping that it will actually work this time around. If not, we're gonna have to do some manual manual searching through these email files. So I will modify this script and then we'll look at it, review it, and then we'll hopefully get our answer. Okay, so here we go. I did get a little bit of assistance for this specific block of text because we are actually looking at base64 data as it said in our source code for the .eml file, and I just wanted to make sure that I did this correctly because I want this to succeed. This is way beyond the scope of this video and this room, and I'm trying to give you extra information so that you become even more equipped. So you could do all of this by just manually analyzing the email .eml files as well as everything else. But again, I want this to actually be an extra piece of information for you just in case you're dealing with many more .eml files. And if you actually create this script in any other environment, this will actually be very, very useful for you. And that's kind of the goal here, is to give you more tools and equip you better. So as we see right here, as it stands, okay, the first portion of the script is exactly the same. So all of this stuff is exactly the same. And leading up to this if statement that we see right here, all of that is exactly still the same. The stuff that has changed is assuming that there is a file, right? So if there is a file, so it says for file in this directory that ends at .eml, if there's a file, then this is what I want you to do. I want you to concatenate that file, and I want you to search through it. And what we're going to do is these flags right here, the I, Q, and capital E. I is that you're going to do it, you're essentially in search, in case insensitive mode. So you basically want to see if there's anything either lowercase or uppercase that would match this. Q is in quiet mode, so don't display it onto the screen. And then the capital E that we see right here is so that we can do regular expressions in an extended format, which is what we see right here. This is like an extended format regular expression. Now, this is kind of a whole other video. So there is a video that I have on regular expressions, which is very, very useful. And I do recommend you go check it out. But for the most part, everything inside of these quotes right here that you see right here is the full regular expression. The content type right up until this colon is a literal matching that we're looking for. The \S+ is looking for one or more spaces, empty spaces. If it was a capital S, it would be looking for something else. So you do need to look for a lowercase s to get empty spaces. And then we're going to look for text / HTML, which is again going to be a literal matching that we're looking for. And then the \, again, S+, because we're looking for empty spaces again. And let me just make sure I'm not missing any of these elements right here. Yeah, so this is actually looking for this is the literal string. Over here, we're looking for the empty spaces again. And then we're going to look for name in literal again. And then from here, or I guess it's name, and then this / right here allows us to search for this as a pattern, and in this particular case we're looking for anything that ends with a .pdf, right? So these backslashes are known as escape characters because we're not looking, we want to be able to look for a literal dot, because a dot in regular expressions also represents a wildcard character. So again, go check out the regular expression video just to really understand what this is when we're going through regular expressions. But for the most part, this whole thing is a regular expression that basically looks for the content type attribute. It looks for text HTML being the content type, and then it's looking for any file that actually ends with a .pdf. Now, if that actually exists, then what it's going to do is it's going to go and search for the, let me make sure that we are there before I start explaining. So if that actually exists, then it's going to go through this second portion of this, where it's going to then concatenate that file, and it's going to look for content disposition being attachment. So this is all part of the same condition, right? So an if statement is a conditional statement inside of any coding language, and we're looking for two conditions to match. The first one would be that it actually has the content type attribute that ends with .pdf, and it also has this other portion where there's a content disposition attribute that has attachment. Now, if both of those are good, then what we're going to do is we're going to concatenate and look for the contents of that specific file, meaning concatenate the files that are inside of this directory right here. And we're going to take this portion and we're going to output it into our output file, which is what we see right here. And then we're also going to take the next portion of it, which is going to be the content disposition attachment portion, and then we're going to put it into the output file, and then we're going to echo onto the screen, essentially log onto the screen that we put this inside of the output file. Now, being that there was a base64 encoded portion of that, we're also looking for the base64 data, and that is going to be stored inside of this variable. And when you put a $, and if you don't know how to do all of this, and this is all over your head, go check out the scripting video for the Linux Plus playlist, and we go into the creation of variables using the bash or shell languages. So when you put a $, in front of a variable, so for example, in this case, we created a variable, and the variable itself, the value of it was just a string, right? So we're just saying that this is going to be this, or this is going to be this. If you want to store a command inside of a variable, then what you do is you put the $, and then you open up parentheses and you write the entire command inside of the parentheses, and the output of this entire command is going to be stored inside of this base64 data variable. Again, if this is all over your head, I do recommend that you actually go check out the shell scripting video, which is the last video inside of our Linux Plus training series, where we actually go through a variety of shell scripts and we create simple and complex shell scripts. And so that whole thing is going to take the Perl, this is like a Perl execution of the grep command, where we actually search through it using types of Perl syntax, excuse me. So we're using Perl syntax to search for that base64 data. So the OP uses the Perl compatible regular expression, and then the $, that you see right here, this $, question mark, or where am I? Right here, this portion right here. It's not a $, it's the actual question mark S. There we go. So the question mark S that we see inside of these parentheses is enabling dottle mode, or dottle, basically a dot matching a new line is basically what we're looking for. I think it's pronounced dottle or dottle, whatever. So that's looking for dots representing new lines. And then we have the content transfer encoding base64, which this whole piece right here, which is actually matching the encoding header. And then it uses that \K to just discard the encoding header. And then this piece right here captures the base64 data, okay? And then the two dashes, so let me move forward a little bit. Let's see if we can we go? Okay, so these two dashes, it's kind of like it's at the end of the line, so it's a little bit tough. But these two dashes, and then these are all stored inside of these single quotes right here. Again, way beyond the scope of this video, so I'm just giving you way more information that you actually need. So if you don't want to look through this, and if you want to just look at the manual, you can go ahead and look at the manual search that we do later on in the video. So you can skip through this if you want, but again, I'm giving you way more than you need. So the dashes stop the capture at the boundary of the encoded attachments right here. So they stop the capture so that it doesn't keep looking for more data past this portion. And then the head N1 is just taking that very first match of this, which is what we have right here. This is the head N1, and it looks for the first match that comes out of that. Now, the next section of conditions is looking for the base64 data. So it's looking if the base64 data variable is actually not empty, meaning if there's something that shows up when we do this grep right here, then what you're going to do is you're going to go through that file name, you're going to grep through that file name, and you're going to look for anything that might be PDF. And then from there, you're going to, if the file name variable is not empty, then you're going to echo that, hey, we found this, and then we're going to put it inside the file name variable. And then we also found the decoded data, and we're going to put it inside of the file name variable. And then outside of that, let me make sure that I'm in the right line here. So that's all the base64 stuff. So this matches this condition. So this is assuming that there is actually something that was yielded from the file name search that we did right here. If there was nothing yielded from the file name search, you're just going to display onto the screen that there was no file name found, and we're going to save that data inside of an unknown.pdf variable. And if indeed that is the case, let's move on. We're going to base 64 the data that's been encoded and saved to the unknown.pdf. So this is all this condition, these series of conditions, and then that's going to be finished. So we will do fee, or the reverse of if, basically. And the next line is going to be the else for this. So this is looking for the base 64 data. If there is no base 64 data, then the else for this is going to say, hey, there was no base 64 data that we found, and we're going to log that into our file, and then finish, and then finish, and then finish. And then we're officially done with the full series of if statements and conditions, and then we're going to do search complete. So again, I understand this is way more than you actually need for this room. I'm just giving you way more information to keep you more capable. If you're dealing with a lot of .eml files, which is what happens in a really large enterprise situation, you do need to know how to build scripts like this, and then you need to know how to pull the data to be able to find those attributes, which I'm going to share how we actually found those attributes. But apart from that, you do need to learn how to create scripts to be able to cycle through all of those EML files to be able to find what you need. Now, all of that being said, I have no idea if this is going to yield any results. If it does not yield any results, then we're just going to move on and we're going to do a manual search. If it does yield some results, then hopefully we'll be able to like quickly find the information that we need. So I'm going to remove this PDF attachment results file, and we should have an empty directory. There we go. So now we're going to do the email search. And unexpected EF line matching for this, so that on line 17 syntax error, unexpected end of file. So on line 17 and line 39, I have a syntax error. So I got to go find what I did wrong over there. So let me go and fix that real quick. Okay, so it was literally a missing quote that I had to add to. Let me actually show you the file so you know what's up. But it was basically a missing quote that I had on the line where it had this thing right here. So the file name right here. After this command ends, or this name equals etc. etc. This last singular quote was missing. And then I had at the end of the file, I also had the previous series of done fee, as well as this whole piece. Like I had this whole piece that was duplicated at the very end of the file that I forgot to delete, because I started typing inside of the file without deleting that last segment. So those were our two errors. So this should be the very end of the file. It should look like this. There should not be any more done fees at the end of it. And this is exactly what it should look like. And then the file name, again, just needs to have that singular quote at the end of that. So now we have that. We're going to exit out of this. We're going to clear the screen. What's going on? Let's make sure that we're here. Okay, cool. So here we go. Fingers crossed. Let's make sure. Let's see if this actually works. Okay, so search complete, results written to PDF attachment. So cat PDF attachment. And oh, wow, look at that. It worked. So it said content type, text HTML. Name is quote.pdf, which is the actual PDF file. Content disposition, and file fish email quote services for this, etc., base 64 not found. So now here's the thing. So it needs to tell me which file this quote PDF belongs to. And that's the issue, that it's not printing onto my screen. Well, and I completely forgot to put that logic in there. But at least the code works, which is excellent. I'm very happy to see that it works. Now I just need to make sure that I put a little bit of logic in there for it to actually print the file name onto the screen for us, so that we know which file includes that quote PDF. Okay, this is where we add it. So it's towards the top of our for loop here. So for file found in email directory, if there is an actual file, or so for file that's inside of the email directory that ends with a .eml. If you actually find a file, then go through this and see if you can find the .pdf in it. And then if you do, this is the line that we added. So echo that we found the PDF file inside of that file name, and then just put it into our output file. So that's basically it. So I'm going to close this out, and we're gonna clear the screen, and then we're just gonna run the email search one more time. And there we go. So now we're going to do a cat of the PDF attachment, and it should say found it inside of the fish emails quote for services rendered process da 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 da. So that's the actual EML file that includes this .pdf. So all of that, we just did all of that work to be able to locate this specific email, and then now we got to open it and go through it. And again, I do understand that if there are only 5 EML files, you don't need to do all of that. But in the event that there are 500 EML files and you need to search through all of those EML files, then you do need a script that will work exactly the way that this script just worked for us. So this is what we got. So now I'm going to open this thing inside of our Thunderbird email. And from there, I actually have it opened up twice. So I'm just going to go and close one of these things, and then we're just going to go look at the Thunderbird email, which is going to be this thing right here. So now what it's going to say is that it's going to say, the question was, who was this delivered to, right? Who's the person that that received it? And it is William McLean, which is the answer for that question right here. And it says what email address was used by the adversary to send the phishing email. And this is the email address, accounts.payable@group marketing. And it's also available right here from group marketing accounts payable. And there it is. So thank you for bearing with me as we figured that out. Hopefully, after I edit away all of the errors and all of the weight and all of that, it shouldn't take that long to see what we just created. And hopefully that'll serve useful for you when you're dealing with very many files that you need to sift and sort through. So those are the first 2 questions. Now we have these other questions that I don't have previous answers to. So it says, what is the redirection URL to the phishing page for the individual Zoe Duncan? And we want the defanged format for it. So now we know who we're actually looking for, and it's this email, which is for Zoe Duncan. So I'm just going to open this up, and we're going to look for the redirection URL for Zoe Duncan. And this is the URL that we have over here. So I'm just going to right click on this, and then I'm going to, let's see, I don't want to, oh, interesting. So usually it allows you to actually copy the link address. And so I don't want to copy the actual email as if I want to see the forwarding, the hyperlink, right? The, what are the href is like the technical HTML type of code that you would use to create a hyperlink. So what we want is, and this is actually a good way to show you how I found the other attributes anyway. So we're going to go view, and then we're going to look at message source right here. So when you click on view inside of Thunderbird, it'll give you a few different options. You can look at, the headers in all or full format, message body, etc., etc. So I want to look at the message source, and when I do this, it's going to open up inside of a text editor like we see right here. Now there are a few different ways that I can search for the hyperlink that is available on here. Now if I do for href or which is basically the hyperlink HTML code to actually create a hyperlink, I'm going to get a hyperlink for this, I'm going to get a hyperlink for the one down here. And I'm more interested in the very, very first one, and both of them technically have the same value anyways, so that should be, in either case, it should work fine. So we're going to do this, and then we're going to right click on that. We're going to copy that, and then we'll see if that'll actually, where's my text editor that I had? There's the text editor. So in here, we can just go, I wonder if Control F would work, and Control F does work. So Control F, and then it'll bring this find for you, and then we do Control V, and it'll print it, right? So it'll paste it in here. So the very first one is going to be from. So obviously that's the from address. Then the next one is going to be the, let's see if I can find it. Okay, so every other version of it is actually not doing the accounts at or accounts.payable, etc. What it's doing is that it's using the I believe it's a URL encoded version of it, because we don't see accounts dot. We see accounts equals 2e and then payable at g da 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 da. So what we're seeing is the encoded version of these things. And I mean, even when I found the portion where it says contact us by emailing such and such, it's actually not showing me the hyperlink for this, because it doesn't seem to be a hyperlink that is pointing to. It's literally pointing to the email address that you would send to. So what we're looking for is an actual link that's available over here. And so what do we have? We have new island. There's a link right here, which is the HTTPS, and then the LinkedIn version, and then there's the YouTube, etc., etc. So I'm trying to find the thing that has an actual hyperlink that she gets pointed to. And even on here, I don't really see I mean, this is literally the email. So I don't see what the hyperlink would be to the redirect that we would get to see what that is. So there's the the attachment, which is the direct credit advice. And now it says save the file directcreditadvice.html or open it with Firefox. So I'm going to open up the HTML file and see where that opens up to. I feel like it's going to open up on our local machine, so that may not be the one that we're looking for anyways. So let's see, let's kind of rummage around and see what we can find. So when we open that HTML file, we land here, and it looks like it's a Microsoft login, but when you actually look at the domain, it's obviously not a Microsoft domain. So I'm going to copy that whole thing. So I'm going to do Control A and I'm going to do Control C to copy it. And then to defang something, you always want to use CyberChef because it just makes your life very, very easy. And what we're trying to do is we're trying to defang a URL. So that's the full URL that's available over here. Now what I need to do is I need to defang it. So I'm going to go inside of my operations here and I'm going to type in defang. And you're going to get a few different options. You have defang URL or defang IP address. I want to do defang URL, and I type that in here, and it creates the defang version of it for me, which is a combination of a few things. It turns HTTP into HXXP. It'll wrap a lot of these elements into these square brackets, so all of the dots essentially are wrapped in square brackets and all of that. So I'm just going to copy that whole output that I have over here, and I'm going to go inside of my answers, and we're going to paste this, and let's see if that's correct. And it says it's not correct. So the redirection URL for the phishing page for Zoe, and I mean I feel like that really is it. So I don't understand why that wouldn't work. So let's see. So we are definitely on the right path. This is actually the specific thing that we're looking for, but I think this is too much of an IP address and the value is massive. It doesn't seem to be working properly. I'm just going to keep the browser open just to make it load a little bit faster. We do want to see where the headers are for this, and inside of the source, again, we can just go ahead and find the various sources. So let me just close this specific item, which is the other one that we had, and then we have the Zoe Duncan here. So we're going to go view, and then we're going to look at the message source one more time, and then it would also be included inside of these locations. So what we're looking for specifically is the HTTP that would show up first, the very first HTTP, which is the URL that we're going to be sent to in this particular case. So, or excuse me, we're looking at the wrong thing. My apologies. We're supposed to be looking at the credit device right here. So I'm going to download this specific item. So I'm going to click save at the bottom right. We're going to save that, and we will save it on our desktop, and then we're going to save it over there. And now we can go ahead and essentially grep through it for the item, for the redirect. So let's go ahead and grep through it for the redirect. All right, so there is the HTML file, the direct credit advice. So we'll just do a quick little lesson, see what we can find here. And this is what we got. So this is the very top of this whole thing. And you see right here, this is the actual URL. So the redirecting right here is the piece that we're looking for. So if you're not redirected automatically, please click on da 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 da. So this is the whole thing, and I need everything that is inside of this piece right here. So I'm going to take that whole thing, and we will do a copy of that, and then we'll go to CyberChef one more time, and let's paste that in here. So yeah, definitely much shorter. It is the Kenna Roads location. I just went to the actual browser, and I think the browser was giving me more data than I needed. So let's do this. Okay, there we go. So we got that, and I am officially, yay, I got my 9-day streak. I used to have like a several 100-day streak, and then I got sidetracked by life. Okay, so there we go, redirection URL, and we were able to find it inside of our HTML file by just simply going through the contents of the HTML file, and this is what we have. So when you do less, it gives you portions of it instead of giving you the full thing. And let me Control C out of that to see if I can escape out of that. Q gets you out of the less command. I completely forgot. So less basically lets you look at a document page by page or section by section, we can say. And then if you need to escape out of it, you would just press Q, and then you'd be able to get out of that. So there we go. The direct credit advice HTML was that. And so now the next question that we have here is, what is the URL to the zip archive of the phishing kit? The URL to the zip archive of the phishing kit. So let's go and actually grab this URL. So we'll do this first. So we'll just take this whole URL right here, and then we'll open it up in our Firefox browser. And let's see what we get here. Oh, it's Control V. There we go. Okay, so there we go. So we have update365.zip would be the actual, I believe that's the location. So if I do update365.zip would be the full path for that. And I think it's going to download. Yeah, it'll download the zip file. So that is the full path of the zip archive. So we will go ahead and copy that, go over here, and then paste that here. Or wait, paste that. Come on, what am I doing? There we go. Okay, cool. So now this is the defanged version of the zip. So we're going to do that. And then we're going to go and paste that over here. Cool. So what is the SHA-256 hash of the phishing kit archive? Phishing kit archive. I'm guessing this is what this is. I don't know if we need to open it or if we need to, what is it, like unzip it. So let's see if we do need to unzip it. Where is the zip file? So that would probably be inside of our downloads. Okay, there we go. So there it is. And so what we're going to do is we're going to do SHA-256 sum, and then we're going to do update zip. And that's the SHA-256 of the update zip. So I wonder if I need to actually, what is it? De-zip it or unzip it for this to work. So let's try the zipped version. Oh, okay. So no, it is the zipped version. So you don't even need to unzip the file. You basically, as long as you have it downloaded, which is what I did, right? So I went to the browser and if you click on this, it'll just download it for you. Or if you just go kennaroads.buzz/data/update365 zip, it'll just download the zip file for you, and it'll be inside of your downloads folder. And that's what the SHA-256 sum of it is. Now it says, when was the phishing kit archive first submitted? So what's the hint here? It says, use a well-known open source tool to gather more information about the domain. Oh, that's easy. So we're just going to go to VirusTotal, and we're going to search for the SHA-256. There we go. And there it is. So we're looking for the first submitted date for this. And it's by 31 out of the 67 vendors have flagged this thing as a phishing. So first submitted date, boom, right here. So first submitted date is this thing right here. So just going to take the whole thing. Whoops, let me take that last C right there, copy that. And this is the, yeah, so there we go. Cool. When was the SSL certificate the phishing domain used to host the phishing kit archive first logged? And the hint for this is no longer available to reliably answer this question. Oh, interesting. Yeah, because I think it expired, so they haven't renewed it. So there you go. If you're looking for certificate information, you can always find the certificate information by clicking on this little button right here where it says, it's like right next to the domain in your browser. So if you actually go look at that, it's literally right next to it. And it's usually like represented by either like a lock symbol or something, right? So when you do that, and then you go to connection is secure, and then it says certificate is valid, and then you open that up, and then you actually get the certificate information, right? And it says issued on or expires on, whatever. It'll give you the hash value of the certificate and the public key and all that information. So, and then you can click on the details and you'll be able to get more information. Now, that's actually if there is a certificate that's available. If there's no certificate available, then you can't pull that information. And we can tell that there's no certificate available because it's an HTTP domain. It's not an HTTPS domain. And that's very, very important to kind of wrap your head around. If it's HTTP, that means it's not a secured version of HTTPS, or it's not a secured version. So we see it right here, right? So it's XXP. Usually there would be an S at the end of it if it was a secure domain. And if it was a secure domain, that means there's some kind of a certificate. But there is no secure domain, meaning there's no certificate. So the answer for this was actually given to us. Now, what was the email address of the user who submitted their password twice? Golly, who submitted their password twice? So where can we even find this information? So what do we have here? We have the actual files. So let's go into this directory. There's a log inside of this directory. So let's look at the log here. Isaiah submit. Oh, I see. So there we go. Isaiah submitted his password. This guy submitted his password. Michael Ascot submitted his password. Let me see. So what can we do? What's like the easiest way that we can find this? So what we will do is we'll go for each of these passwords. I'll just do this. I'm going to copy the password. Oops, not select all. I'm going to first copy the password. So I'll highlight it, I'll copy it, and I'll do Control F, and then I will search for the password and see how many times it shows up. So it says 1 of 1, meaning it showed up once. And then we'll take this next password and we'll copy it and search for it. Oh, 2 matches. So there we go. 1 of 2 matches, invoice 2023. So this is who? Michael Ascot that did it. So where's the next match? That is also Michael Ascot, who submitted his password twice. Come on, Michael. What are you doing with your life? So what is the email address of the user who submitted their password twice? That's what we're looking for. So do we have his email address? We do. This is his email address. I am ashamed of Michael. No, I mean, he probably doesn't know. We can't be mad at him. He wasn't trained properly. What was the email address used by the adversary to collect compromised credentials? So that is now what we're looking for. So let's see if we can actually find that over here. So none of this information is actually relevant to the person who's capturing it. It's mostly the people who actually submitted their information. There is another directory here. So if we go to Office 365, there was nothing found over here. So let's see if there's any other information that we can find that would be useful to us. So if we unzip the Update 365 zip file, there's a many data points that are over here. We have, delete PHP error log, a variety of other information over here. And we're looking for something that might be interesting to us. So enter password.php. Let's see, favicon, logo, robots, resubmit, submit.php. That seems interesting. So let's see if we can. So now what happens? So if I have this, I have an update 365. So if I actually go into the update 365, I will see Office 365. So I will go into Office 365 and then I will see this information. And so where's the submit PHP file? So submit PHP is inside of validation. So let's go into validation and let's see what's in here. So we do have submit PHP. So we're going to cat the submit.php. See what information that we find over here. So this is the contents of the submit PHP file. Now what we're looking for is something that would submit or, submit the information, right? So we're looking for the thing that would actually have that person's email address in there. And that is something that I am curious about too. So let's see what we can find. So there's this email right here. It's under the send variable. I'm guessing it would send it to this person. So we could try this one. Let's try if this is the actual, let's see if this is the actual email address that is receiving that information. Oh, it is. Okay, great. So it's being sent to whoever this is, menpat or M3npat something. So this is the person that is receiving all of the compromised credentials. The adversary used another email address in the obtained phishing kit. What is the email address that ends in @Gmail? So this would be a little bit easier for us to search through. So we can click on the search button up here And what we're going to do is we're just going to do @gmail.com, press enter, and see if anything shows up. And I don't know if it's searching through this document. Maybe it's not. So let's see if I can go find something that is @gmail in here. Oh, there it is. Okay, so this is actually inside of the update or updat. It's not even, instead of doing this, let me just ls real quick. So I looked through a few of these files here. There's the updat.cmd, so updat.cmd. And inside of that, we actually have at the very, very bottom right here, we have the James Tanner 2299 @gmail. So let's see if that is potentially the answer that we're looking for here. And let's do that. Okay, cool. Very nice. And what is the hidden flag? So what's the hint for this? It says the flag contains a .txt extension and some adjustments should be downloadable from the phishing URL. Look for the flag in every subdomain directory of the phishing URL. Okay, that's exciting. So the phishing URL itself, it says we're looking for in every subdomain directory of this thing for a .txt file. So I am obviously not going to manually search through this. So what I'm going to do is I'm going to use, there's a tool that is really useful for this actually. It's GoBuster, and GoBuster will actually enumerate something for you and look for file extensions inside of any given domain name. So let's see if we even have GoBuster installed on this machine, because if we do, it would make our lives very, very easy. So let's go into, whoops, I need to go into the main directory for my guy, which is right here. So we'll go into the desktop and okay, cool. There's all of our data. So let's see if we just do GoBuster, and it says the command GoBuster cannot be found, but it can be installed with apt install GoBuster. So maybe that might not be the, I mean, dude, I don't want to go through all of these directories here to see if I can find a text file. So maybe I can, I guess, right? So maybe we can do kennaroads.buzz/data. Maybe inside of all this stuff, there is actually something that we can use. Log.txt, Office 365, that's not accessible. There's a log.txt, parent directory, update65.zip, kennaroads.data. So let's see if we just go to Kenna Rhodes' website, see what we can find over here. And inside of it, there might be something. So mind blown, a blog about philosophy. And there would be some kind of a text file in here. Okay, so I cannot download GoBuster because I am not a sudo user on this computer. And really, I mean, what happens is when we try to navigate this website, because it basically tells us in the hint to navigate the website, to like go through everything inside of it. And so if we go to the parent directory, these are the only two things that are available: update 365 zip and an update 365. And if we go over here, we can see that there's the log text file, and then there's the Office 365. And then this is a not found, essentially, meaning that we can't look for, or it's either not found or it's like a dead domain or something. And then one of the things that I also did is I went into the, let's see, we want to go into the downloads folder, and we have this update 365 location here, right? So essentially, if I do print working directory, this is where my actual directory is right now. And what we can do is we can search for the individual path itself to see if there's anything like a text file inside of that path. So just in case maybe it's inside of that folder. So what I did previously was I went into home, Damien Hall /downloads, and then /update 365. So we want to search inside of that location, and we're looking for a file type that has a name that ends with the .txt, like that. So we press enter on this, and then we only get these two specific files right here. So if I do a cat of the, let's say, the robots, right? So if I do Damien Hall /downloads /update 365, and then /office 365, and then /robots.txt. So let's say if we do that, we have these various locations, or these various, I guess, extensions, because kind of that's what it does for you, robots, is it kind of shows you the things that were indexed by the various search engines or the things that you want them to index. So we have these specific locations or these things, and none of these things are a flag or anything that would be of use to us. And then so what I'll do is I'll just copy this whole thing and we'll just use that as our cat option to see if there's anything inside of that location. Maybe, I don't know. So we'll paste that and then we'll do robots.txt. What are you doing? Why are you... Did it actually... Wait. Okay, cool. Okay. So even with this, I still don't have anything that would be interesting or useful to me. So none of this stuff, unfortunately, is useful to us. So what we can do in this case is if we just, I don't know, this is like a, now we're just trial and error. So what if we add a, let's do asterisk.txt. Anything shows up, nothing shows up. And I don't think that's even a query. So what if I do flag.txt? Oh, look at that. Wow. Honestly, really, that's like a shot in the dark. That was like a throwing anything at the wall to see if it sticks. So this is the secret. So I'm guessing this is our flag. Now this is an encoded version of the flag. So find out the type of encoding. Let's do that. And then if we do encoding explorer, and then let's paste it in here and see what this might be. So it is, well, these are the various types of encoding. I'm just trying to see what type of encoding I got. So I don't want you to decode it for me. I want you to tell me what the potential encoding actually is. All right, so what I'm just gonna do is I'm gonna input it inside of CyberChef, and I'm going to do that. Now, what is this magic button? It says from base64 will produce this, which is what that does. Oh, interesting. It actually has something here. So THM play with, interesting. That I think that's actually it. So what needs to happen is that I just need it to be reversed, because I feel like this is exactly it. It seems like this would be the flag, except it's in reverse, which is kind of odd. So let me see. That's interesting. Okay, so let's see. I think we're getting close. Look at that. It actually worked. So there's another operation inside of CyberChef, which is called reverse. So I did from base64, which basically turned that, and that was like an automatic detection. So it actually does work in that regard as well. So we'll do it like this, right? So I'm going to remove this, and I'm going to remove this, and then there's this little magic button right here that kind of detects what it might be. So if you click that, it'll actually reverse it for you, or it'll decode it for you. It'll implement the operation that might work, which is from base64 in this case. And then we just need to reverse it to actually get the flag. And that was me just, again, kind of like, oh, this looks like it might be the flag. So let's see if that is actually the flag. And I think that is the flag. So let's go into our little location here. And then let's click on this and type that in. And that indeed was the flag, my friend. So we finished the snapped phishing line exercise. So that was it. That was pretty cool. It was a nice little exercise that we were able to run. You got a chance to see what it's like to create a shell file, a shell script to be able to run through a bunch of .eml files, or really any kind of file, and look for a specific type of attribute and an extension, and you were able to do that. I don't know if you skipped through that portion to just look at the manual versions of the test, or if you actually hung with me as we went through it. But really, if you just wanted to manually look for something, it's not difficult to do, because you would just open every single one of these files over here. And then when you open the file, at the bottom of each one of those files, there's an attachment. And so if you looked at it, this is it. There's the quote.pdf attachment that's available in this file. So it's not hard to do manually if you have a handful of files to look through. But if you have hundreds of files, because you're looking at, a company that has hundreds of employees. So if you have hundreds of files, then that would be a little bit more time consuming. It would be very difficult to do. So you need to be able to look through every single one of those files using some kind of a script. So you got a chance to do that. You got a chance to see what that's actually like. And then we went and looked at the redirection URL that was found. What is the URL to the zip file? We found it, the SHA-256 hash value of it, the phishing kit archive. When it was submitted, we got this from VirusTotal. The SSL certificate didn't exist anymore, so they actually just kind of gave us that answer inside of this question hint that we had. And then the email address of the user who submitted their first password, and that was available when we actually visited that domain and we looked at the update, the log itself that was on that domain. The email address that was used to collect the compromised credentials, and we had to actually download the zip file and go through the various documents or the various scripts, the PHP scripts and things like that, to be able to find it. And then from there, the adversary used other email addresses, and we found that in the backup. No, it wasn't the backup. It was the update. So there was submit.php that we found this information from, his actual password. And then the update.php was the one that we found the backup email address. And then finally, we literally, I mean, I tried a few different ways to find that final text file, but ultimately it just came down to going to the browser and just like kind of, throwing a Hail Mary and just putting that flag.txt. Now, if I was able to download GoBuster, you could just run a GoBuster scan against this domain and it would show you all of the TXT files that are on this domain. So that would be the other way that we could have done it, but we weren't able to download GoBuster. We had to do most of this stuff manually. And any engineering guy, any cybersecurity person, or guy or gal, any cybersecurity person that is on the engineering side will tell you that you want to automate things as much as you possibly can. This room kind of limited us, and they didn't want us to do it because I think this is still a little bit on the beginner side of things, because we are doing SOC level 1 and all of that. So for the most part, we were supposed to do everything manually, but I like to kind of go off script a little bit and go down some rabbit holes and see if there's anything that I can share with you that might be useful. And in this case, there was, and hopefully you got some value out of it. If you did get some value out of this video and you would like to get more videos like this in the future, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. Make sure that you drop a comment if you have any questions about what we did in this particular exercise, or if you need an explanation for any of the questions or anything like that. If you have a question, if you have a comment, if you just want to say hi, all that stuff, drop a comment below. It helps the channel actually get some more traction and things like that. But definitely make sure that you subscribe, because there is a lot of other videos that are going to be coming out in SOC level 1 as we refinish SOC level 1, and then we're going to go finish up SOC level 2, and then we have the AI for cybersecurity that's also in the works right now, and then I have the ethical hacker pen tester stuff that's going to be coming up. So there's a lot of great stuff that's coming up in the future on this particular channel. So make sure that you like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out, and of course drop a comment. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master, and each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@hankhacks/hackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section, and that is it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I'll see you in the next video later. In this episode, we are going to go through the Tempest challenge, and this is a part of the SOC level 1 Capstone challenges, which is a part of the SOC level 1 pathway of TryHackMe. And the Capstone challenges are essentially the very last module in the SOC level 1 pathway that they added relatively recently, I think maybe over the last 6 months or something like that. And these are all just a bunch of challenges. There's very little information. I feel like there might be some information that they're going to give us in forms of like lecture format or something like that, but I think they're splitting the challenges into individual segments. So this is what I believe, but this is what I'm assuming is going to happen, because they all fall under challenges in general. So that being said, this is the room that we're going to go through, and it's a part of the module that we're going to go through. And essentially we are doing a big capture the flag type of exercise, and we're going to try to capture as many different flags and answer as many different questions and solve as many different challenges as we possibly can. So we have the intro, we have the preparation for log analysis, preparation tools and artifacts, initial access for the malicious document and the stage 2 execution, and then malicious document traffic. All of that falls under initial access. Then we have the discovery for the internal reconnaissance, privilege escalation for exploiting privileges, and then actions on the objective, which is fully owned machines. Now, this sounds like it's a series of actions we would have to take for a penetration testing exercise, but we are technically in SOC level 1 and we are security operations center analysts. That's kind of what we're doing here. So I wonder if we're actually going to be running pen testing exercises, or if we're trying to kind of trace the steps of somebody who did all of those things and we have to catch them. That's kind of what I feel like we would be doing, or that's what I'm assuming that we would be doing. So anyways, that is the Tempest challenge, and we are going to tackle it together today. And if you don't already have access to TryHackMe, I would highly recommend that you get it, because it is a controlled environment. I did find out last week that they discontinued their referral program as of November of 2024. So unfortunately, there's no longer a referral program, and I'm very sad about that. But I still think it is an amazing bang for the buck. So if you do get the annual membership, you get a discount on the membership. If you don't, and if you just want to pay the $13-14 a month, whatever the price is, I still think it's very, very worth it compared to everything else that's available on the market. You get access to a bunch of virtual machines, and you get to do these cybersecurity and hacking exercises in a controlled environment where you don't get caught up. And if you do something, or if you scan a machine or something like that, which is a felony, you won't get into trouble for it. All like none of that will happen, because you're in a controlled environment, you're in a lab environment, and you get to do all of these practical exercises. So I think it's very, very worth it. I get nothing from this. Back when there was a referral program, I would get some kind of a referral credit, but from that, it doesn't even exist anymore. And I still stand by TryHackMe, and I think that is a very, very powerful resource. So again, highly recommended. And if you don't have it, you can kind of just follow along with the lecture and with everything that we're doing, and then try to do it in your own environment. But again, it's just easier and more convenient, and you get into less trouble if you actually use TryHackMe. So that's my whole spiel on that. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the Tempest practical exercise. Okay, so the intro actually tells us that we're going to be analyzing endpoint and network logs from a compromised asset. Given the artifacts, we'll aim to uncover the incident from the Tempest machine, and we'll be asked to be one of the incident responders that will focus on handling and analyzing the captured artifacts of a compromised machine. The prerequisites would be the Windows event logs, Sysmon, Wireshark packet operations, and Brim, and all of these actually have videos dedicated to them inside of the SOC Level 1 playlist, and you can go find them. It's in the title, but you can also just kind of search for it and you'll be able to find it. There are multiple videos on the channel for event logs. There are multiple videos on Sysmon, multiple videos on Wireshark, and I think there's only one video on Brim, and that would be inside of the SOC Level 1 playlist. The investigation environment is going to be the virtual machine that I've already started, and we can actually see that on the right-hand side of the screen, which is this machine. I'm going to open it up into full screen in a little bit, and that's what we have. And if you do have TryHackMe, and if you want to do this on your own machine, then you would need to connect via OpenVPN, and then these would be the login credentials. The IP address changes every single time that you load this virtual machine. So this IP address that you see right here is not going to work if you just try to randomly scan it, or if you try to break into that machine. It's not going to work, because by the end of this video, I'm going to break this down and you're not going to get access to it, and you won't be able to do anything to it anyway, because you would need to be connected to the TryHackMe servers through OpenVPN. If you don't have that, then it's just not going to happen. So that is it for the overall setup and the introduction of this video. So let's actually look at the very first preparation step over here, which is the log analysis step. So as a review, we need to go over two general concepts. One of them is log analysis. The next one is event correlation. So every event that happens inside of a given network or inside of a given machine generates some kind of a line item inside of a log. So if it's the authentication log, if it's the web server logs for Apache or Nginx, or if it's the system logs, the security logs, whatever it is, there are events that are generated that get logged. Now, log analysis is the process of understanding those events that are generated to identify anomalies like a security threat or an application bug, system performance, or anything else that may impact the organization. And the log file has an audit trail, or it is an audit trail of events or activities that happen inside of any given application or the system or the network at large. And logs automatically audit any activity that's configured, like these system messages, authentication attempts, network traffic, basically anything that happens on a computer, down to a click. If you like click on something and if you open something, there is a log item that's generated for that activity and that event. So just keep that in mind. For in a good environment where you have these things set up, there pretty much everything can be logged. I'm not going to say they will be logged, because depending on how the system has been configured, they may not log the smallest things, right? But for the most part, you can log essentially everything. And the concept or the philosophy of the security analyst and the penetration tester is to be the most paranoid person that you can be. And so that means assume that everything is being logged. And especially when you're on the offensive security side and you're pen testing and ethical hacking, just assume that there is everything that's being logged, and everything that you're doing at some point can be reverse engineered and tracked back to what you did. So just keep that in mind. So that's what log analysis is. Now, event correlation is when you use the relationships between the different logs, right? So an event that takes place can generate events or individual line items in different log sources. So it could be the application log and the endpoint log and the network log that generate these items or these individual events that combine together, they correlate together to make up the big incident that has taken place, right? So if we're doing an incident response exercise, we can look at the overall thing that happened, right? So, you know, one of our networks was hacked into and they stole some data, So that's the incident, right? When we look at that as the overall connection of all of the individual events, it's easy to say, okay, so for this big incident, there were 4 log sources that generated a bunch of events, and then we need to correlate all of those events to try to figure out what happened in this incident, okay? So event correlation deals with identifying the significant artifacts that coexist from different log sources and connect them to each related artifact. So a network connection log may exist in various log sources like the sysmon log or the firewall log, and the firewall log may provide the source and destination IP, source and destination port, protocol, and the action taken. In contrast, sysmon logs may give the process that invoked the network connection and the user running the process. So all of those individual items or artifacts come together to give us a full picture of what this person did in this given series of actions that he or she took. So with this information, we can connect the dots of each artifact. So source and destination IP, ports, action taken, protocol, process name, user account, and machine name. All of those things can come together. So event correlation builds the puzzle pieces to complete the exact scenario into an investigation. So there's that. So now we can look at the tools and the artifacts that we would use in a given environment, and just overall what that whole process would be like. The list of activities, or the list of tactics that we're going to use or go through in this specific section is going to be for this investigation that we're running for this video. So we're going to talk about the artifacts and the tools that would be needed for that. The very first thing that we want to look at is the hash value, the checksums of the individual artifacts that we're looking at. And this has to do with chain of custody and making sure that the integrity of the artifact has not been altered, right? Nobody's tampered with the given artifact. So if we go into, for example, the desktop incident files location and then list the incident files, which is going to be these 3 files. We have a PCAP file, a packet capture file. We have a few, it seems like executable files. Let me see if that's indeed the case. Let's see what the breakdown would be. It doesn't say what the extensions are. We could find out what EVT, or I think if I click on it, it might be able to tell me. No, it doesn't tell me. Okay, so but in either case, whatever these things are, what we need to do is we need to first get the hash value for it. Now, if we're using PowerShell, it's going to be a very different command than if you're using a Linux command line. And this is called a commandlet, essentially anything that has a verb at the beginning of it, and then it has this noun that we want to get. So we want to get the file hash, and then the algorithm that we want is SHA-256, and then we want it for this specific file, which is the PCAP file that we have, the capture PCAP file. So then it gives us the hash value. So algorithm SHA-256, this whole piece right here is the hash value, and it's for that given path or that item. So when you look at that, or when you start collecting this data, you can say, okay, well, these are the hash values that we have now for this version of the file that exists in here. And then we need to compare it to the different hash values that are generated inside of these endpoint logs, or the various logs that we're going to look at, to try to compare and see if the hashes have changed, therefore implying that the file somewhere along the way was either altered or tampered with or edited, modified, etc. So then we have the tool set, which is needed, which is going to be analyzing for the sysmon logs, Windows ML logs, and packet capture. So we have the endpoint logs. And to be able to analyze these things like the Windows event and sysmon logs, we're going to use the EVTX ECMD and then the Timeline Explorer, Sysmon View, and Event Viewer. For network logs, we're going to look at the Wireshark and Brim tools. And then these are listed in our taskbar. And again, so if you don't know how to use Wireshark, there's videos for that. If you don't know how to use Brim, there's videos for that on this channel. So you can go just find those. And there are very detailed breakdowns on how to use those tools. All of these things are covered by the prerequisite room. So we'll only cover the new ones in this section, meaning we're not going to go through the details of these specific tools because we have other videos that exist on them, but all the new tools we're going to go through. So for example, EVTX ECMD and Timeline Explorer. So Zimmerman is a big name in this world of incident response and analysis and security, and he has a set of forensic tools called the Easy Tools by the Eric Zimmerman creator, the Eric Zimmerman author, developer, etc. We're going to focus on the EVTX ECMD and the Timeline Explorer, and they're mainly used for parsing and analyzing EVTX logs. So EVTX ECMD, I need to find like a different ways. I'll just call that double E or something. It's a command line tool which parses Windows event logs into different formats like CSV, JSON, XML, da. You may use this tool in conjunction with the Timeline Explorer created by the same author. Timeline Explorer is a GUI-based tool. It has a graphic user interface, point and click, drag and drop, basically. And it functions as a data filtering and navigating application to ease incident responders in handling raw data. To parse the provided logs, we need to convert the EVTX logs into CSV using the EVTX ECMD, and then feed it into Timeline Explorer. The command for that would be this. So we being inside of the tools EVTX ECMD, we're going to call on the executable, and then we're going to say, this is the file that I want you to convert for me, basically. And then I want you to convert it into a CSV, and then the output is going to be this thing, and then it's going to be the sysmon CSV. So the output is going to be in this folder, and then this is going to be the file name that you're going to output it for me to. And then it's going to do whatever it does, and then it basically processes log. This is a lot of data just to convert something into a CSV file, but it will go ahead and do that. It'll process that file and it will convert it into a CSV file. Then for Timeline Explorer, we can load that CSV file by doing file open, choose the file, and then from this location, very, very simple. If you've ever loaded anything into any kind of a software that allows you to load something, it's a very, very similar process. And then once it's loaded, you can navigate through each item looking at something like this. So this is, if you don't know what a CSV file is, it's comma separated value. And usually when you want to access that data inside of some kind of a graphical format, you would be able to open it inside Google Sheets, for example. You'll be able to open it inside the Timeline Viewer tool, as we're looking at here. So technically, you could even just open the CSV file that we get from this conversion, the sysmon CSV. You could technically open that in Microsoft Excel, technically. You can also technically open it in Google Sheets. And then it will give you a similar view, but it probably won't give you the functionality that's available in Timeline Explorer, which would be very relative to cybersecurity incident response activities. I hope so. I hope there's like extra functions that we can do with it. So you can use the search feature in the upper right hand corner to find a unique string that may exist on any column. You can also do that inside of Excel and my Google Sheets. So Sysmon View is a Windows GUI-based tool that visualizes the Sysmon logs. Before this tool, we must export the file's contents into XML via the event viewer. So we would open up the event viewer, and then we would look at whatever the event is that we're trying to do, and we would save it as an XML format. So you can see right here at the bottom, it's saving it as an XML format, and then it'll go ahead and export it for you into an XML. And then from there, you would import the Sysmon event logs inside of the Sysmon View tool. And once loaded, the left sidebar has search functionality that can filter a specific process in mind, choose the image path, and the session GUID or GUID. What a GUID? Who even says that? The session GUID to render the mapped view. So this one seems to be a little bit more functional than the Timeline Explorer. And I can't wait to actually use it and see what we got. So this tool can easily view the correlated events from a specific process. The example above summarizes all Sysmon events related to the explorer.exe, which is what we see right here, the explorer.exe and the path for it. And then it gives us all of the events that have been correlated, which is actually kind of cool. So I like this tool already. So this tool does that. Okay, great. So we talked about that. So what is the SHA-256 hash of the captured pcap.ng file? So this is actually up here. So I'm not going to run the command. We should already be able to access this 256 hash. I hope this is actually the value. Otherwise, I have to run the event and confirm that that is it. And if the value has changed, that means that somebody tampered with the file. So there we go. All right, so that's correct, but we also do need to get the Sysmon evtx and the Windows evtx file hash values. So we do get to actually run that command. So I'm going to open up PowerShell on our machine here. And what we need to do is, where's the files located? It's inside of the, incident files. So that's where we're trying to go. I need to let PowerShell load because apparently it's taking its sweet time here. So this is what we're going to do. We're going to open this in full screen mode, and then we're going to minimize it here. And then what I'm going to do is I'm going to open this link in a secondary window, or my secondary monitor, excuse me, so I can still read through the instructions while I am navigating everything on our terminal here on our full screen. And it still hasn't loaded. That's crazy that it's taking so long for the PowerShell tool to actually load. It's kind of mind-boggling, my friend. Okay, so we're just gonna give, oh, you know what? I think I might need to allow it to do something. Maybe that's what it is. All right, so we're gonna give it a second for it to load, and we'll get right into it as soon as it actually loads. Cool, so it is officially loaded, and we actually have it on our screen. So let's zoom in on this bad boy a little bit so we can see what's going on. So this is what we got. We got the LS of this particular location. So I need to go into the desktop, I believe, and on the desktop, or let me actually clear the screen. So let's do LS on the desktop, and we have incident files. So we're going to go into the incident files location, do LS over here, and those are our files. So now what we need to do is run that get file hash command and get the SHA-256 of the two evtx files that we have over here. So let's do that. Okay, well, I tried to be clever with it, and I tried to do both of them at the same time, but it didn't work. So what I'm going to do is I'm going to try it one more time to do them together, and then I'm going to separate them by commas. And if that doesn't work, then I have to do it individually. So let's run that one more time, actually, and see if we can separate them by commas for it to work. And it does work. Okay, great. So if you separate them by commas, then it works. So here we go. What is it? SHA-256 of the first path. Okay. I need to know what this actually is. That's the part that's interesting. Okay. So I'm going to assume that the first one is the sysmon evtx, and then the next one would be the Windows, because it doesn't give me the full path. That's kind of interesting. That's actually annoying a little bit. So we will, Control C, and that should be copy. So let's go over there and see if that works. And paste that. Okay, cool. So let's try that. All right, yes, that is exactly the hash value for sysmon. And then we're gonna copy this bad boy, and then Control C, go over here and do the paste, and voila. Cool. So we got all of the hash values that we needed. So now we need to do the initial access for the malicious document. So we need to look at that event. And I'm going to zoom in on this a little bit to make life easier for us to read these things. So we are now officially the incident responder from an alert that was triaged by one of the Security Operations Center analysts, and they've confirmed that the alert has a critical severity, which means it's really important and we need to address it immediately. As reported by the SOC analyst, the intrusion started from a malicious document. In addition, the analyst compiled the essential information generated by the alert as this. So we have malicious document has a doc extension. The user downloaded the malicious document via Chrome, and the malicious document then executed a chain of commands to attain code execution. To aid with this, you may refer to the cheat sheet crafted by the team applicable to the scenario. So start with the events generated by sysmon, then Timeline Explorer. So evtx ecmd Timeline Explorer, then sysmon view can interpret the sysmon logs, follow the child processes of WinWord, then use filters like parent process ID or process ID to correlate the relationship. And we can focus on sysmon events like the process creation and DNS queries to correlate the activity generated by the malicious document. Significant data sources would be sysmon. So the user of this machine was compromised by a malicious document. What's the file name? What is the name of the compromised user and machine? What is the PID of the Microsoft Word process that opened the malicious document? Based on sysmon logs, what is the IPv4 address resolved by the malicious domain? And what is the base64 encoded string in the malicious payload executed by the document? What is the CVE number of the exploit used by the attacker to achieve a remote code execution? And that is the last question for this particular segment. So I have all of these things open on my second monitor. So we're going to go in this location here. We're going to clear our PowerShell, and we're going to open up our incident files. There are a couple of things that we do have to do, right? So remember, we need to convert them into CSV files so that we can use them, etc., etc. So the first thing that we need to do to be able to convert them was using the evtx ecmd to actually convert the file into a CSV file. And that was a command, if you remember, that they shared with us. So I'm already inside of the incident files folder inside of the PowerShell window. So I'm just going to pull up the evtx ecmd command, which is it's fairly simple, but it's a pretty long command. So let me go ahead and pull that up on my second monitor, and then we'll run it over here. And then we should get a CSV file for each one of our evtx files. Actually, so we need to be inside of the tools directory that has the evtx ecmd directory inside of it. So I'm already in here, and then we can see that we have the executable for that. And so now we're going to run it, the command here. So it's going to be dot. Okay, so there we go. There's our command, and now it's working. So let's see here. I mean, it should be fine. So let's see, CSV output will be saved to this location, and it's going through the motions. I don't know how long this is going to take. So let's see how long this actually ends up taking. Okay, so it only took 176 seconds because when you get to the first portion right here where it says CSV output will be saved, I guess you still need to press enter. So I did not press enter until like literally 5 seconds ago, 10 seconds ago. And then when I did press enter, the rest of this took a very short, it just took a few seconds. So just keep that in mind. You do have to press enter when you get prompted. The CSV output will be saved to, etc. So this is the first one. This is the first file that we converted into CSV. And then what we're going to do is we're going to, because I'm pretty sure we're going to end up needing it for the next few tasks, is I'm going to convert the next file as well. So let's now convert the next file, which is going to be our, what's the name of the file? I already forgot the name of the file. The Windows EBTX. So we just converted sysmon EBTX. Now we're going to convert the Windows EBTX file. And we could just do this. We can press up on our command, and then we can go ahead and change this name into Windows. And then we can go, whoops. So you do need to, let's see. You can't press up again. You have to actually press back on this thing. So we're going to do back, and then we're going to go and deal with this file, and it's going to be Windows, like that. There we go. And so that's going to start, and then so there you go. That one did it automatically. That's so weird. Okay, so I mean the first one I had to press enter, but this one automatically did it, and it took 2.3 seconds. So much faster than 176 seconds. Okay, so cool. Now I actually have my file converted into a CSV file. So since we're only dealing with the sysmon file for this series of questions, what I'm going to do is the first thing that I'm going to do is I'm just going to open it up in the Timeline Explorer, and I'm going to open it up in sysmon view and see what we can actually find about this data. I'm going to try to open them up both at the same time to kind of just try to save some time. Hopefully the computer or the virtual machine that we're in can actually handle it. So let's see how that ends up working. Here we go. These are our files that we have over here. So first we're going to open up the tools. We'll open up a new window, which is going to be the one that will access all of our tools from. So I'll go into, what do we got? This PC. We're going to go into the local disk. We're going to go into the users. Then we're going to go into user. And then we're going to go into the tools. Where's the tools? Oh, you know what? My bad. So it's actually, we got to go to local disk, and it's right here. So you don't go to users. You go to local disk, and then you go to tools. And then here are all of their tools. So we're going to do Timeline Explorer, and we're going to open up the Timeline Explorer, and then I'm going to go back to tools, and then we'll go to sysmon view, and we'll open up sysmon view. So I'm going to open both of them up at the same time. Let's see if this is going to crash the VM that we're on. Okay, that wasn't that bad. So sysmon view opened up literally within like 2 or 3 seconds after that. And then in the background, I have Timeline Viewer or Timeline Explorer that opened up. So now we're going to do this, right? We're going to click File, we're going to open it, and then we're going to go into the this PC, and then we're going to track down our user because all of our incident files are on the desktop of the user. And then we're going to open up the sysmon CSV inside of the Timeline Explorer. And I think we are supposed to also use the CSV version of the file to go to sysmon view. I wonder if that's what they did. So let me review that real quick. No, actually, so in order to be able to make it viewable for sysmon view, we need to open up the log file inside of event viewer, and then from there we can convert it into XML format. So that's the piece that we have to do. I am curious if we can just use the EBTX ECMD to convert it into an XML format. So let me see if that exists, because if that does exist, I think it would be faster to just convert it into XML via the command line. Okay, so it seems like we can actually do that. So I'm just going to open up my PowerShell one more time, and we're going to go back into the EBTX tool that we used recently. So let's do this. I'm going to clear the screen so we can go back to the top of the screen real quick, and then we'll run the command that we had right here. So this is the last command that we had, and we'll actually even go up one more because that's the one that we used for the sysmon file. So the first part is going to be the same, right? So we're just going to use this as our reference file, which is evtx, and then instead of turning it into CSV, we're just going to turn it into an XML file. So right here, I'm going to do XML as the extension. And then for here, we're going to, I think the main thing that we need to do, let's see, we'll do this just to make sure. I think, let me zoom out a little bit to make it a little bit easier. Instead of it being a CSV file, it would be an XML file like that. And then the location would still be the same, and the output format right here is going to just say XML. So let's try that. Let's see if that actually works. Okay, cool. So that actually worked. So what do we have? We do have the sysmon XML file, and it's been saved accordingly. So the command was very similar to the last one. The only thing that I modified was that instead of CSV over here, it says --XML. So we're still referencing the original file being exactly the same as the last time. Format output is going to be XML. The location is still going to be the path that we want. And this right here is the last piece. So it's kind of hard to see it, but it says --XMLF. So originally it was CSVF, but we're going to do XMLF for an XML file, and then we're going to give it the sysmon.xml name. And then if we go into our file explorer, we should actually be able to see the XMLF availability here, which is this file right here. So it says XML document, boom. So that's cool. So now for PowerShell, or no, excuse me, where was it? It was the timeline explorer. It's already loaded as a CSV for sysmon view. I'm just going to go here and I'm going to import an event log, and we're going to do it in XML format. So let's see if we got it. That would be cool if it did indeed work and it made it fairly simple, because I think it's faster when you can do things inside of the command line. So desktop incident files, there is the XML file, and we open that, and easy money. Look at that. This operation may take some time depending on the size of the file. Cool, no problem. Import. All right, so we're gonna let that, I mean, that was it. It's like fast. Logon UI exe. So if I click on that, and then let's say click on that as well, and then click on this, it'll open this up for me. And there's no other information here. If we do the map view, we don't, that's an actual map. If we do an all event view, it's just a one line item. And if I do hierarchy view, nothing. So the main view is the process view that we want. And so this is what we got. So logon UI.exe, Tempest, summary of events, process creation, etc. So what was the question here? So it says, let's see, malicious document. There should be a question that has to do with the file, right? So it says, by a malicious document, what's the name of the document? It can't be the logon UI.exe. I don't think that's it. Based on that, what's the malicious domain? Base64 encoded CSV number. Okay, so none of these things are actually relevant to us. Winlog.exe might be the executable, so I'm going to try that to see if that is the name of it. But again, I don't think, no, it's not. I don't think it is, because it's too short for the answer that they're looking for, so we can just automatically assume that that's not it. Now, let's see if there's any more data. Boom. Actually, there's a lot of data. Great. So we do have a lot of data with each one of these things. So we do want, what do we want? We want a PID of the Microsoft Word document that is open. So we are looking for a doc, right? So it has a .doc extension. So let's see if any of that information is useful here, or if I can find it. So I'm just gonna kind of like click around and try to find any information that I possibly can. And then from there, we'll try to come back and see what we can do. Okay, so nothing so far. There are some commands there is a command line element that's actually useful here. We do have a SHA hash value. We have an import hash value, a parent process GUID parent process, but these all have to do with the individual winlog exe, which is not the specific item that we're looking for here. So it says, what is the PID of the Microsoft Word process that opened up the malicious document? So this is definitely not what we're looking for in this case. I think these are going to be useful to us. I just don't think they're going to be useful to us right now. So we're going to go to the timeline viewer here, and I will expand this so we can see things a little bit easier. So we can search for anything. So what I'm going to do is I'm going to do .doc, and I'm going to press enter and see if there's anything that shows up. Okay, so we have several elements or several line items that actually have shown on. So the provider is Microsoft Windows Sysmon, channel, process ID is 2800, computer is Tempest, user ID is this guy. Let's see what else we find if we go down the line here. We have file creation, user name, payload data, and what else? Payload data part 2, payload data part 3, payload data 4, 5, 6, executable info. Ooh, we're getting close. We're getting some good information. And then source file, payload itself in entirety, which is a very long thing. Okay, so let's see. So let's look at some of this data here. So we first and foremost, we just want to find that file name. So payload data part 1 doesn't really give us much. Payload data part 2, if we expand it, still doesn't give us much. Payload data part 3, if we expand it, gives us some file names and some executable names. It gives us some paths, and we are looking for that doc extension. So let me see. I'm going to try to track it down, and I'll tell you where it is. Okay, so here are all of the docs. It's under payload data 4, and it's literally the very first one that says users Benny Maru downloads free magicules or magicules.doc, and we have a couple of other doc files, but I feel like this is the one. So if we actually go ahead and input that, I already input it, and I know for a fact that it is the one because I wanted to make sure that that's the right answer. So that is indeed the right answer that we're looking for. So it is free magicules or magicules, whatever, .doc. That's the first answer. So it says, what is the name of the compromised user and machine? And that's also in that same path that we just had, which is Ben Imaru. I believe that's their user. So users Ben Imaru. So let's see if that works. Imaru. It's not. So it's format is username and then the machine name. So it would be Ben Imaru dash something something. So we need to find his machine name real quick. Oh, Tempest. I think his machine name is actually Tempest. So let's do Ben Imaru dash Tempest. Yep, that's the machine name. Okay, cool. So Tempest was his machine name. Let's see if we can actually find that information over here so that you know where it is. I mean, I kind of deduced it because at the very beginning of this exercise, they did say that we were working on the compromised machine, which was Tempest. And so this is what we have. So Tempest Ben Imaru. Tempest is the host name, Ben Imaru is the username. And so that is how you get the format that they gave us, because they just said username and then dash machine name. And that's the one that we got. So Ben Imaru Tempest. Now it says, what is the PID of the Microsoft Word process that opened the malicious document? So this is the next thing that we want to look for. So we have event record ID, event ID, provider, process IDs right here. So 2800 is these processes that we have over here, but I don't think it's any of those because that actually is not relevant to what we're looking for here. So what we're going to do is we're now going to kind of expand our search, or narrow down our search, I should say. So we're going to do free _ magicules.doc as our search, and let's see what we can find. So now we have a narrowed down data, and so payload number 4 is the one that gives us everything over here. Parent process is what we have, payload data right here. So let's see what we can find in this location. These are all the hash values. Parent process ID 6596, parent process ID itself. So let's see what we can find with this information. Again, I'm just gonna roam around a little bit and see what I can find for you. Under payload data 3, we actually see all of the executables or the images of the programs that ran them. And there's one down here that is a Microsoft Office program, which is the WinWord executable. And so if you go, where is the location? There's a specific payload there right here. So payload data number 1, that actually gives us the process ID and then the process GUID, etc. So the process ID for the WinWord executable is 496. So let's try that to see if that actually works. And that is indeed the process ID. Great. So now based on the sysmon logs, what is the IPv4 address that's been resolved by the malicious domain used in the previous question? So now what we need to see is where this thing was downloaded from. So that's the thing that is interesting to us. So he used Chrome executable to actually download it, but we need to see where this thing was downloaded from. So we are looking for some DNS data here and potential command line items or maybe activities that have to do with DNS data. Okay, so at first I started with the search term download, but then it actually leads us to this series of events over here under map description. And so we have network connection and DNS event or DNS query. So the thing that I'm curious about is the network connection part, because the network connection is what led to me seeing an IP address. So if we just narrow it down by network connection, and then we go down to the payload section, so it's payload data 4. This payload data section gives us a series of IP addresses, and they're exactly the same IP address. So it says source IP, so I do wonder if it's actually talking about the IP address of Ben Imaru. But I do want to try out this IP address to see if that is the IP address that potentially made that connection. And let's see, so 192.168.254.107, and that is not the IP address. Okay, so that's not the one that we're looking for. Based on the sysmon logs, what is the IPv4 address resolved by the malicious domain used in the previous question? So the next thing that we would be doing then is we would be searching for DNS query. So let's do DNS real quick. And then so we have what, Fish Team XYZ, we have YouTube accounts, Google suggest queries. I feel like it's Fish Team. I feel like that's literally the domain that we need to talk about. There's also Resolve Cyber XYZ. I'm gonna take a guess here, and I'm gonna say that it's the Fish Team domain. That would be something that we would be interested in. So let's see if we can find anything relevant to that domain. So if we do a search for fishteam.xyz, we actually get a connection to the query as well as the file, the free magicules doc zone identifier, target file name, and a few other connections here that we had, PowerShell executions, query name, etc. So now we're looking for an IP address in all of this payload data. So if you know what an IP address looks like, you should be able to spot it pretty quickly. I wish I knew if there were ways to we can fine tune our search queries, to see if we can actually potentially combine, Fish Team XYZ with an IP address kind of a formatting. That would be very, very useful if that was indeed possible. But in this particular case, I feel like we cannot do that. So we're going to go and search through our various payload data and see if we can find any kind of IP address. So it would be, so payload data 5 shows us the process IDs and data like that. Payload data 6 actually gives us what looks like IPv6 addresses as well as what looks like an IPv4 address. So we have 167.7.1.1.9.1. So I'm going to try that one. I'm going to try the 167.7.1 address, and let's see if that is indeed the case. Yep, that is the address. So we got there, right? We had to first I looked for network connections, and then I looked for the DNS queries. And then based on DNS queries, we saw this domain name that is very fishy, no pun intended. And then when we search for that domain name, we're able to see the various queries that were made for that domain. And then looking under the payload data, we were able to see that there was an IP address that was connected to it. So excellent. We now have that answered. Now, It says, what is the base64 encoded string in the malicious payload executed by the document? So now we need to actually see the command that was ran and then the base64 encoding of the payload for that. So now we're going to go back to the, what was it? I think it was like free magicules. That was the name, right? Yeah, freemagicules.doc. And then from there, we need to find the payload that's connected to that actually has a base64 encoding. So we're going to search for this again. And so we do have a payload or a series of payloads that are over here. And there is a variety of data that we can look for to be able to find that information. So payload data available, payload data 2, nothing in here. Payload data 3 doesn't have anything. It does have the hash values over here that are interesting, but it's not encoded data. We're looking for base64 encoded data. Payload data 5 section also has a bunch of hash values, and there's a target object location, and inside of this, let's see, there's nothing that seems like the hash value. So if we go through the command line, we free magicule source file, and then we have the full payload data over here that potentially may have the base 64 encoding in there. So I do have to rummage through this a little bit and see if I can find anything of note. Okay, so here's where we ended up with this specific item. So I went through a few different search phrases, and the answer was actually like the most obvious. So let me make sure I renew my machine here. So it's pretty much inside of the answer. So or inside of the question, excuse me. It says, what is the base64 encoded string? So I searched for a bunch of different things, but the one thing that I should have searched for at the very, very beginning, which is again like the most obvious piece of this, is base64. Excuse me. So when you search for base64, there's literally one item that shows up, and that one item that shows up, if you go under executable info, there is this whole tab right here that, I mean, there's a lot of data. So one of the things that you can do, instead of dragging it all the way out, you could just double click on this and it'll open the entire thing for you. And inside of this whole element that you see right here is all a part of that executable or that command that was executed. Now, if you never have seen anything that's base64 encoding, usually I look for these double equal signs, and then it's always inside of some kind of a quotation. So you see that there's a single quote right here. So if we follow this and then we basically go to the beginning of that single quote, this is what we end up with. So this full thing is a base64 encoded element. So if I copy this, I am fairly certain that that is the base64 element that they are looking for. So let's submit that. And that is indeed the answer. So literally the answer was like so simple to search for. And I went through a bunch of different search phrases, and it just happened to be that base64 was the one thing that I should have searched for that will end up giving you a single item. And then when you go under executable, you can just look at all of this data right here, and then we can see that this is the piece right here. So the last question that they have for this section is, what is the CVE number of the exploit that is used by the attacker to achieve a remote code execution? So this is the piece that might be interesting to us. So the hint says, external search needed. Observe the parent-child relationship of WinWord and the process that executed the malicious base64 payload. So what is the process that executed the malicious base64 payload, and then the connection of that to WinWord? And then we'll have to do some external searching here to see what that may be. Okay, so the process that executed the payload. So first of all, this itself is the payload. So if we actually copy this, right, and if we go to a tool like CyberChef, which I have open right here, and I already pasted it in there, it'll decode it for us. So if we have from base64 encoding, and then we just drop that encoded portion in there, it'll decode it for us, and this is what we'll get. So this is basically a series of commands that run inside of PowerShell, and you know they go into the Microsoft Windows Start menu program startup directory, and inside of that they download this file from the Fish Team XYZ website, which is the update zip folder. They output it into the update.zip, and then they expand the archive, meaning extract whatever is inside of it. They go into it, and ultimately they will remove it to kind of try to erase their tracks so that we don't see that anything was downloaded in there. So that's the portion in here that's highlighted right here. That's the everything that we just saw is this portion, which is base 64. So technically that's what's executed. Now we need to find the thing that executes that element, and that is done here. So this is the MSDT executable, and this is actually a legitimate executable inside of Microsoft. And so I did a little bit of research on that just to see what it is. And MSDT allows arbitrary code execution via the MS-MSDT protocol handler, which is this piece right you see right here. So these two elements are the elements that actually allow for remote code execution, but they are legitimate elements of Windows. So MSDT is the Microsoft Support Diagnostic Tool. That's what MSDT stands for. And the protocol handler is what allows the commands to be passed to MSDT. So meaning the MS-MSDT portion, this piece right here, this is what allows the commands to be passed to the support diagnostic tool via a URL. And then this specifically, this piece right here is referring to the troubleshooting wizard. And this series of commands that we can see, these are the ones that help to execute the rest of the commands that you see here, right? So inside of this parameter portion, from here to, where does it go? I think it goes all the way to this element right here. So from the highlighted portion that you see right here, this is the element into which the payload is actually injected, and then we have the text encoded. So all of this stuff that you see right here, these pieces are the portions of it that help with the formatting of what is about to be pasted into it. So it'll take the text encoding, UTF-8, which is another formatting. UTF-8 is encoding or formatting. I'm trying to figure out what the proper word for that is, but it has to do with formatting and encoding. And then it's converting, and then it's converting it from base 64, and then he pastes the base 64 portion into here. So all of this essentially allows for the system to process the base 64, and it's going to convert it from base 64 into normal PowerShell command, so that this helps to bypass the intrusion detection, essentially, because if he actually did inject the PowerShell command in plain text, so to speak, into this, the system would have an easier time to detect that, hey, listen, somebody's running PowerShell in here and they're downloading this file and then they're doing all this stuff. So, and then this last portion right here is whoever the hacker is, he's trying to just basically kind of cover his tracks by making it seem like he's just running a normal Windows process. So it's called obfuscation, right? So he wants to obfuscate his true intentions, and it's designed to make it look like he's trying to interact with a legitimate Microsoft file. So this whole piece, and it actually goes all the way up here too. So like this whole piece right here, the /./ this whole thing makes it seem like he's actually trying to interact with a legitimate Microsoft executable or a Microsoft file. This is where the actual exploit is, and then this is the element that is helping him to launch the exploit, to actually run the exploit. And so the question is asking us, what is the, let's go back down here. The question is asking us, what is the CVE number of the exploit that's used by the attacker to achieve a remote code execution? So basically what we need to do is just do a little bit of homework on any exploits that run MSDT exe and the MS-MSDT. So what we can do for this is we can just go into the CVE database. So we're going to go into the CVE database because we also need to get the CVE number anyway. So we're going to go into the CVE database, and then we're just going to do some searching. So let me close this thing so we can actually go into the search CVE list. And then from this search, we can start doing some different searches to see if we can actually find anything that might be of note to us. And obviously, there's a lot of stuff that's available for MSDT specifically. So let me see if I can do like a combination of searches. It might also be easier to start with Google, because I think Google like allows it to be a little bit easier to kind of do searches like that. So let's see. We still have a really long list of stuff that comes up. So let's see. I think I'm gonna go to Google, I think, for this, and let's see what I can find by using Google as my search mechanism instead of doing the actual CVE database. Okay, so this is what I Googled, right? So I did msdt.exe and then ms-msdt and an exploit vulnerability, and the first series of results that we get have to do with the CVE 2022 30190 and defense in depth variant, and again FortiGuard Microsoft supports. Okay, so I'm gonna try this. I'm gonna try the 2022 30190 as the and here is actually what it's called. It's called Folina. I've heard that name somewhere. So Folina would be the name of the vulnerability itself, but we're interested in the CVE. So we're going to do 2022 30190, and that is the answer. So look at that. We actually got the answer from this. So there it is. So just to kind of walk you through the thought process here, because I don't want to just throw the answers at you. This is one of the big things that I think people appreciate about the content on this channel, is that we work through the logic of how we got to a given answer. So the big thing that we needed to find, number one, was what was the base 64 encoding, right? So this is the last question that we had. What was the base 64 encoded string? And so to be able to find that, we just searched for base 64, and there's only one item that shows up. And then when you go through the payload data of this one line item, you get to the executable info portion, you double click on that cell, and it opens up this cell for you. And then you have all of this data that you get to interact with and work with. And then it becomes a matter of, okay, can you decipher what's happening inside of this data? The one big element that they were looking for was the base 64 encoded version, or the encoded string. So we did that. We found the base 64 encoded string, and that just requires that you can recognize base 64 encoding. Now, if you can't recognize base 64 encoding, what you do is this. You go and you copy this whole thing, and then there's a variety of different tools that can kind of help you extract the data. So if I actually just paste that whole thing in here, you can see right here that the output looks like jargon, because this whole input right here is not base 64 encoded. I know that there is something inside of the CyberChef operations called extract, and then there's a variety of different things that you can extract from this block of text. Now, unfortunately, there's nothing over here that allows us to extract the base 64 encoded element of it, so we would need to find something else. And lucky enough for us, there are so many different tools that are available that can help us actually extract data. For example, Gemini AI or Meta AI or GPT. I only use GPT for like really, really powerful type of commands or prompts if I needed to do some really, really heavy lifting type of stuff. I don't really use it for just basic extraction of stuff, because I don't want to run through credits and kind of get run through all of the credits that are available to me for the more powerful engines. So I'll use that for like really, really heavy lifting type of stuff. But for something like this, we can go to Gemini AI, for example. So we do go to gemini.google.com. And so we come in here and we basically just, I'm going to paste the whole thing in here. and then do a question like, can you see if there is any base64 encoded data in here? And then that's it. And then you do that, and it says, yes, there's base64 encoded data, and this is the base64 encoded portion. And it literally tells you exactly what portion of it is base64, so you can see this full piece right here. That's it, right? So it's not hard to be able to, especially if you don't like recognize something. And you can always use a tool like this to help you extract it. And then ultimately what will happen is that you will learn how to recognize these things. And it is a really long block of text. So it's like this whole piece right here, this whole long thing right here is the base64 encoded portion. Now I would probably actually do this instead of like zooming out all the way like that. I would go to here and I would just go from right below it and I would just highlight the full thing, because you can either just start at the beginning and drag down and it'll highlight the full thing. And then you could even do this, like if you want to guarantee, you can go all the way to like decoded result and to highlight that whole element. And then you can copy that and then you go to base60 or to CyberChef and then you paste it in here. And then all you need to do is you need to delete this extra piece that we also highlighted. And all of a sudden, we see that we have the decoded version. So all of that to say, that's how you find the base64 portion. And then you can see that there's other stuff that's going on in here. And you can literally also copy this whole thing and go to a tool like Gemini again and be like, hey, so tell me what's going on. And what is this command actually doing? And then it can show. So let's see, with just even based on what we asked it says this is designed to download and execute arbitrary code on a victim's machine. The use of the startup folder indicates that the attacker wants to code the run persistently. The URL fish stream is a strong indicator of malicious intent. MSDT is being used to bypass security measures. This is a known exploit. See, there you go. It's already giving you a hint, right? And then from there you can kind of expand on that. And the long string of these characters is trying to navigate to the system32 folder. So that's just very, very basic use of a tool that's available to you that you can use to decipher something if you're not familiar with it. And that's how we got the answer that we got. That's how we kind of narrowed down and worked through the logic to try to find our answer. Now we can move on to the initial access for stage 2. Based on the initial findings that we just finished, we discovered that there's a stage 2 execution. So the document has successfully executed an encoded base64 command. Decoding the string reveals the exact command chain executed by the malicious document, and we already decoded it using CyberChef, so we're a little bit ahead of the game here. With the following discoveries, we may refer again to the cheat sheet to continue with the investigation. The auto start execution reflects the explorer.exe as its apparent process ID. Child processes of Explorer within the event timeframe could be significant, and the process creation, event ID 1, and file creation, event ID 11, succeeding the document execution are worth checking. The data sources are still the sysmon. And now we have our questions here. So we have a shorter list of questions. The malicious execution of the payload wrote a file on the system. What is the full target of the path of the payload? The implanted payload executes once the user logs into the machine. What is the executed command upon a successful login of the compromised user? Based on sysmon logs, what is the SHA-256 hash of the malicious binary downloaded for stage 2? And the stage 2 payload downloaded establishes a connection to a C2 server. What is the domain and port that is used by the attacker? So let's start from the top here. It says malicious execution wrote a file on the system. What is the full target, full path of that file? So we actually already have that, and the full path of the file would most likely, I wonder if they're asking for the website path. It seems like it's not. So let's see. Okay, so let's see what's the hint. The hint says the app data environment variable can be simplified. The app data environment variable can be simplified. Okay, so we're talking about a writing of a file of the system, and that is file creation. So when a file is created, it invokes event ID number 11. So let's see if I can do something like this. So let's do event, and if we do event, we can see what the event queries are, and I'm interested in the event ID. So let's see what the syntax of the actual thing is. If we look for something that has event ID, something associated with it, I'm very curious to see what that looks like. So first, let's see if we can find the syntax of what it looks like when there's an event ID in place. Okay, so I wasn't able to find anything by the specific event ID because it doesn't there's nothing called event ID specifically, and then I tried different variations of it. I tried event ID 11, etc. But there is something called file create, which is the map of the process that we're interested in, because we are trying to track down file creation, and we can go ahead through the various IDs, or not the IDs, excuse me, the various parameters, the attributes that we can find here, to see what other data that we can pull from these things. So file creation or file create would most likely be the thing that we are interested in. And so I'll do this. I'm going to hone in on this. I will do file create only, so we actually get all of the file create events. And now we have all of the file create events that we see right here. And there is a way that you can do multiple filtering. I just learned this by kind of doing a little bit of research on this freaking Timeline Explorer tool. So if we go to file, tools, if we go to tools, we can technically, I think we can create like a bunch of different types of filters. And we can do it, if we just do find, I think it ends up being an extra layer of filtering that we can basically put in here. So if we go through this, and then now let's see, because we know that it's going to be inside of the startup directory. If he wants to do some kind of, there we go, sysmon startup term shows up 2 times. Okay, so show it to me. Can you expand this for me or what? Okay, there you go. So you just double click on the 2 and hopefully it'll open it up for you. So now we have 2 filters, or I guess no, it changed the find element up here to startup. So that part is not what I thought it was. I thought it was going to do both of the filters at the same time. And so it removed file create that was originally up here, and it replaced it with startup. But I mean, it's still okay, because technically now we just have 2 results that we need to filter through. And the question now is, what is the question? It says it wrote a file to the system. What is the full target path of the payload? So essentially, where did it write the file to the system? And so that's what we want. Target file name is most likely the answer. And this seems to be the full path. So let's see if this is actually it. Okay, and submit, and that is indeed the answer. Okay, so the target path, and again, the logic for this was it's creating a file, and that's kind of where it started. They're going to go inside of the startup folder to maintain persistence. So where was that element? I saw it somewhere. But it was something that said that they're gonna be inside of the startup folder to be able to maintain persistence, or to stay inside of the system. And that is the thing that led me to believe that this is what potentially could be the case. Now, I started with file creation, or I started with event ID 11. That didn't do anything. Then I went into file create, and then that helped me find that. And then from there, I looked for startup, and then that gave me the 2 events that we were able to find the actual target file location for it. Oh, it was actually inside of the Gemini key observation. So that's where I got the startup from. So the use of the startup folder indicates that the attacker wants the code to run persistently. So that's where that thing kind of was planted into my head. So we went into startup. So that's how we found that specific path. Now it says the implanted payload executes once the user logs into the machine. What is the executed command upon a successful login of the compromised user? Okay, finally learned how to create multiple filters. Okay, so there's a section at the bottom right here, and I didn't manually enter this, but we can also see what it looks like when you combine them using this filter portion down here. But basically what I did was this, right? So when you go to any column, there's this little icon right here that looks like a funnel. And if you click on that icon, it opens up this new little pop-up. And then from here, you can essentially search for whatever value that is inside of this column that you can add as your filter. So we are interested in the Explorer, right? So it says a child process of Explorer within the event time frame. We're also going to look for the process creation IDs or the file creation IDs. So process creation in this case, since we're going to be executing something, that means there is a process that's going to be starting. So with that, we are going to look for process creation as one of the filters, and then we're going to look at Explorer as one of the other filters. And then we already know who the user was because we looked at it at the very, very beginning, and the user's host and where is it right here? So we had the username and the machine name. Benimaru was the user. So we know these three elements. So we're going to go to the payload data where it has all of the parent processes, and then we're going to filter for Explorer. And then we would come to the element, which was, what is the other, let me see, what was the other one that we did? Username. So we go to username, and then we're going to select for username, and then we're going to select Benimaru for that username filter. And then for the map description is where all of the different processes were, and we click on that. And then we have a bunch of different processes that we can choose from. In this particular case, I chose process creation as the very first thing, and then I narrowed down as I went forward. So I started with process creation, then I added Benimaru, and then finally I went to the payload for portion that actually had our parent process, and I chose Explorer. Now, having all of these filters at the bottom right here, having all of these filters added, we can then look through a very small set of events that we can hopefully be able to find some information here. So now it says, the implanted payload, what is the executed command upon a successful login? So of course we're going to go to executable portion right here. And so upon a successful login, what is the command that is executed? So let's see what we can find with all of these the executions that we have over here. And I mean, really, honestly, when you look at it upon first glance, really the only thing that even seems fishy is the PowerShell one over here. And OneDrive is fine, VM tools is fine, security health, systray, OneDrive again, VM tools, health tray. So all at Chrome, those all seem fine. It's this thing right here that just seems fishy as hell. So we have the Windows system, Windows PowerShell. It's executing, it's hidden. So yeah, that's definitely very, very fishy because the window itself is in hidden mode, meaning you don't see a pop-up. You don't actually see anything running. And so if that is indeed the case, and of course it's executing the thing from Fish Team XYZ website. So this would be the command. I want to say, I think it's the full thing that we have over here. Let's see what the format is. So let's say we're going to use all of this. I want to say, let's see if it is this full thing. If it's not, we'll try to break it down, but I'm pretty sure that's the full command that they're looking for here. Okay, so this is the only modification you have to make. You need to just remove the quotes that are at the beginning and end of this first portion, and then everything else stays the same. So basically I just copied this whole thing, this whole piece right here, and I went to CyberChef and I edited it inside of CyberChef, and I just removed the starting quote and the end quote for this first portion, and then the rest of it I left exactly the same, and that was the answer that we had over here. So that's all good. So now it says, based on the sysmall logs, what is the SHA-256 hash of the malicious binary that was downloaded for the stage 2 execution? So the malicious binary is this guy right here, the first.exe. I want to say that's the actual malicious binary that was downloaded, it seems. So what we're trying to do is we're trying to find the hash value of this thing. Now, I do know that there's actually a portion of this that gives us the hash value stuff. So this is all hash values here. And so I'm just gonna real quick, just kind of hoping for the best here. I'm gonna take this SHA-256 hash, and maybe that's the answer, or maybe we have to do a little bit more research, but okay, that's not the answer. It was too good. It was too easy to. So we are going to, we need to hunt down, I think it's that first exe. That would be the thing. So let's go and see if we can find the hash for it. Okay, so I searched for first exe at the very top right there, and then I'm going to go to my map description here and do my little filter right there. And then we're going to do process creation as our filter. And so these are the items that show up. And so we are interested in the hash value. And I think it would be the stuff that's available over here. Now, interestingly enough, we are interested in I want to say we're interested in the child process, right? I don't think we're interested in the parent process. The parent process would not be the first exe anyway. It would be the actual child process. So that's the one that we're trying to find the executable information for. So let's see. We have this is really the only one that actually has the executable right here running just by itself as an execution. This is the PowerShell command. This is a cert utility command. This is the only one that actually has the executable running by itself. Excuse me. It's the only one that has the executable running by itself. The rest of them don't even have it inside of the executable portion. So I'm going to say it's this one. So I'm going to highlight this whole row right there. And if we come over here, we have the hash values in there. Open this up, and we're going to grab this. And fingers crossed. Let's see if this is actually value. Cool. All right. That was the value. And so basically all I did, first.exe, and then I went to the map description column, and I just changed map description into process creation. And then from there, we looked at the only one that actually has under the executable, the first exe just running by itself, because these are technically the parent process here is PowerShell. And then this one, the cert utility would be the, all right, I'm kind of confused. I don't know if this is the, like cert util in this case would be the parent process or the child process. But just to be like extra sure, you just say, okay, well, this is the only one that is actually running the executable just by itself. So we have stage 2 payload downloaded, establish a connection to a C2 server. What is the domain and port that is used by the attacker? Okay, so going back to these guys right here. So they just downloaded, right? They downloaded and established a C2 connection. What is the domain that's been used? So if we look at our executables here again, users Benimaru download chexe, download first exe, and let's see if we go to the parent process portion right here. So let's go to parent process portion, and we'll filter the parent process. So I'll go and click the filter button, and I want the first exe to be inside of my parent, and close that out. Okay, so there we go. Now first exe is our parent, and this is the executable that was launched. And when this is launched, it downloads something, right? So when that's launched and it downloads something, then our executables now have changed a little bit. So we have who am I? He's doing reconnaissance, right? Net users, he's doing like reconnaissance. Local group administrators, user Benimaru, all these is recon, right? So he wants to know who he is as the user. He wants to know who the list of the users are, who's inside of the administrators group, and the user Benimaru seems like he's actually switching himself to the user Benimaru. And then finally he launches this thing. So the user Benimaru now downloads this ch.exe, and it's downloading it on this specific IP address, or I think the client itself would be the IP address of Benimaru's machine. So now we want to see what we can do. So if we go look at, let's see, so I'm going to actually clear this filter, or clear these filters real quick right here, and we still do have, we have first exe still going up over here. So now what we want is to see if there's anything that we can look at for potential DNS queries, because they are making a web request. Interesting. So look at this. We already have a domain name over here. So under queries, this is under payload data 4. We have query name resolver, or resolvecyber.xyz, and it's being done by this image right here. So it's being executed by the first exe, and it's resolvecyber.xyz. So that could be the domain name, and we need the port number. So I mean, it's a guess, so I'm gonna guess, but we can also verify this. But if we do resolvecyber.xyz, or xyz, and then the port number would be 80, because it's the HTTP port. It's like the port that would be running for any kind of internet connection. You know, if you haven't gone through the networking videos, there's Network Plus that was recently launched on this channel. So there's a Network Plus playlist, and all of this stuff is covered. And this is why it's so important to have a strong understanding of networking concepts. But port 80 is the port that is for establishing just HTTP connections and making requests to web servers and websites and the internet at large. And then when you do port 443, it would be the encrypted version of port 80. So it's just HTTPS. So that is the answer. But so there is a way that you can actually do this to kind of confirm this. So if we know that the domain is resolvecyber.xyz, I can go ahead and basically go inside of my incident files folder, and I can go to the pcapture file, the pcap file over here, and it opens up with Wireshark. Now Wireshark, what's nice about Wireshark is that it'll actually create, or not create, but it'll outline everything that's done inside of a packet in detail, and then you can filter through all of the results of the packets that have captured, you know, using a domain name, for example. So from this right here, so we have 21,000 packets that were captured for this specific exercise. And so we can just go up here and we can add a display filter, and the display filter could be an IP address, or it could be a domain name. So resolvecyber.xyz, and I'm just going to press enter, see if that works. It's not going to work because I think it needs to actually be like one of the given attributes that you would search for in here. So there's another way that we can do it, is we can do Control F for find, basically, and then instead of looking for a display filter, I want to look for a string, and then inside of that I'm going to do resolvecyber.xyz, and then I'm going to press find, and it says no packet contained that has that string in its info column. So it's not in its info column. So we're going to look through the various different types of search that we can find, because I know that it has to exist, because if it's inside of the sysmon file, it needs to be inside of this packet capture file. So we need to be able to just find what that connection is and where it exists. So let's see what we can find. So let's see. Okay, cool. So the query itself is actually going to be the http.host contains resolve cyber. Now, the reason for this is that usually if it was just a DNS request or a DNS query, we would be able to narrow down our protocols by DNS, but all of the traffic inside of this packet capture file was either encrypted using HTTPS or TLS, and so we'll see it right here as well. So if we scroll down here, we can see that we only have either HTTP traffic, or that as it progresses downward, and it's a very large file, so I would have to like manually scroll, but it goes to HTTP, and then from HTTP it will go to TCP, transmission control protocol, or it will go into TLS. So let's scroll all the way down here, and we have TLS. And so TLS is encrypted. HTTP is not encrypted. And what is it? TCP also can actually have encryption or encrypted type of data. So that all of those things yield the fact that most likely if you just search for inside of the string value or inside of the information portion right here, if you search for the domain name, you don't get any results, which is exactly what just happened to us. So if we search through the filters based on what I recently did right here, which is the host, the HTTP host containing resolve cyber, and then going through that, it actually does narrow down the results for us, and then it'll point immediately to the packet that would contain that value, and then we can see that we actually have it in the encoded portion right here, where we actually see resolve cyber.xyz, connection keep alive, etc. And then so we would go to the TCP portion of this packet. So all of these packets, this is why Wireshark is so powerful. You get to look at the finer details of every packet that took place. So for example, the MAC addresses that were communicating with each other, the IP addresses that were communicating with each other, and of course the TCP protocol that was used, the source port 51962, which is the port of our source IP, which is Benny Maru's computer, and then the destination IP, which is that malicious IP that we established earlier. Or I don't think it was, I recognize the 16771, but maybe it wasn't 222.162, or maybe it was, but the destination port is for sure port 80, especially if it's going to be on the protocol of HTTP. Let's actually confirm what the destination port or the destination IP was, because we did, so it's 167.171.199.191. So that could potentially be the thing. So I could even narrow it down, but that was the initial connection, and the C2 server would be a different IP address. So it actually makes sense for it to be a different IP address, because the initial connection was when the IP address that we connected to actually download that file. And then when we're in stage 2, we need to establish the C2 connection to a C2 server, and so that C2 server was the resolve cyber XYZ port 80, and there is that. So now we can move on to initial access the malicious document traffic. So I finished this whole thing, and I had the entire recording, and something happened with my external drive that this is being recorded to, and I lost the recording file for the last portion of this thing that we just went through. So I'm going to go through all of this stuff again. Unfortunately, all of the answers have been filled in. So it is what it is. I'm just going to explain everything as we go through it, just so you can see how we got the answer. That's kind of so it's going to be a little bit quick of a breeze, of kind of like a walkthrough. And the nice part is that you're not going to see any of the mistakes that were made, because we're just going to kind of jump right into all of the answers for it. And so we are starting back up from the malicious document traffic portion, or malicious document traffic. I believe that was the last thing. Yeah. So that's the last thing that I'm going to, or this is where we're going to pick up, because this is where the last one left off. So by this point, we have discovered a domain and IP that was invoked by the malicious document. There's another domain and IP that was used by stage 2, logged from the same data. And now we're going to be using Brim and Wireshark to be able to filter the rest of the data. And we're looking for network events that are related to the harvested domains and IP addresses. And this is a simple Brim filter that they provided to us so that we can go ahead and pull this data. Now, the first question is, what is the URL of the malicious payload that's embedded in this document? So I'm going to open Brim back up real quick, and we're looking at the first malicious domain, right? So this was the domain that was used to download the document. So in this field right here, in this filter, we're going to modify it to this piece right here. So I'm going to cut all these things, because this is for later on. And we're going to do the fish team XYZ domain. And then from there, we're going to be able to pull the interactions that were done with that domain. And this is the information that we're most interested in, is the host and the URI. And if anything's being retrieved from a website, we're going to be using the get request method. So if you're retrieving pages from the website, if you're retrieving actual downloads from the website, so all these executables here, the zip file, these are get requests that are downloading the file, and then there's the get request that's trying to access this domain name or index.html to be able to access the rest of the downloads. Excuse me. So there's also the free Magicules document that was also downloaded as well. So the first question here is saying, what is the URL of the payload embedded in the document? And the URL specifically is the HTML. So this is the page from which all of these other things would have been accessed. And so you can see that it's inside of the 02DCF07 path. And then inside of that, we have all of these various paths as well, or all of these different payloads or downloads that we can access from that specific directory. So it would be http://fishteam.xyz/02DCF07 and then /index.html. That's the specific answer that they're looking for, because the links to everything else, all of these other ones are download links. These would be the links that if you visited that combined address, it would download this executable, it would download this one, etc. So that's the first question, is what is the URL of the malicious payload or the malicious payload embedded in the document? Now what we're looking for is what is the encoding that's used by the attacker. So if we went to look at the requests that were being made, we would be able to see certain encodings that would be done, right? So the encoding used by the attacker on the C2 connection. The C2 connection was then done on the other domain name that we had, which was, it was the Resolve Cyber. So that's the domain name that actually had that connection, the C2 command and control connection. So we need to change our HTTP right here to Resolve Cyber, and then we'll be able to see all of the requests that were made to that specific domain. And we pull it up right here, and then you can see a bunch of this stuff. So there's a bunch of get methods, and then these are the requests that are made. So if I highlight this and I copy that, and if I go to CyberChef and I just paste that over here, this first portion is just the path, right? And then this question mark Q equals is the parameter that's been passed on to that URI. So that would be the query essentially that's being sent. So if we just leave it at this, this is what we see right here. This is the actual query that he's sending to our machine, and it's base 64 encoded, right? So we already established that also earlier on in this exercise, where we saw that he was submitting base 64 encoded requests when we were looking at the timeline explorer. So that is the encoding that's used by the attacker, which is base 64. Now the malicious C2 binary sends a payload using a parameter that contains the executed command, and we already talked about that right now as well. So that's the parameter right there. Anything that you see after this question mark, that's essentially a parameter. And then the equal sign means that for this parameter, right, for this Q equals, I want to have this base 64 encoded value. So the parameter will have a value. So Q equals da 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 da. And the parameter in this case is going to be Q. So it's a singular letter that he's using, and that is the parameter for that. Now the malicious C2 binary connects to a specific URL to get the commands to actually be executed. And if you pay attention to this, every single one of these base 64 encoded commands are being sent to the same exact path, the same exact URI. So it's the 9AB62B5. And that is the answer for this question, 9AB62B5. What is the HTTP method? We already talked about that as well. It is the get method that is being used to retrieve all of these commands. And based on the user agent, what programming language was used by the attacker? So we need to scroll a little bit to the right here so that we can actually go to the user agent portion. And so when you get to the user agent column, oh, I went way too far. When you get to the user agent column, you see that there's the HTTP client, and then nym is the HTTP client, and that was the answer in this particular question as well. So real quick, we were able, and this one actually I was able to, when I was recording it live, I was also able to retrieve all of these questions fairly quickly, because Brim does a really good job of kind of compartmentalizing data so you can analyze it quickly. You could have done all of those things on Wireshark as well. Brim just does a pretty decent job of splitting everything into different columns so that you can access the information relatively quickly without running too many queries. So that was the access of the malicious document. Now that he's established all of his access that he needs, now he needs to do some reconnaissance, right? So the internal recon is what he's going to be doing. And so far, we've discovered that there was a malicious binary that continually uses command and control C2 traffic, and we can easily decode it using base64 decoder. And the traffic contains the command and the output that was executed by the attacker. So in this portion, the guide that they give us is to find network and process events connecting to the malicious domain, find network events that contain an encoded command, and then we're going to use Brim to filter all the packets and look for endpoint enumeration commands, since the attacker is already inside of the machine. So now we have this updated query for Brim that we're going to end up modifying to be able to get a little bit more information here. So I'm going to just pull this up on my second monitor so I can type it up real quick, and we're just going to be using the same domain, because this is the official domain that's been used for all of the C2 communications. So we do need the ID response port, which is going to be I'll just start with 8080, or I think 80 was the very first one, and then he establishes a full connection and he runs the rest of his commands on 8080. And then we're going to cut the timestamp, we're going to cut the host, we're going to cut the ID response port, and then we're going to cut the URI, and then we are going to sort it by the timestamp. So we want to see essentially everything in order from when it started happening to later on as the day progressed, right? So this is everything that we have on port 80, and then you can see that there is, for every single URI, there is the base 64 encoded requests that are being made on every single one. So the first question here is, they were able to discover a sensitive file inside the machine. What is the password discovered on the affirmation file? So this was actually something that took me a little while to find, because I literally had to go through every single one of them, but it's essentially a PS1 document that he goes through. A PS1 document is a PowerShell script, and inside of the PowerShell script, whoever had written that script had a there we go, PowerShell, and he's running the, oh no, I'm sorry, he's just using PowerShell in this instance. But inside of the script that he found, somebody had hard-coded the password of the user, and that's how he was able to establish that. So this is the netstat query, because the encoded text was just so long. So I'm just going to go back through these again just so I can find, boom, there we go. So this is the actual PowerShell script, right? So he's concatenating the contents of the PowerShell script to see what's inside of it. And then we can see that there's a user variable, which is Benimaru. And then there's the password for that user, which is the Inferno Tempest. And it's been hard-coded into it. And then, of course, it converts it into a secure string and all of that. But the password has now been encoded or hard-coded into the script, which is it's a big no-no, right? Like when you're doing this, it's much better to give an input command to prompt the user to enter their password, so you don't hard code anything into the script. And this is the reason why, because somebody can go through all of your files and then they'll be like, oh, I found so-and-so's password. So they were able to discover the sensitive file that actually has that password. And then they enumerated the list of listening ports inside the machine. What is the listening port that they used? And I want to say I think it was this one that they used, and we had the response. Nope, that's not it, because it's too short. So it's definitely this one. We see the netstat report that he was able to. Yeah, this is definitely it. And inside of this netstat report, or this command, I guess, that he ran, he found all of the TCP connections, or the TCP port connections that were listening. So these are all of the listening ports for netstat. Now, the way that I was able to find the answers, I literally copied this whole thing And then I went to Gemini and I was like, hey, out of this entire list of stuff, what do you think is a good resource or a good target for somebody to be able to use for remote connection? And so Gemini analyzed that whole thing and it's like, okay, well, there are potentially suspicious ports, which is 5040, 7680, etc. And then there's the less suspicious, but they're still worth investigating. And they're less suspicious because these are legitimate ports. And this is actually, if it's a good hacker, they would use legitimate ports to establish their connection. So, RPC endpoint mapper, it can be exploited. It's generally not a primary choice for C2. SMB, server message block, it's used for file sharing, right? And then we have 5357, which is for web services for devices. And then you have PowerShell remoting. And this person, whoever this person was, pretty much was running PowerShell commands for the rest of their attack and for the rest of their communication with our local machine. So 5985 was just it stood out immediately, and that was indeed the answer that we were able to find. So the listening port that would provide a remote shell inside that machine was that PowerShell remote port, and it actually says it inside of Gemini where it goes, listen, it can be used by attackers. It's also a legitimate tool. If you don't need PowerShell remoting, you should disable this because somebody can connect to it and they could hack you, which is exactly what happened here. The next question is, the attacker then establishes a reverse SOC proxy to access the internal services included hosted inside of the machine. What is the command that was used by the attacker to establish that connection? So for that answer, we go back into our timeline explorer. And for the reverse SOC proxy, so we're going to be going through a series of commands really here, but there is just a way that you can even just kind of filter through this. If you are looking for something that is a SOC proxy, you literally can just type in SOCs, right? And you would be able to find the singular command that was used to establish a reverse SOC proxy. There are a lot of different ways that you can filter through this. You can go through this specific portion where we can look at the payload that was used, which was the first.exe, which was one of the exploits or the payloads that he had downloaded and he ran it. There was also the process creation mechanism that can be used because he was using a process creation event to be able to run that. But the most obvious way to be able to find something like that, especially when you have inside of the information or inside of the question, you've been given a very obvious hint where it's like, okay, they created a SOC proxy. So we need to go ahead and find what that reverse SOC proxy was. And so that's the way that we were able to find it. And I'm going to kind of minimize this a little bit to make it a little bit easier for us to navigate through this. But it's under the executable. Most of the information that we're going to find from here on that has to do with the timeline explorer is going to be inside of the commands that were executed. So this is the command that was executed. We have the ch.exe, which was the executable that he actually ran, and then he connected to the client, which is the IP address of his malicious domain, right? So 171 or 167.71.199.191. This is the one that we found earlier in the exercise, and he did it on port 8080. So essentially every communication after this connection is done on port 8080, and it's of course a reverse SOCs connection, and literally all you do is just search for SOCs and you would be able to find it. So the full path for that, they're saying to remove the double quotes from the log. So you can see right here where it has the quote here and then the quote right there. So if you double click on that, it opens up this whole thing. You can highlight this and copy it, and then and I think you might even be able to, can we modify it in here? We can't modify it in here. So basically what I've been doing, I've just go to my CyberChef because I can paste it in here, and then I just go boom, and then go right there and boom, and then I copy that, and then I bring that as my response for the question. So what is the SHA-256 hash of the binary that was used to establish that reverse SOCs proxy? And that's very, very easy. So on the same exact line, we just scroll a little bit to the left here, and under payload data 3 is where all of the hashes are stored. So we open this thing up, and then you just highlight the value of SHA-256, which is that, and then you copy that, and then you come over here and you paste that, and that would be SHA-256. Now, what is the name of the tool that was used based on that hash? So we'll take the same exact hash and we go to our virus total database, which is a very useful tool. And I did not copy the hash, so let me go ahead and copy the hash real quick. But basically, you literally take any hash value. If you just want to see what it is, you can drop a file in here. You can look at IP addresses. You can look at domain names. So if you drop the hash value of the file, it'll say at the very top that this hash value belongs to this file. And that file could be renamed, which was done in multiple instances. So in this case, it was renamed to first.exe, right? But in the original name is chisel, and you don't need the .exe at the end of it. You could just do chisel, and that would be the answer. And then they used the harvested credentials from the machine based on the succeeding process after the execution of the SOC's proxy. What service did the attacker use to authenticate? So the way that we can find this is we're just going to highlight this line, and we're going to remove the SOC's portion of this, okay? And one of the things that we need to do is we need to organize this by the timestamp. So I'm going to do timestamp created or time created, and then I'm going to go back to my executable portion so I can see the SOC's proxy element of this, right? So what we're looking for is the command that was ran after the fact, right? And there seems to be something else that I may have entered as no. So there is no other element that was entered here, but we do need to narrow it down by our, and I mean, it literally is the next command that does show up anyway, but it would be much more useful if we narrowed it down by the Benimaru user, because we're looking at all of the other users right now. So we'll go to username, we'll click on this filter up here, and then we're going to do Benimaru, and he's actually right there. And there we go, Tempest or source user Tempest, and then I'll just do Tempest Benimaru as well. So all of his commands show up. So there's that. And so now we can go over here and we can look at all of the executables and then just find what was next in line after that SOC's proxy. So I'll do the search for SOCs one more time so we could just narrow it down to that one command. We'll highlight this command and then we'll remove SOCs. And now it's going to be highlighted on our timeline. And the very next command in line, so the succeeding command, that's what they're asking, right? So they're saying the attacker then used the credentials from the machine, and based on the succeeding process after the execution, what service did they use? So this is the succeeding process. This is the very next thing that was done. Now, this is also a legitimate process here. So WSM prov host, that's actually also a legitimate Windows process. So if we go and search to see what is connected to that process, which is, of course, the very next thing that I did. So I went and asked what legitimate Windows process is associated with this executable. And the very first response that came up was Windows Remote Management, also known as WinRM. So Windows Remote Management was used to essentially run the rest of the commands in his exercises or in what he was doing. So WinRM would be the answer for this question. And that, just like that, we have all of the answers for task 7. And now we can move on to the next piece, which is now he's actually doing some privilege escalation. So far, we know that they now have a reverse SOC's proxy and they used WinRM or that WSM, whatever executable. So now we're looking for events that are executed after that execution of the reverse SOC's proxy, and for potential privilege escalation attempts, as the attacker has already established a persistent low privileged access. So we're going to look at the packet capture file, and then we're going to look at sysmon again. So first and foremost, we are discovering the privileges of after discovering the privileges of the current user, the attacker then downloaded another binary to be used for privilege escalation. What is the name and the hash value of that binary? So we're going to go to the timeline explorer, and there needs to, I know I have more than enough time, so I'll just add another hour just for the hell of it. So we're going to go back here, and now we know that the parent process of this is going to be the WSM prov host, etc. So what we want to do is I'm going to go ahead and it would be under parent process. Where is that information? We just need to narrow it down for that parent process. I think it's in this column. No, right here in this column. Parent process would be in payload data 4. So I'm going to go click on that, and we're going to filter it to the SM, whatever that thing is, and it's literally one item that will show up. So there we go. So this is all the stuff that was done with the after the WinRM established connection was done. So then we go back into our executable info, and we can see a few things, right? So first he wants to see what his privileges are as the user that he's logged in, and then he goes and downloads spf.exe from the fish team, and then final.exe from the fish team, and then he runs both of those together, right? So he'll run the spf exe and the final exe, and this is the command that officially will have the hash value for the spf.exe, because these commands are technically going to use the hash value for PowerShell to be able to run for us. So we're going to find the hash value of spf.exe. So then we just highlight that, and then we go to the left, and then we go under the hashes here, open that up, and then we go over here and highlight the SHA-256, and then copy the hash value of that. And then so you go here and you would do spf.exe as the name, comma, the hash value, which is exactly what we found over here. So that's the first question. Then it says, based on the hash value of the binary, what's the name of the tool that was used? So again, we'll go back to VirusTotal, and we'll go here and we'll paste that hash value, and then we'll look for it. And it says print spoofer. printspoofer64.exe is the name of the tool. And so you just need print spoofer, and that's the answer for it. And then it says the tool exploits a specific privilege that's owned by the user. What's the name of the privilege? So to find this, I literally just Googled it, and it was, let's see what we can do. I've completely forgot what the question was, but it was basically print spoofer. Let's do that, and then we'll do print spoofer 64 privilege vulnerability. Let's say that. We'll do that. And based on this, we'll be able to get some information. And specifically, what you're more interested in is the actual print spoofer GitHub page. And from there, right at the very top right here, you'll see that the SE impersonate privilege is what was abused on the computer. And that is the answer. The SE impersonate privilege is what the specific privilege that was exploited, right? It's the impersonation that print spoofer is taking advantage of. Then the attacker executed the tool with another binary to establish that connection, and we already have that over here. It's right next to the command itself, or it's inside of the command itself, which is the final.exe. So he executed this along with that other binary, and that was the final.exe. And the binary connects to a different port from the first C2 connection, and that was port 8080. And we can find that inside of our brim. There we go. So inside of the brim, if I just remove this portion and I only look at the stuff that was done with that C2 server, we can see that there's only two ports that are available. We have port 80, and then we have port 8080 that was done. And essentially all of the commands are run in either of these ports, and then everything that was done on port 80 was before he had that final connection, and then port 8080 is after he had that final connection. You can also just go to the timeline explorer, and then over here we can delete our last filter down here for the payload data to remove that MSMProv host portion, and then we can filter based on 8080 just as the information to see what shows up. And it's again inside of this command where he's using to establish his reverse SOCs connection. So 8080 on his IP address, that's the port number that he's used to establish that connection. If you don't know, if you didn't know what the port was, right? If you didn't know what the connection for that was, there's a few different ways that you could look for it, right? Because you know that he's establishing a SOCs connection, so we could technically just go and look for the SOCs keyword again. Or if you know that the IP address, the original IP address that was his malicious IP address, was the one that he was going to use to establish that reverse connection, we would just go to our initial portion, which was the malicious document. So was it in this location? Yeah. So this is the malicious IP address that was used for that. So we could just highlight this and then go ahead and search for it inside of our file over here, and it would probably show up more than one result, but there is essentially only one result that actually has this command that was executed that's run on port 8080. So there's a few different ways that you can try to find what the port number was that he established that connection. We can go ahead and look at the parent process that was run, which is the process that was used, which in combination with a few different processes that he had originally. So first.exe was that initial established connection. So we do have that somewhere in our responses as well. All of the responses that you've collected so far are hints for you to be able to use when you do the rest of your search. And that's what you should be doing. You should be combining all of the information that you've gathered to be able to be like, oh, okay, you know what, this is what we've used to establish all of our connections. So port 8080 was the port that was established. But the way that I found it originally is I was just looking at Brim, and I just removed that the ID response port filter that was available over here, and I just looked at all the ports that were connected, and there was only 2 ports that were connected via this domain, and it was port 80 and then 8080. So that was it. There's a few different ways that you can find this specific answer. And now finally, we are moving on to what this person did after they had their reverse connection. They had their reverse SOC connection, and they increased their privileges. So now what do they want to do? The attacker now has gained administrative privileges inside the machine. So we need to find all the persistence techniques that they used after they became admin. Now, one of the things that the first time that I was running through all of these commands right here, one of the things that I did, because I had to go through every single one, was find one of the base 64 encoded commands that this person ran, and they were able to log in as an administrator. And what happened is that it was like towards the later portions of these commands where they run the command to log in as an administrator, and they were successful to log in as an administrator. And then they started creating accounts. So, you know, Cheyenne and Shuna were the 2 accounts that this person created after they were logged in as an admin. So if you actually go through every single one of these values, which is time consuming, I understand, but if you go through every single one of them, you get to see that he's running a variety of different commands. And so he's adding Cheyenne and Shuna. And so let's go back a few to see where he was logging in as the admin. But essentially, they have established administrator access by going through the variety of different attempts at login. And then you can see that by going through the timeline explorer, where there's so many attempts to log in to the machine. So who are my privileges for the person, and he's trying to see what the privileges are that he has access to, and etc., etc. So he will go through, or they will go, whoever this person is, they will go through a variety of different attempts to log in as an admin, and then ultimately they'll start using their admin privileges to actually start adding those new users, because if he's created his own users, then he can establish maintenance or persistence, to be able to add these things. So now here's the thing, right? So this is the first few attempts that this person made to try to add the user, but it was not successful because he's missing, or they are missing, I don't know why I feel like I need to say that, but they're missing a very key element of this adding of the users that they haven't added to any of their commands. So it's very interesting that this person is so strong at attempting these hacks and then actually getting, there we go. So the command completed successfully. This is when they actually were able to log in as the administrator, and they were able to get in. They've been able to do all of these things, but they're missing a key element of adding a user. So they get their persistence, they get their escalated privileges, and now they want to make sure that they stay in the system. So we're going to use Brim to filter everything. And again, we're just going to sort through everything like that. So the port in this particular case is going to be port 8080 because they've already established their connection, and the attacker gained a system. So now the context for each malicious execution blends with the authority system. And then the child events of everything that's being done, we are also going to check out to see what happens. So we're going to look at the package capture, sysmon, and of course the Windows event logs as well, because now there's Windows events that are taking place. And for this, instead of going through the Windows event logs, I just Googled the events because it's very easy to find event IDs if you know what you're looking for. So first and foremost, what were the system access that the attacker then created two users with? And this was a little bit towards the bottom right here. I think I can actually even do this. I can do Control Z a few times to go and see the list of the users that they made. And we would be able to see right here. So all of the users were Cheyenne and Shuna. These were the two users that were created. Now, in order to be able to find that, you would literally just go through every single one of these things. And let me kind of just actually do the response port that will equal to 8080 to filter this down just to these events that we have over here. So it's a little bit, it's like almost immediately right after they get their admin login, and from there is when they start creating the accounts. So accounts still right here, you see that they're Cheyenne and Shu or Schumer or whatever their name is. Those names are no longer present here. So what do we have? The BMV0. So let me see, BMV0. This is the longer one. So I'm just going to go through all of these things just to kind of give you the various events that were used to create the new users, because if I show you the last list, so you can see, right, they're trying to create the Shuna user, but they haven't ran the proper command to do it. So they still haven't created the user, but they're trying to create the user. Net user Shuna princess, still nothing. So they're trying to do it. It's just that they're missing a key element. And of course, we're going to be asked about what that key element is to be able to do it. So it tries to do it and looks, and they're like, oh, the user still wasn't created. So every attempt that I've done so far has been unsuccessful to be able to add the user that I want to add. And ultimately they get it right. So now new user Cheyenne MasterChef, and again, they'll probably run to check to see if the user was added. And of course the user won't be added because they were not successful. So if you add a user, you will actually get a notification that you were successful, and it is missing one key element for them to be able to do it. So I'm going to go through these things, and there we go. So net user administrator change password, they were able to actually log in as an admin, and from there they're going to keep attempting to add those users, and I'm going to find the one where they're finally successful because they ran the proper command. This one is still unsuccessful, so I'll find the one that they actually did to successfully add the user. And we know that they want to add Cheyenne and Schumer, or I keep forgetting the second name, but they want to add these users to the list and then modify them for future access so that they can maintain persistence. All right, there we go. So Shuna, not Schumer. So they were missing the /add portion of this command. And finally, they got a command was completed successfully. So they were able to add Shuna, and ultimately they were able to add Cheyenne. And at the very end, we got to see already where they were looking at the list of the users that they wanted, and they were able to find those two users that they added finally, which is right here. We have the net users, and we have Cheyenne and Shuna that were finally added. So this is where we got these answers. You just had to do a little bit of searching, and obviously you're getting the answers if you're watching this, but I do recommend you actually go through that exercise to try to decode some of those base 64 commands, just so you can get it in the cells of your body of what it's like to go through that process. And it is a little bit time consuming, but that is what it is right now. We are not going to talk about using shell scripting or PowerShell scripting to do something like this, but you can actually create a PowerShell script that will sift and sort through those events inside of the PCAP file and look for any given pattern and then replace or remove the element, right? So what it would do is it would essentially extract the base 64 portion of this by looking for this and then removing this, and then everything after this until this portion is going to be the base64 encoded, and then you can use PowerShell to decode that portion. So you can create a script to actually do that for you. It's just beyond the scope of this video, and I don't want to go down the rabbit hole. So these were the users that were used, and now it says the attacker executed commands that failed was the missing option, and that was the /add option. Based on the event logs, the accounts were successfully created. What is the event ID that indicates the account creation? And this is where I went to Google and I just pasted that here. And then the only thing that I did was I changed that to what is the Windows event ID. And then it brought, there's only one answer, which is 4720. And that is indeed the response. The attacker added one of the accounts in the local administrator group. What is the command that was used by the attacker to add the user? And so it was the netlocal admin Cheyenne. And so it's, again, just one of these things. So if you go through the remaining list, because it was after them verifying that they added their users, and it was so add Cheyenne Master Chef, they were able to add that user, and that's great. And so now we want to make sure that we add that user to the admin group. And so they just follow along with that. So new accounts, there we go. It's been confirmed. And it's like literally towards the end, because they want to make sure that they have their user inside of the admin. There we go. Net local group administrators add Cheyenne. So you just take this portion, and that's the answer that they're looking for. And that is the answer that we gave them. Based on the Windows event logs, the account was successfully added. What is the event ID that indicates the addition to a sensitive local group? So we take that and we paste that into Google, and then we just put Windows at the beginning. What is the Windows event ID that indicates that? And 4732 is the only response for security enabled group. And that is indeed the answer. So after the account creation, the attacker executed a technique to establish persistent administrative access. What is the command that was used by the attacker to achieve this, right? So this is where it gets a little bit interesting. And this one took me a little bit of time to find. So we're trying to see what they did after establishing that administrative access, or excuse me, after creating that account, they executed a technique to establish that access. So I'm going to walk you through essentially what I did to be able to find that final answer. And I'll do it obviously a little bit more quickly than what I did previously. But this is something that is actually, if you know what you're looking for, if you know what different elements you're looking for, it's kind of easy to find. So let me show you. The first thing that we need to remember is that once they've established their administrator privileges, they're no longer Benimaru, right? So everything that they're doing is now going to be under the NT authority system user. So when we go back into our Timeline Explorer and we're looking at the sysmon CSV file, so we're not inside the Windows. The Windows one, I think, was more for the getting those event IDs and everything. So we're going to go into the user, and we're going to filter for the authority system. And this is the one that we're most interested in. So we're going to only look at the NT authority system user. And then we're going to, of course, go look for the executables that were run to be able to find to be able to create this like persistence portion of it. It is a fairly good amount of information that's available over here. So I'm going to filter the executables just to show us all of the actual commands that actually have values. So we need to click it one more time to bring all the ones that have value. There we go. So let me just kind of scroll to the top here. So these are all the ones that actually have value. So the ones that we are most interested in would be the things that are using the Windows System 32 element. So we can see, if we go over here, we see that Windows 32 service SVC host, and then there's a variety of different commands that are used, net1 users, and then user Shuna Princess and Cheyenne and administrator, all of that, right? Add user, local administrator, etc., 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 etc. So you just keep going, and then you can see if there's anything else that might be relevant to what's going on. So the Tempest is the name of the machine. Tempest is the name of the host, right? And SC is something that is for service creation. So you create a service, and then you're creating Tempest to update. Binary path is going to be the final.exe, which is that final executable, right? That final binary that they wanted to run. And it's going to start on auto, meaning that every time that they boot this computer, it's going to run this thing. So this is actually a scheduled task that's happening. So they are doing sc.exe. The user itself is Tempest, and they're creating this specific service called the Tempest Update 2, and the service that will, the binary that will launch for this service is going to be this final exe. So there are a few different ways that we can find this. I just narrowed it down by Tempest because I just wanted to see where it was. But technically, you could even do final.exe, and it would pull up everything that has to do with that binary, that final binary. And it's a smaller list. It's a much smaller list because, again, we already established, right? So if we go through our information, all of the data that we gathered previously, they executed a tool with another binary to establish their C2 connection. What is the name of the binary that they executed? It's that final exe. And when you do this in a real environment, in the real world, you need to make note of all of the artifacts that you found and all the data that you gathered. And final.exe would be the last piece in the timeline of activity that this person did. That would be one of the final pieces. And they used this to establish their connection on port 8080, etc. So that would be the big thing that you would search for, is that final.exe binary. And so when we do that, and then we organize our executables to actually only show us the stuff that have value inside of them, then it's fairly easy to kind of narrow this down. So we have, the original final exe, looking at your privileges, etc. And then you have these creation of these services, and create is another one of those kind of red flag types of events where it's like, oh, what are you creating here? And so they're creating this automated service, this service that will launch every single time the computer boots, and then it's going to be that binary, that final.exe. So this is the full command, because the second one is the one that I think was the most successful, because if they do one Tempest update and then they do two, that means the second one would be the one that would be of note or of interest. And so remove the double quotes as the other one as well. So again, just open this and then highlight this whole thing and text it inside of it, take it inside of a text editor, remove that quote, and then remove that quote, and then take the whole thing again and then paste it in here, and that would be your answer. And that was the final answer that you needed to complete this exercise. And let me tell you, I went through a good, let's say, hour and a half of recording, 2 hours of recording, and then the freaking OBS acted up, and all of a sudden I lost the recording, and I'm sitting here in front of the computer. I'm like, oh my God, I can't believe that just happened to me. But we made it. We actually made it to the end of this, so I'm very excited that I hope you persisted. I hope you went through this whole thing with me. It's a very, very cool exercise. I loved it because it did test me in some places, and I got a chance to run some command line tools that I haven't ran before, and we were able to deal with certain files that I had not dealt with before. So it was cool. It was like a nice experience to be able to actually run through this thing, and I got a chance to learn, and I hope you got a chance to learn as well. And I hope if you already knew some of these things, that this became kind of another exercise that embedded or further embedded this process into your system. And Brim is an amazing tool. I love Brim. Of course, the Timeline Explorer was very useful. It was nice to be able to learn how to create various filters inside of Timeline Explorer. We went through an entire investigation. If you really think about it, we actually did of course, looking at the various artifacts, or modifying our artifacts, formatting. That's the word I'm looking for. Formatting the artifacts that we were using so that we can go ahead and prepare them for the investigation. And then we first looked at the things that were downloaded and what they did to establish that initial foothold and get their foot in the door, so to speak. And then they were able to use that foothold that they had to download several other binaries so that they can get themselves persistent access. And then they escalated their privileges and became administrator. And then they created new users. and added those users to an admin, or at least one of those users was added to an admin group, and assuming that that would have never been discovered, this person would have been able to log in as that new user and be able to do everything that they wanted to do without having to log in as the administrator user specifically, because that's a red flag. Like when you log in as the administrator user, the system security will kind of fire all the alarms and it'll be like, hey, somebody's logging as admin. So if you log in as a normal user, just, you know, Schumer or whatever, Cheyenne, if you log in as the normal user, but you have admin privileges, it's not that big of a deal, right? So specifically, if you log in as the admin, there's a lot of configurations that have been established that, oh, somebody's logging in as admin, and then it raises flags. So in this particular case, they were not successful because we caught them and we were able to investigate what happened. And that was the whole purpose of this exercise. And it was really cool. I liked it. I hope you liked it too. And I hope you learned a lot from it. To get more videos like this one as we go through the rest of the SOC level 1 capture the flag exercises and the investigations and everything that we're doing, make sure that you like, subscribe, and turn on the notification bell. And of course, drop a comment. This was actually quite a complicated room. So if you have any questions or if you need any clarity on anything, please let me know. I tried my best to explain it in the best detail that I possibly could. So hopefully it wasn't too much of an explanation, but hopefully it was enough to be able to get you to go through it and understand what just happened. And then we have obviously the future videos that are going to come out on SOC level 2, and then we have the pen tester stuff that we're going to do and everything else that we're going to do for web hacking and AI cybersecurity, all that. So there's a lot of content that's going to be coming up, and these things become more and more complex. So this took me 2 days to record the video for this one room because it was very time consuming to be able to go through that initial investigation. And then what you see is just all of the cut up pieces, but it was a good total of like 5-6 hours that was dedicated just to recording this one video for you. And it's going to be less frequent, I think. The uploads will not be as many, but they're going to be really jam-packed with a lot of value because we're doing more advanced stuff from this moment forward. We did all the CySec 101 playlist, so now everything that we're going to do from now on is going to be more advanced stuff. SOC level 1, SOC level 2, pen tester, ethical hacker, AI cybersecurity, all of those things. So it's just going to become bigger pieces of content because all of the foundation has been set. We've talked about all the fundamentals, and now it's time to talk about all the really crazy fun stuff. So I hope that you like, subscribe, turn on the notification bell, and of course drop a comment so that you get notified the next time that these videos come out. If you're serious about your CySec training and want to get access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section, and that is it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I will see you in the next video later. In this video, we are going to go through the Boogeyman Capstone challenge that is a part of the SOC level 1 capstone challenges in the SOC level 1 pathway of TryHackMe. And this one specifically, I believe, has to do with a phishing campaign. The last one that we did had to do with a series of network attacks that somebody did, and they were able to get past certain filters to get into the actual network, and they impersonated a user. Then they escalated their privileges, and then they took action on their steps, so on and so forth. So that was a really good one. It was actually a really strong video. I liked it a lot, and I think this is going to be a good one as well. Anything that's essentially ranked medium inside of TryHackMe, I know is going to be a good test of everything that we've learned so far, so that we can go ahead and accomplish whatever the investigation is without too much help, and we are left to our own vices essentially. So that's what we're going to be doing in this video with the Boogeyman challenge, the certified Boogeyman challenge. I always get reminded of the Kendrick line. certified boogeyman. So that is what we're going to be talking about today. This is the outline. So, just the introduction, the email analysis of looking at the headers, and then looking to make sure that the attachment apparently is an invoice or not. And then they got us, call the bank immediately. This is assuming that we've actually been hacked, and we're analyzing the network traffic to try to find the packets and the flow of the traffic that implies that we were officially hacked by the boogeyman. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the boogeyman exercise. I do wonder whether or not this is actually something that exists out in the real world, or if it was just something that was created for this specific exercise. But the whole point of this is that we're going to analyze the tactics, techniques, and procedures executed by a threat group from obtaining initial access until achieving its objective. So there's a threat group, also known as an APT, an Advanced Persistent Threat. And those are very common inside of the MITRE ATT&CK framework, or the MITRE ATT&CK matrix. And the tactics, techniques, and procedures is also something that gets outlined a lot inside of the MITRE ATT&CK website. So these things are very common in the real world. I just wonder if the boogeyman is real. I mean, everybody probably wonders if the boogeyman is real. So let's go and look at the MITRE ATT&CK website and see if there is indeed something called the boogeyman. So we are here, and we're just going to search for boogeyman. That would be so interesting. There is no results. Obviously, there's no results. It would be kind of corny, I feel like. It's like kind of cliche if a hacker calls themselves the boogeyman. It's like, really, dude? Like, really? But anyway, that's who we're dealing with today. And that's what he looks like, apparently. And he's trying to get into the financial office, the finance office. The prerequisites are that we need to know the basics of phishing and phishing analysis tools. And of course, Windows event logs, Wireshark traffic analysis, and T-Shark, which is the command line equivalent of Wireshark. For the most part, it actually has a lot of the functionalities that Wireshark does, with a few limitations, but you can essentially use T-Shark in the command line to quickly analyze traffic inside of a PCAP file, or even capture traffic if you wanted to. So very, very powerful series of tools that we have here. And there are a series of videos that were done for phishing that are on this channel that, if you don't know the basics of analyzing phishing emails and looking at email headers, etc., I would recommend going through those videos just so you can get a good crash course, so to speak, and all the fundamentals before we jump into this room. Because for the most part, they're not going to tell us where we're going to find things. They'll tell us, specific commands maybe that we need to run to get a report, but they're not going to tell us how to find the information and where the information would be located. All of that stuff, we're left to our own biases to figure out on our own. The investigation platform is the virtual machine that I've already started, and it's on this window right here. So that's our virtual machine provided to us by TryHackMe. And this is another one of the reasons why I love TryHackMe. They even stopped their referral program, but I just can't stop singing their praises, because it's a controlled environment. You can essentially run virtual machines and attack boxes and attack as many different virtual machines as you want without getting a felony on your record and getting arrested. So that's all amazing stuff. So we have the machine that's already loaded. The artifacts are the copy of the phishing email, which is dump.eml, PowerShell logs from Julianne's workstation, PowerShell.json, and the packet capture, also known as capture.pcap. And the PowerShell JSON file contains JSON formatted PowerShell logs extracted from the original EVTX file via the EVTX to JSON tool. And this is what we were dealing with in the last video as well. We had to convert EVTX files into CSV as well as XML files to be able to analyze them. All of this stuff is going to be included in the desktop artifacts directory, which is what we have right here. and we need to, this is the full path of it when we actually go into the command line, and that's easy to navigate. The tools will be the Thunderbird email email client. That's the word I'm looking for. So the Thunderbird email client, the LNK parse, which is a Python package for forensics of a binary file with LNK extension, Wireshark, Tshark, and of course JQ, which is something that is used to process JSON in the command line. And these are some of the commands that we're going to need to get really good at. So grep is to search, awk and sed are also for search, and base64 is for encoding and decoding of various tools. I'll run everything inside of the command line, but there's a really easy way to decode something for base64 and encode something in base64, and really a lot of other encodings as well. And that is the CyberChef tool. And most likely I will probably kind of default to CyberChef. I do want to learn or get better at running these things inside the command line, especially if you don't have access to CyberChef inside of whatever environment you'd be running in. So it's always really good to learn how to do these things without CyberChef. But CyberChef is one of the best tools that you will get, because you can do things like, you know, to base64 from base64, to hex from hex, and all of these things. And these are just like the common ones. There are literally, I would say hundreds of different operations that you can run, and they're categorized exclusively to do a bunch of different stuff for you. You can extract data using any of the extractors. So if you have a really large file or a really large block of text that you want to extract data, excuse the dogs in the background. If you have a big block of text or a big file that you want to extract data from, you can use the extractors. So again, really powerful tool, and I would highly recommend you check it out if you have not used it already. So that being said, we have covered all of our bases, and now we can jump into the headers portion. Here's the scenario. Julianne, the finance employee working for Quick Logistics LLC, received a follow-up email regarding an unpaid invoice from their business partner, B Packaging. Unbeknownst to her, the attached document was malicious and compromised her workstation. This is the email. So, hope you're well, blah, 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 blah. You may use this code to view the encrypted file. And best regards, Arthur Griffin. And then there's something else that's also missing at the bottom. So there's two things that have been blacked out for us. The respective document number, the invoice number is probably this. The payment is for January 20, 2023. And that's essentially it. So the security team was able to flag the suspicious execution of the attachment in addition to the phishing reports that were received from other financial department employees, making it seem like that it's a target attack on the finance team. And upon checking the latest trends, the initial TTP, the tactic technique procedure, used for the attachment is attributed to the new threat group named Boogeyman. And we already verified that they actually don't exist inside of MITRE, so they probably don't exist. Known for targeting the logistics sector, and we need to analyze and assess the impact of that compromise. So this is the investigation guide. This is essentially the outline that we need to take to be able to analyze this thing. So given the initial information, we know that the compromise started with a phishing email. So let's start with analyzing the dump EML file located in the artifacts directory. There are two ways to analyze the headers and rebuild the attachment. The manual way is to use command line tools like cat, grep, base64, and sed, and analyze the contents manually and build the attachment by decoding the string that's located at the bottom of the file. And so this is what it looks like, right? So essentially, you cat whatever the file is, and then you base64 decode whatever the contents are into the zip file that we have over here, okay? So the echo portion right here, it says it's a sample command to rebuild the payload, presuming the encoded payload is written in another file without all the line terminators. So the alternative and easier way to do this is to double click the email file, open it on Thunderbird, and the attachment will be saved and extracted accordingly. Once the payload from the encrypted file is extracted, use the link parse to extract the information inside the payload, and that would be link parse, and then we give it the LNK file. So let's go and actually analyze this to be able to pull the information that we need to answer some of these questions. So easy money. And because it is a singular file, so in the, not the last video, I think it was the video prior to the last video, where we start looking at another phishing campaign that we had, and I created a script inside of that video to analyze a bunch of EML files, because in that video we had, I think, 5 EML files, and you can still manually look at 5 EML files. It's not that many. But if you have a large list of employees, let's say 500, if you have 500 EML files from all of their email accounts that you need to analyze, at that point you need to start using scripting. And so I created the script that I'm not going to recreate here because we only have one EML file to deal with. So that script, and it's not the last video, because the last video was not that investigation, is, I would say, it's the video previous to the last video. So if you actually go to the uploads on this channel and look at the date range, essentially, it's not the one that you're watching, obviously, not the one prior to this one, it's the one prior to that one. And I guess I could go ahead and find it real quick. So let me just go and find it real quick. So here's the channel. We come to videos real quick, and then we are looking at the latest tab, right? So in the latest tab, we have Catch a Hacker and then Phishing. And this is the one. So this is the one where we create the shell script that will analyze multiple EML files, and then through those EML files, we extract the data that we need. And it's a very useful script. I think a lot of people will get a lot of value out of it. So I would highly recommend you go check it out, especially if you are going to be in incident response or security analysis or digital forensics or anything like that, and you're going to be analyzing very many files, because it's not necessarily just EML files that you'll end up analyzing. You'll probably end up analyzing a bunch of different types of files, and it's always good to know that. And another way that you can also learn about scripting is to obviously go to the Linux Plus playlist that we have on the channel. And on this playlist, the last video, the 5th video, is all about scripting, and you'll get a chance to learn how to create a variety of different shell scripts for automation, to parse through documents, and to learn a bunch of different types of information about the data inside of that document. And then there is one other video that I do want to point you to real quick, and that video is going to be the Python for cybersecurity video, and that one I have to actually kind of search because I know it's a little bit further. So if we look for Python for cybersecurity, it's this video. So it says build Python algorithms for cybersecurity, Python for tutorial, or Python tutorial. And this one is a really robust video. This video is what, 6 hours long, 6 hours and 17 minutes long. And it starts from the very basics, where you actually learn how to, download Python, run your very first program, go through all of that, and then by the end of it, you will learn how to build an algorithm. So you get all of the foundations and the fundamentals for Python, and then from there you'll get the advanced stuff where you can actually read from a file and parse data from a file and extract and manipulate the data from a file and create an algorithm for cybersecurity. So a lot of great tools, a lot of great videos available on this channel. To really think about it, honestly, it's a little bit over a year, maybe like a year and 2 months or something, that we've had this channel, and I've had over 300 videos that have been uploaded on this channel, and it's pretty interesting what has happened. And I'm kind of digressing and I'm going on a tangent, but there's a lot of stuff on this channel that you can use for your learning pleasures. And if you're interested in a specific topic, you can either go and look at the playlists that are available, because we do have a lot of good playlists. And then there's also the search function over here where you can actually search for a given topic. And if you find it, great. If not, drop a comment and let me know that you are interested in it, and I will see if it's possible to create it for you. Now, all of that out of the way, we are now going to actually analyze this very first artifact, which is going to be our EML file, which is the dump EML file that we have over here. So I'm just going to double click it. It'll open up inside of, oh no, actually, you know what? Interesting. It just opened up like this. So we can actually see the email right here, right? So this is I think it says the first question was who is the email used? What is it? Who's the email address used to send the phishing email? Or excuse me, what is the email address used to send the phishing email? And it will be A. Griffin. So that's that. What is the email address of the victim? And that's also here, which is Julianne West. And we didn't even have to open this inside of Thunderbird yet. So there's Julianne Westcott. And then what is the name of the third-party mail relay service used by the attacker based on the DKIM signature and the list unsubscribe headers? So Now this is where we actually need to go ahead and see some data from the headers of this thing. So we need to actually look at the email headers. And to be able to do that, let me see if I can just open it with Thunderbird. Boom, there we go. So open with Thunderbird, and we're going to be able to look at the source code of the email, or at least the headers of the email. And then you just search for the, what is it, the DKIM signature and the list unsubscribe headers. And from there, we'll be able to find the third-party mail relay service. And then what is the name of the file inside of the encrypted attachment? And so the name of the file inside of the encrypted, I want to say it's invoice.zip. No, it's not, because we need to actually unzip it. So I would need to download that file. So let me just write down here. We see invoice.zip. So we're going to save it. And then it's going to be saved. I'll save it onto the desktop inside of the artifacts. So we'll do that. And we'll save the zip file inside of our artifacts. And there it is. And then we'll extract that in a quick second. And then what else do we need? What is the password of the encrypted attachment? Based on the result of the link parse tool, what is the encoded payload found in the command line argument field? And that is it. So let's see. We need a password. We need the password is this right here. So invoice 2023. So there is that. See, and that makes it like really legitimate, because if they're giving you a password to access it, and it's an encrypted file, you're like, oh, okay, so this must be legitimate, because it seems to be a very sensitive document, and they're giving me a password to unlock this document and all that. So it's a really good way to, they call it pretexting, and pretexting is essentially a strategy in social engineering, and we talk about this in great depth inside of the Security Plus playlist that's on the channel. But the pretexting concept is to like manufacture this story inside of the mind of your target to kind of make them believe that this phishing campaign is real, right? Or it's not a phishing campaign, right? Like that it's actually a real email that's being sent. And usually it's things like this, like little tactics like this, where it's like, hey, you know, we have this invoice that we need you to check out. It's encrypted for privacy reasons. Here's the password to be able to access the file. And it's like, okay, all right, it sounds legit. It sounds super legit. And it's something that will make a person kind of drop their guard a little bit. So anyways, DKIM and list unsubscribe headers. So let's zoom in here a little bit. What's going on? Why can't I zoom in? Okay, here we go. Zoom in. All right, so there's a few different ways that we can access this information. So usually if you go to view, you'll be able to just look at headers, and typically it's just the normal headers, which is what you see right up here. And then if you go to view and then do headers and do all headers, what it does is it gives you all of the headers up here, and it's a kind of difficult to search through this. So what I like doing is I just like opening the headers inside of a separate document. So I'm going to go back to normal just to kind of collapse that. And what you can do is you can look at message source. And when you look at message source, it just opens up the whole thing for you. And this is all of the information inside of it, including the encoded portion. So these are the things that you see right here, like the stuff that end with equal signs. These things right here, these are all encoded elements of this document. So base 64 encoding is what we're talking about. So like this full thing, I would assume is like a full base 64 encoded element of this document. So real quick, just to kind of display, let's see, maybe we'll even find something information, why can't I highlight this? This is like obnoxious right now. So if we copy that, there we go. And then we go to CyberChef and drop that over here. And then it has an actual magic detection right here. So we can just do that. And then now it gives you the decoded version of all of that jargon, and it's a PK zip file. Extension is B64 application octet stream. That's basically what this whole block of text actually equates to. So we have the attachment invoice zip, the encoding is base 64, etc., etc. So the big thing that we're looking for is the DKIM signature, right? So that's the one thing, and then the list unsubscribe, because we want to find that forwarding email service. So the reason why I open it up inside of a text editor like this is that you can actually now do Control F, and you can look for something inside of this document. So I can do DKIM, and then DKIM pass, and what is it? DKIM signature is what I'm looking for. So DKIM signature, there we go. So inside of the DKIM signature, we have, let's see what data might actually stand out here. So there are two emails, right? So there's, or two domains, technically, I should say. There's the B packaging that's misspelled. If you actually look at it, K comes before C in this. So that's actually misspelled. That's how they really psyched out the person who was reading this, because the website of the legitimate company is probably B packaging, but it's CK instead of KC. And a lot of times you don't catch something that as simple as this little switch in the thing. So that would be the email that they're trying to impersonate. I would say this is the actual email that is being forwarded to, and this is also a part of DKIM signature. So there's two of them. There's two DKIM signature headers, elastic email, there's the elastic email that's revealed in one, and then the other one was the list unsubscribe tag that we can just go also look at. So if I do list unsubscribe, it will show me, I mean, this one right here specifically, and the value of this is also encoded, as we can see. And then let me see if there's another value. There's another value right here. Whoops, I skipped through it. So packaging, I think this was the original one. So let's go back one. And this is the other one right here. Julianne Wiscott, this list unsubscribe. And inside of this information, can we see that email domain? Let me see. I mean, so the only thing that I can actually see under the list unsubscribe is the multiple references to the A Griffin at B Packaging XYZ. So this, I mean, it feels like this would be the reply to email, not the forward email. And the question that they're asking specifically is the third-party mail relay service. And I would say that that is indeed that initial domain that we found. So let me go ahead and do the DKIM signature one more time, and I'm doing DKIM signature. And so that was the one that we found over here, where it has the elasticemail.com. I think that's it. So it's either elasticemail.com or it's B packaging misspelled. So I'm gonna do elastic email. And that is the answer. Okay, great. So elastic email is the third-party mail relay service. So there we go. Now, what is the name of the file that's inside the encrypted attachment? And in order for us to be able to do that, we need to unzip this invoice. So what I'm going to do is I'm just going to open up a terminal inside of this specific path. And that's one of the easier ways to just be inside of the path that you need to analyze the document. So you can just right-click inside of the artifacts folder or wherever you are when you're looking at the file explorer inside of Linux, or really any other service as well, like or Microsoft or Mac OS. If you just right click inside of any location, you can just open up a terminal in that location. Usually if you open up the terminal, it's going to be in this location, which is the root folder that shows everything that you have here, and then you would have to go into the desktop artifact by CDing into it, and that's not hard to do either, so it's not really that big of a deal. So anyway, so there's our zip file in red right there. So let's zoom in a little bit more for you. And so now what we need to do is we need to unzip it. So the command is unzip, and then you do invoice.zip, press enter. It's going to ask you for a password, and it was invoice 2023 with an exclamation at the end. And there we go. So inflating invoice 2023.lnk. And so that is the name of the attachment. So we're just going to drop that in here. And there's that. And the password to be able to look at it was that. And based on the result of the link parse tool, what is the encoded payload found in the command line arguments field? And so that's what we're going to be running our little link parse command right here. So lnk parse, basically. lnk parse. So just like this, we're going to zoom in here again. We're going to do ls, and now we have this lnk file right here. And so we're going to lnk parse and then give it invoice underscore, press tab. It'll fill it in for us. Press enter, and it's going to work like a charm. And we are looking for a specific field, which is the which field? The command line arguments field. So let's go find the command line arguments, which is right here. And so we have the, what do we have? We have NOP, window style hidden, and then the encoding is this piece right here, and then the icon location. And what they want is, what is the encoded payload that's found in that? I'm guessing they want the actual encoded base64 payload, which is basically this whole thing. So we would need to highlight this entire payload, and that is the encoded payload. So can I copy that? There we go. We can copy that. I would assume that that's what they want. And let's see if that is, yeah, that is indeed what they want. So now we're going to just go, because we're nosy, we're going to go and drop it into CyberChef. And so what do we see? We see unknown file type. Have you tried checking the entropy of this data to determine whether it might be encrypted or compressed? And it doesn't really seem, I don't know, at first glance, maybe it is useful information or something, but for now, it does not seem like it would be any useful information. So moving on to, are you sure that's an invoice? This is what we found so far. So we know that there's a PowerShell command that was executed on the workstation, and we know that decoding the payload reveals the starting point of the endpoint activities. And now what we need to do is we need to analyze the PowerShell logs to uncover the potential impact of the attack. So we can start the analysis by searching the execution of the initial payload in the PowerShell logs, and searching the, since the given data in the JSON file can parse in CLI using the JQ command. We note that some logs are redundant and don't contain any critical information, so we can ignore them. Just like looking at something like this, I feel like the unknown file type, whatever BS, I don't know if that's relevant. Honestly, it might be, but it doesn't seem like it would be. If you've never used JQ, I've actually never used JQ, so it's nice that there's a cheat sheet here. It's a lightweight, flexible command line JSON processor, and it can be used in conjunction with other text processing commands, meaning grep, for example, or cat, or something like that. So we can use this as a guide to parse the JSON into beautified output, print all values from a specific field without printing the actual field, print all values from a specific field, I guess with printing the actual field, print values from multiple fields, sort logs based on their timestamp, and sort logs based on their timestamp, and print multiple field values. So there's also the full documentation that's available on the GitHub repo for these people right here, and it gets forwarded to the jqlang.org website, but originally it started as a GitHub domain, and then it just forwarded us here. And so we have the manual, etc., and the various commands that you can run, and you can navigate through the table of contents on the left hand side. So I will keep that open just in case. We'll move it towards the back. And what are the domains used by the attacker for file hosting and C2? Provide the domains in alphabetical order. What is the name of the enumeration tool that was downloaded by the attacker? What is the file that was accessed by the attacker using the downloaded SQ3exe binary? Provide the full file path. What is the software that was used in what is the software that uses the file in question 3? What is the name of the exfiltrated file? What type of file uses the KDBX file extension? What is the encoding used during the exfiltration attempt of the sensitive file? What is the tool used for exfiltration? So good amount of stuff that this person has done, and apparently he was successful, because if he actually used the tool for exfiltration, that means he got the data that he was initially looking for. So that is no good. And I mean, obviously there's also this thing at the bottom right here where it says they got us, call the bank immediately. So they did more than just export some files, exfiltrate some files. So all right, first and foremost, we need to look at the PowerShell JSON file, and we need to use this wonderful tool in the beautified output so we can see what the hell is going on. And first and foremost, we need to find second most, I guess, after we parse it, we need to find the domains that they used for hosting and C2 and do it in alphabetical order. So let's go over here. We are now in this location. Let me kind of zoom in a little bit on the terminal, and I'll drag the terminal a little bit to the right. Okay, perfect. So here we go. Let's clear this. Let's look at that. Where's the JSON, PowerShell JSON? There we go. So we're going to do cat PowerShell .json, and then just pipe it into the JQ like that, and then it'll give us the beautified version of this, basically saying that it's organized, right? So this is usually what it looks like if you open up a JSON file inside of coding software or inside of a web browser. It's typically beautified like this, so it's useful, it's nice to see. So we are looking for domain names. Now, the interesting portion of this is that domain names specifically may have a .com, they could have a .net or .xyz, whatever it may be. So it may be a lot. So let's see how big this file is over here first and foremost, because there's a lot of stuff that's inside this file. As you can see, it's barely moving, and there's a lot that's going on. So we need to find a way to sort through this a little bit better, and that would make our lives probably a little bit easier. We need to see, so what do we get? We could do print all the values, print values from different multiple fields, timestamp, etc. So let's say from one field, if I want to print a value from one field, what would that be? Okay, so here's what we did. I'm going to start from the very, very first command that you already saw. So you saw me essentially pull the information from the entire JSON file, which is what this looks like right here. The very next thing that I did was I just wanted to see maybe if I only look at the script block text portion of it, maybe it'll find me some information that might be interesting. And then when I did do that, that it did find me stuff that was interesting, but again, it was still too much output. There's just too many things that are going on, and then to be able to try to manually sift and sort through this is going to take literally forever. So I was like, okay, well, I'm not going to do that. So the next thing that I did was I created my very first grep command using regular expressions to try to find a domain name or a given domain name. Anything that might even resemble a domain name. And so the first portion of this is what you see down here, cat PowerShell JSON, and then we did JQ, and then there's an option inside of JQ, which is the -r, and then pipe strings, and then you put the pipe strings inside of quotations or singular quotes, and the -r turns the output into raw data format, so it's not being formatted in any kind of way to make it look pretty or anything like this. We actually just want to get the raw data, and from the raw data we're trying to pull all of the string values, and then from those string values we're going to grep inside of this for the regular expression that would potentially yield us some kind of a domain name. And so if you don't recognize regular expressions, I understand it's not, I'm not here to explain regular expressions to you. There's an entire regular expressions video that's available on this channel. Very, very powerful stuff, and I highly recommend you go through it because it's a very powerful resource. It's like a powerful skill set to be able to create these patterns. And this is a really basic pattern, especially when you understand regular expressions. So we're looking for lowercase a to z, uppercase a to z, and the numbers 0 to 9, and then you have a literal dot, and then you have again lowercase a to z, uppercase a to z, and then we want to say essentially from 2 spaces or 2 characters and onward. So show me anything that is greater than 2 characters, which could be a .io, it could be a .co, .us, it could be .net, .com, .xyz, etc. So when we run this, we actually get a good amount of data. Now, if we get past this exception portion and all these things, we can see that it's actually pulling a bunch of other types of data for us. So if I keep scrolling in a little bit, and I'm doing this slowly because I don't want to like pass it, but essentially what happens, oops, there we go. And essentially what happens is that you start seeing the domain name. So files.bpackaging.xyz, and that would be the file that would be one of the domains that we would be looking for, because more often than not, I mean, if it's especially the misspelled bpackaging.xyz, it's like, oh, okay, that's probably the domain for this thing. And the question asked us, what is the domain that they're using to the domains used for file hosting and the C2. Provide the domains in alphabetical order, and I know that we have 2. we have 2 domains that we need to look for, and that is one of them. I want to say for sure it's going to be the files.bpackaging.xyz. So instead of manually kind of like sifting and sorting through the rest the rest of these outputs, what I'm going to do is I'm going to add one more grep. And so I have this whole, and actually there was another grep that I did as well. So there was like a more advanced grep that was actually looking for a more advanced regular expression for filtering the domains a little bit better. So if we go through that, it'll still show us most of the same data. It'll just be a little bit less robust because a lot of the other stuff has been actually filtered out, and then we get to see similar stuff. So we see line bpackaging.xyz. We do get to see files.bpackaging.xyz at some point as well. I've reviewed a lot of the output, but it makes it a little bit there's less volume, there's less data to sort through. So one other thing that we can do is we can pipe this again to another grep command, and then from this I could just say grep anything that ends with XYZ, which is, I know that's what the domain name is going to be. So I'm going to do that, and it actually doesn't show me anything. So that's very interesting. So let's see if I can, I actually know that for a fact that it can actually show me that. So I want to see if maybe I did it incorrectly. So let's do it like that. And it still doesn't show me anything. That's interesting. Okay, so let me see, because I know there's a way that I can grep multiple, or I can do like multiple filterings of the data using grep, and I'm just curious as to why this is not working, because I know for a fact that if I go through this data, I know there's a bunch of data, so I want to be able to see if I can filter it a little bit more. So let me, I'm going to fool around with this a little bit and see if I can pull that data for you. Okay, cool. That's what it was. So essentially, I needed to use the regular expressions again instead of trying to filter normally the way that you do. Because really, you could do it in multiple ways. You could actually grep in multiple ways. And the one that I was doing was something like this, where it's like you do grep and then you put the asterisk inside of the quotes to stand for a wildcard character, and then you say XYZ, and then you close it with another quote. And usually, sometimes that actually ends up working, but I think it doesn't work when you're trying to grep through files. I think it would maybe only work when you're trying to grep to find a file name inside of a given location. I think that's kind of what works. When we're trying to grep through the contents of a file, for example, the stuff that's inside of a JSON file, we would need to just further grep using another regular expression. So I used the complicated regular expression for the domain name, and it only yielded these domains for me. And I used the simplified version of the domain search, and then I grepped the again the expression for the .xyz at the very end of the domain to only pull this information. And I actually got a couple of extra domains. So we got the CDN.bpackaging, files bpackaging, and line bpackaging. Notice that obviously we didn't get the HTTP because in this one we were actually looking for HTTP, so it would limit it only to the output that had the HTTP. In this one, it did not limit it to the HTTP, so now we have CDN.bpackaging.xyz and files as well as line. But I want to say that the CDN would be command. That's probably what they're trying to do. So command, and then files obviously is the files. So let's do cdn.bpackaging, like misspelled, and then XYZ, and then we will do files.bpack. It's so hard to misspell it, like when you know how it's supposed to be spelled. Okay, cool. There we go. So we actually got the answer. So cdn.bpackaging and files.bpackaging. So, you know, it's useful. It's useful to be able to use cat and go through the information just by looking at it like that. And they give us a few little hints of how to extract values from given fields. But I mean, to be honest with you, there's just too much data. There's like way too much data to not use a tool like grep. It's like you would pull your teeth out if you had to do that. I don't have any hair. I was about to say you'll pull your hair out, but it's like I don't have any hair. So you would pull your teeth out if you had to manually sort through all of this stuff. And like and this is just like the limited output where we actually use the regular expression to try to find only things that have, that kind of look like domain names. So imagine if I didn't do this and I was looking at all of the freaking data that was output. It would literally take a long time. I'm not going to say forever, but it would take a very, very long time. So okay, cool. So we got this answer. That is the very first answer that we got here. Now it says, what is the name of the enumeration tool downloaded by the attacker? And the hint for this is they mistakenly executed the exact tool name. So enumeration tool downloaded by the attacker. And I just know that there's something called GoBuster. I'll do the research for this, but GoBuster is like a really powerful enumeration tool. So is it GoBuster? It's not GoBuster. Okay, cool. So it's not GoBuster. All right, so they accidentally used the exact tool name. So let's try to find that answer. Okay, so first we need to find out what is the PowerShell command that is used to download files from a web server. And typically that is invoke web request. So invoke web request. So let's do it like this, right? So what is the PowerShell command to download a file from a web server? And invoke web request is usually to make any kind of web request from any kind of a URL. And that is most likely going to be the first string that we're going to have to grep for, that we're going to have to search for. And then the second string that we're going to have to search for is the actual domain name, right? So we know that there's the files.bpackaging.xyz domain that was used to download files, most likely, because they're hosting their files over there. So most likely they were able to download the files from over there. So first I'm gonna do a grep of just the domain, not the domainer, excuse me, just the actual command of invoke web request. That's the first thing that we'll do a search for. And then from there, we'll see, I mean, most likely, hopefully there will be some kind of a response, but if there isn't, then we'll just go ahead and grep for the domain name itself. So we'll do a case insensitive is what we're going to do for our grep, and then we're going to do invoke web request, which is essentially any query that would be done. And then, so, I mean, it says invoke web request, so it literally has all of these things over here. And let's see, so we have, let me see if I can find any reference to the XYZ domain, although it feels like there may, this seems like the biggest block of text that would be relevant to what we got to do, but it says CDN bpackaging XYZ on port 8080, so let's see if I can find anything else. Okay, so the command that actually ended up working was the cat of that without any other exchange or any other parameters fed into JQ. So we just did JQ, although I feel like that's probably not even necessary. And then I did grep -I and then just the domain for the files bpackaging website. And so we have 3 different references to it. Where there's script block test. They were not using invoke web request verbatim. So the IWR is a short, kind of like an acronym version of invoke web request. So that's what they were using instead of the actual invoke web request commandlet by itself. And then these are the files that were downloaded. So we have sb.exe and then sq3.exe. And these were the files that were downloaded. Although I think I skipped seems like I skipped a question, because they're looking for the enumeration tool, right? I think that's what the question was. So neither of those are going to be our answer. So it won't be sb.exe. It's also not going to be the sq3.exe, because they're obviously too short of an answer. So what we can do is we can rerun our last command again. And in this particular case, what we can do is grep for the word download. And let's see if that exists. And we have a few. So thankfully, it's actually a short list here. So what do we have? We have from the web client download string, GitHub, secure this shit, PowerSharp, blobmaster, power, invoke seatbelt. Seatbelt might be the name, and then bpackaging update. So potentially seatbelt, I think. Seatbelt PS1 could be the name of the tool itself. And so if we now search for this and see if we can find reference to seatbelt, let's see if we can find that. And so he did run seatbelt just by its name, and that would potentially be the thing that he used to run. Okay, cool. So what is the file processed, or what is the file accessed by the attacker using the downloaded sq3.exe binary and use the full path? So we can do a similar command in this particular case, where instead of searching for seatbelt, we'll just search for sq3.exe and see how many times that shows up. And it shows up a few times. So what do we have? We have two references to it. We have this one where it is the, so it would be essentially right after this, app data, local packages, Microsoft, plum SQLite, and then from there select whatever. So he's using the SQL queries to be able to do something, it seems like. There's another one where there's sq3 out file. That's the one that's being downloaded. So this is the only other one where he's running sq3 and then downloading or referencing this specific path and then following it by print working directory. So local packages, Microsoft sticky notes, local packages, Microsoft sticky notes, local state, plum SQLite, local state. So we have two potential answers here. So there, we'll do the first one where it's just local state by itself, and we can use all of the backslashes, so that's great. Local state. Now, local state is not separated by, let me see. So this feels weird. Oh, I see. So I need to do the C dot, and then we can do that maybe? Could that be it? App data. Nope, that's not it. Definitely can't be it. So we need to see if there's anything else that we can pull, but it's very interesting. So let's see what the hint says. The hint says trace back the executed CD commands. Interesting. Okay. The only thing that I can see that would actually be a potential file that was downloaded is this plum SQLite portion. So we need to, and that would be most likely inside of the local state directory. And so if we're referring to the CD commands, we would probably search for local state, I guess. So I can do local state as the first portion of this, and then we can also grep case insensitive, let's say CD. That could be one of the things that we could search for, and nothing comes out of that. So let's just get rid of the CD portion of it and grep the local state, and local state pwd, app data, plum SQLite, etc. So let me see that I feel like this is the file. So like the only thing that would make it kind of complete, I guess, would be where app data would be located inside of the overall machine. So if the user that this was done on, so the compromised user is who? It's Westcott. So if the compromised user is Westcott, right, then we can probably find references to J Westcott and plum SQLite most likely. So let's see if we can do something like that. So first I can just do plum SQLite. Let's see what shows up for that. This is the only instance of plum SQLite that shows up. So let's do a search for is it Westcott or Westcott? I think it's Westcott, right? Let's see. It's Westcott. So for Westcott, let's see what shows up. Okay, so the username is J Westcott. Okay, we're making a little bit of progress here. That JQ command is not making anything nice for us, which is kind of annoying. Okay, so here we go. So this might be a good path here. So we have C users J Westcott. That could be the intro to this. And let's see if there's any other references that I can use that would potentially be useful here. So C users, J Westcott. Okay, so we combine a few different searches. The first one is the search for that SQ3 portion that gave us this full path that we have right here, right? So I've also searched for app data because I'm trying to find the full path to the user. So if we actually search for SQ3, if you remember, we just saw this full path, the app data, local packages, which gives us the Plum SQLite, which is most likely because it's been combined with that SQ3 downloaded executable. That's the one that was used to get this file, or that's the file that ultimately we ended up with. The thing that we need to find is the full path, including C, backslash, etc. And so they give us as a hint to look for anything that has to do with CD. And obviously there's a bunch of script block IDs that give us this information. And then there's a few different pieces of information that have to do with the script block text parameter or attribute. And then so we have the CD to the users. So it goes like this, right? So if we go CD C and then CD users and then CD J Prescott or J Westcott, and then from there they were able to go into or launch this piece that they had over here. So if I scroll up a little bit more, we can actually see that we also have this right here, CD app data, etc. So if we combine all of these together, it would be C users, J Westcott, and then app data, etc., etc. So I'm gonna take this full thing right here, and we can kind of just manually input the rest of it. So it'll be C dot backslash users backslash J dot Westcott backslash, and then we can paste in the app data portion of it. Or is it not pasting? Let me see if I can paste it. And that should work, right? App data, and everything seems to be fitting perfectly. So let's submit that. Okay, cool. That's it. So yeah, we had to trace a few things. We had to, number one, we were going to trace the actual the file that was accessed using the downloaded SQ3 binary. So we search by SQ3 first, and then it gives us the path of the file, which is this piece right here, that app data, and then it goes the full path to the Plum SQLite. So that's the full path to the actual file itself that was used, that SQ3 was used to access. And then we just need to be able to find the location of where that whole thing was sitting, and we had to narrow it down by just searching for this CD. And the command for that is very simple: cat PowerShell JQ and then grep for the term CD. And then that's it. That's what we got. And so you just trace it at that point, right? So if somebody's CDing and then printing that working directory, and then they CD to users and then print the working directory, and then they CD to J Westcott, print the working directory, and then from there they also there was another CD that went into the app data PWD, which is probably available at some point right there. So music PWD, public PWD, etc., and then app data PWD. So all of these things are actually accessible for us. Documents PWD. So if you trace it piece by piece, you end up getting that final notice, which will end up giving us this full location right here. And then you just combine that with the user's J Westcott, and then you add it to the end of it. What is the software that uses the file in Q3? So the software that uses the file in Q3. So now we're going to run for Plum SQLite, I'm guessing. So that'll be the thing that we will search for. So if we just search for SQLite, we can see that, because this is the only thing that actually shows up. So this is the only software that really I recognize. It's Sticky Notes from Microsoft, and that's pretty much it. So I wonder if it's actually Microsoft Sticky Notes. Yeah, well, it fit for the template that they gave us. So it is Microsoft Sticky Notes. And what is the name of the exfiltrated file? And let's see if we can find that information. All right, so here's what I found. The very first thing that I did was I just started searching for J Westcott. Now, for whatever reason, even when I use JQ, it doesn't prettify the output. It still kind of gives this jumbled output or whatever. But You just scroll up a little bit. You don't have to go too far. And then you see for the field script block text, there is what seems like a command. So, there's the variable file that's being created that actually has this protected data.kdbx that is turned into this variable, and then the destination location is this IP address, and then the bytes are the system IO read all bytes of this specific file variable. And that very much looks like somebody's trying to transfer something out. It looks like very much a command that's being used to transfer it out. So what I did then, I did the same thing, and I just extracted the script block text field, and then I grepped for J Westcott, and then we get this short output. And then so we have script block text CD and then ls of this location, and then we have this final value for this field that is officially the command. So it says file documents protected So that is most definitely the script or the command that is exfiltrating the files. So the question now is, what is the name of the exfiltrated file? And that would be protected data.kdbx. So let's see, protected data.kdbx. Very good. Your answer is incorrect. Please, sure. I mean, what do you mean? That's literally the name of the file. Oh, and I see it's an underscore. So protected underscore data kdbx. Okay, very good. What type of file uses the kdbx file extension? So we could just Google that real quick. I think it's a database though. So it's a KeePass database file. That's what it is. So that one we can kind of, because DB, usually if you have DB in there. Oh, so KeePass. The answer is incorrect. KDBX file. What type of file uses the database file? Or data KDBX? And it is a database, so I mean, I don't understand. What would be the other answer? KDBX extension. So let's do a little bit of more researching, I guess. Oh, you know what? It's a password database file. So maybe that's what the answer is. Maybe it's a password file. No, that's not it either. So it's not database. It's not KeePass. Oh, it is KeePass. I just spelled key as in KEY. So it's a KeePass password management file or password database file. Okay, so that's the type of file that uses KDBX. Very cool. What is the encoding used during the exfiltration attempt of this file? So let's go look at the command here. And the encoding would be in here somewhere. So let's see what it is. Okay, so a few different search commands, and finally ended up with the cat PowerShell JSON. We still pulled the script block text field, and then I grepped for the B packaging domain, assuming that that's where the data would be exfiltrated to. And we did see a few different domains, like subdomains as well, at the very beginning of this. And so, we have the CDN location where the command and control whole request is happening, and this entire thing is just one block of text. And then we have another one where they did the update that they pulled, and then we have these two, which were the web request, the invoke web request command that they were downloading the SB and SQ3. And then finally there's this element right here that shows us there's a split variable that has the hexadecimal variable inside of it, and that's actually being split. And for each line in split, do this. So hex would be an encoding. So if we're trying to use an encoding hex, there you go. So hex would be the encoding. And what is the tool that's been used for the exfiltration? And in this particular case, we can also see the tool in this final command, and this is an actually tool right there. So NSLOOKUP looks for the DNS records of something. That's literally the only other tool that would actually even exist in this line of code, because everything else from here is not referencing a tool, and this is the only other one apart from the one where he prepares the file, and yeah, NSLookup is the right answer. Apart from the command where he prepares the file, that protected data file, apart from that command, the only other command that would make sense would be the one that is using NSLookup for the exfiltration. So that's pretty much it for the looking at the headers and then the endpoint security. And now we have to look at the network traffic so we can see what else we need to do. Obviously, we got to call the bank, so that seems to be a big deal. So let us finish this whole thing up. All right, based on the log of investigation, we have seen the full impact of the attack. They were able to read and exfiltrate 2 potentially sensitive files. The domains and ports used for the network activity were discovered, including the tool used by the threat actor. And the investigation now is trying to look for the network traffic. So utilize the domain and ports discovered, all commands executed by the attacker and all command outputs were logged, and follow the stream of the notable commands discovered from PowerShell. Based on those logs, we can retrieve the contents of the exfiltrated data by understanding how it was encoded and extracted. So what software is used by the attacker to host its presumed file payload server, what HTTP method is used by the C2 for the output of the commands executed by the attacker, what is the protocol used during the exfiltration activity, what is the password of the exfiltrated file, what is the credit card number stored inside of the exfiltrated file. So those are the last few elements that we need to find. So first and foremost, so it says what's the software that's used. The hint, it says review the headers of the HTTP requests going into the server hosting malicious files used by the attacker. The headers of the HTTP requests going into the server. So let's go over here. First, we have two big pieces of data that we can mess with. The destination in this block of text, which was the one that was preparing the password file, is this IP address. So that's where it's supposed to be going. And then the destination in this one is the line bpackaging.xyz. So we have those 2 elements at the very least. Now we have a package capture file that's over here. So I'm going to open that up and it's going to open up automatically with Wireshark, and we're going to filter through the packets that are available inside of it to see what we can find for the HTTP headers and information. So it says what software is used to host the presumed file payload server. So let's see what we can get. Okay, so the first search query that I have is the HTTP host contains this bpackaging.xyz. There are multiple domains, right? So if you remember, there were multiple subdomains. And the very first packet that we actually see once it's filtered, so there's literally 48,000 packets, excuse me. And then now we have narrowed it down to 932, which is actually not bad. And the very first one that is revealed to us is the files.bpackaging.xyz. So let's see if I narrow this down and let's say this equals to files.bpackaging. So that's what that query is now going to look like. So our display filter is now files.b, and we only have 3. So excellent. That's amazing. So what's the question that is asking? So it says what software is used to host that file. So we need to look at the headers of this thing. And if I remember correctly, I think if we go to view, it's either under view or analyze, where we can actually see the header. So let me see where that was located. Okay, cool. So it's under analyze. So let me go back. It messed with my filter and I don't want to lose my previous filter. So it's the files bpackaging. And so we'll use that and it'll go back to this. And if I click on this guy again and then click on analyze at the top right here, and then we'll go to follow and then we say follow HTTP stream and we do that. And then it pulls all of the other packets that were related to this conversation. And so this is what we have. So the HTTP server here is simple HTTP. The software is Python 3, I guess. And that's the only thing that seems to be relevant. And then we have the commands, obviously, that he ran as he was running. So ran as he was running. Python. Okay, so Python is the software. Python is a language, so I can't imagine Python being a software, but I guess Python is the only one that's available because we looked at the header, the HTTP header request, going to the server. Okay, cool. So what HTTP method is used by the C2 for the output of the command? So now we can actually look at this information. So we have multiple request headers that we have. So we have the get request, and let me see if I can go back and forth, or we'll just look at the stuff that's going over here. So we have we did. So what's the hint? It says yeah, so we did have a domain name at the very beginning of this, right? So when we found, I don't think it was in part 1, but there was one of the domains that we found where it was actually the domain of the server, the C2 server. It's the CDN B packaging. So let's go and turn this into http.host contains, or it could also equal, but whatever. So we'll do cdn.b b packet. Ugh, the spelling kills me. And there we go. So we have that now. So let's do this here. And so we have get request, and then we have post request. So get request is when you're pulling data from something, and then post request is when you're sending data to something. And we only have get or post request. That's pretty much all of the requests that are being made from here. And the question specifically, the way that it's phrased inside of the question is used by the C2 for the output of the commands executed by the attacker. So it's used by the C2 server for the output of the commands. So if all of these things, let's see, if it's a post request, all of it is the same IP addresses. So there's 1010, all of those things are exactly the same. So if it's being from, I mean, I would assume that it's this, yeah. Because getting is when you're pulling data from it and you're getting input from it, I would assume. And posting is when you're sending data. So the way that the question is phrased, and I mean, the hint really didn't give us anything, and just based on what I understand, post is when you're sending data, get is when you're receiving data, and if the command has been executed by the attacker, the C2 server is sending data. That's really the only logic that I can kind of think of when it comes down to that. So now it says what protocol was used during the exfiltration activity, and the protocol is HTTP. The exfiltration activity. So under the protocol column, we see that everything is TCP, but when you actually go into the packet details, just so you know, there, like as far as transmission of data is concerned, there's literally only 2 general protocols. You could either have transmission control protocol, which is TCP, or you can have user datagram protocol, which is UDP. And transmission control protocol requires a connection to be made. UDP is connectionless, so it doesn't require a specific connection to be made. And for every single conversation that we have, and you know, as far as networking is concerned and understanding what that means for something to have a connection, when you look at stuff like that, for the most part, everything is going to be TCP or UDP basically. And if you want to learn more about this, you can just go look at the Network Plus playlist that's available. So I would presume that this would be a TCP protocol, and that's interesting that. So it's neither TCP nor UDP. That's interesting to me. So that is something that I'm very, very interested in to see what the potential answer of this would be, because that's so silly. How's that not even? So let me see. Okay, so there's actually something else, I guess. So there's the DNS protocol, the domain name system, domain name service, and this is the hint right here. So the NSLookup tool was the tool that was used for the exfiltration, if you remember from our last segment. So NSLookup deals with DNS, so the domain name service, the domain name system. And if they're using this block of code to send the data, to exfiltrate the data to the line B packaging website, and they're using NSLookup, that means they're using the DNS protocol. So that is the answer for this one. Now it says, what is the password of the exfiltrated file? It's stored in the database file accessed by the attacker using SQ3EXE binary. So let's see how, there is usually a way that you can extract the objects that are attached to a packet capture file. So if we go to File and see if we can export objects, there we go. And then we're going to try to export the HTTP objects. there is a lot of HTTP object, or yeah, there is a lot of HTTP objects. And we're specifically looking for a file itself, the file itself. So let me see if I can actually find the file name that we're interested in. Okay, so there was nothing here for my system seems to have frozen. There's nothing here for the name of the file that was extracted, and there was nothing here for the KDBX, which is that the extension of the file. So none of those things unfortunately exist inside of our exported object. So another way that we could do this is we can use the name of the software that was used to exfiltrate the file. So if you remember the executable name, so if we go back over here, we may be able to see the executable name that was used to extract it. And so we see right here, so SQ3, and then you have the potential, hold on, let me see. There's also, it was used earlier on as well when it was trying to extract the database file, that plum something, whatever it was. So SQ3 was the name of the file specifically that was used to extract the document. So let's see if we can actually find something that contains SQ, or let me put it in here. So SQ3.exe. Let's see if that exists at all. And it does. It actually does exist. So we have get SQ3.exe, which is something that I believe they used to download the file that we were looking for. And then we're trying to find something that has to do with the data transfer. So there's literally only 4 files. So or 4 packets, excuse me. I'm gonna go through the data of these things to see which one would be of interest to us. And one of the hints is usually the ones that are later in the timeline would have to do with the data that was exfiltrated. So if we look at the last one, presumably that would be the one that actually has to do with the data that was exfiltrated from what we're looking for. So you actually can see it right here as well. This was the original command, right? So music, SQ3, and then app, data, local packages, Microsoft, sticky notes, and then local state, plum, SQLite. You see that, right? So that's probably the packet itself. So let's see what we can find when we now analyze this packet by following the HTTP stream for it. So this is the one that is actually making the request from the SQL database. So you see that there's a select everything from the note and then limit 100. So this is the original request that's happening, and this is the very first packet that we saw. And so this is the TCP stream of 749. So this is what you can see that has been changed over here. So TCP stream 749 is what yielded that packet for us. So ideally, the next one in that stream would be 750. And so that should bring up this interaction for us. And if we go ahead and look at, let me see, this is the one that's highlighted. So if we go ahead and analyze this thing, let's see if we can actually get any data from this one. The data of this one, and it is actually coming from the CDNB packaging website, so that's good. And it is a post request, meaning that it's actually giving us some of the information that we're potentially looking for here. So from here, this is the data that's been encoded that we need to decode. This is not base64 encoding. If you recognize what we saw with base64, this is very, very different. So we're going to highlight this. We're going to copy this. We're going to go to CyberChef, and I'm going to delete this portion right there. And I'll go ahead and paste the stuff that we found. And now we use this magic wand to give us the information, and it is a decimal encoded. So this is decimal encoding. And now we actually get to see the data here. So master password, that's the password that's been extracted. So now from here, we should be able to actually see the password. And this, of course, is for the J. Westcott user that's making this request. So now we just need the password. The way that this seems to be separated is through these backslashes that we have here. So this first ID is the master password. The next ID looks like this might actually be the password. And then separated by this pipe, and it goes to manage position. So that seems to be the password. And it is a pretty complex password, so I'll give it to him for having that. So let's see. Is that the answer? Cool. Okay, that is the answer. Nice. That was cool. All right, that was a cool little experiment to be able to gather that information. Nice. All right, so I think we have literally one more question to finish this exercise. Yeah, so where's the credit card number stored inside the exfiltrated file? And retrieve the exfiltrated files using T-Shark and focus on the query type used in the PowerShell logs. So retrieve the exfiltrated file using T-Shark. So oof, I gotta dust off my knowledge when it comes down to T-Shark. It's been a minute since I've used it. It is a command line tool. I know that much. So I'm gonna go to my terminal. I'm actually gonna keep this one open because it has a lot of the history of the data that we have. So I'll open up a new terminal, and we're going to go to our desktop artifacts location. And now we're supposed to look at the capture file. So we're gonna do T-Shark and then R to read the capture file. And so let me zoom in on this a little bit for you. I'll drag it over here so it's easy for me to go back and forth between my two windows, because I really do need to look for the command that extracts data using T-Shark. So it is capture.pcap. That is the information. And now we are going to look for a field. I need to pull up my notes. I don't remember how to craft this command, so give me a quick second. Okay, the first command that I ran was just reading the pcap file using T-Shark, and then the Y that you see right here is helping us to extract certain fields from it. So -Y is a display filter, essentially. So when you do the -Y and you use the display filter, now you have to give it the display filters that you want to customized by it. And this is no different from putting these fields inside of Wireshark. So dns.query.name is actually a field or an attribute that you can filter by. So we're going to do dns.query.name matches the B packaging XYZ. So this is a regular expression that would be used. And so we do 2 ampersands to include that we also want the destination to also be the IP address that we found earlier when they were doing the exfiltration, when they had started the exfiltration. So when we run this, we get these series of requests, or these responses, excuse me. And so we see B packaging XYZ, and then we also see there's B packaging XYZ and then .eu west, and then it's going to Amazon AWS. So probably we want to remove all of the ones that have to do with this, the EU West, the Europe West region of Amazon, because this is just the Amazon domain, and it doesn't have anything to do, or not that it doesn't have anything to do, but I don't think this is where the exfiltrated data would be at. I think this is just maybe a proxy server that they're using potentially, or it's like the in-between server. So what we want to do is we want to remove that piece from it, and I should probably also just extract a specific field in here, because there is other data that's being extracted for us as well. So I want that specific field that I would be most interested in. The capital T, I believe, is the command that would go ahead and pull a given field for us. So we will do let's see how that breaks down. It would be capital T, and then we give it the field name, and then we're extracting a specific fields, and then we're extracting, so we'll do -E to extract it, and then we want to extract the DNS query name one. So if I do that, it should give me, yeah, okay, it's a little bit of a cleaner output. So we still do see the EU West one, and then we see the B packaging just by itself. So we will run that same command one more time. Now we're going to grep the inverse of something. So when you do grep and you want to show anything that does not include a specific field or a specific value, technically you would do V. So it's basically going to look for whatever I tell it right now, and then it's going to show me everything that does not include that in it. So it would be EU West, right? And that should only show me the stuff. There we go. So this only shows me the stuff that does not have EU West in it. So we're getting a little bit better of a filtering here. So we need to now essentially try to find a way to pull the information that we need. We need to pull that data that we need out of these packets, which is there's a good amount of stuff that's going on here. So there needs to be something that hopefully we can craft together to extract the data. So this I'm gonna step away from. I mean, I'm gonna cut it, so you're literally gonna see like me with the answer. But I need to do a little bit of homework here to see how I can go ahead and pull that information from it. Okay, the one thing that we can first conclude is that this is where the data is. All of this stuff that you see right here, this is actually where the data is that we need to extract from these specific queries and from these interactions that are happening with Bpackaging's website. So what we need to do is we need to remove all of these and just only extract these. Now, at the beginning of this video, at the beginning of this room, they said that we need to learn, or we need to use the tool SED, S-E-D. And SED is actually used to replace the content with another bit of content. So there's a specific formatting that is done to do it. And the formatting itself is essentially this. So let me kind of zoom in so you can actually see what's going on. So the formatting is like, so you do, you know, S and then /, and then there is the old data or the old value, and then you want to replace it with the new value, and then you do G at the end of it. So it would be SED, and then you would put something like this in the middle. So this is kind of the full command of what it looks like. So it would be SED, and then you would do S dash, and then the old value / the new value, and then you would do G, and then you would close it off. So in this case, the old value for us is going to be the .bpackaging XYZ. This is the old value, right? And then what we want to do is now we want to replace that old value with basically nothing, right? So technically, so let's actually run like a test version of this so you can kind of see what this looks like. So we'll run the same last command that we had that removed grep EUS, and then we'll do SED, and then we'll do S, and then I'll do .bpack. The spelling, bro, the spelling is like what kills me. And I'm gonna do /, and then just for the hell of it, I'll do new, and then we'll do G at the end of that, and then we'll press enter, and then it's gonna essentially just replace everything. And I mean, it didn't do it. So that's kind of, well, that's so annoying that it didn't do it. I think I may have maybe mistyped it or something like that, but it should do it. So that's the thing that I need to verify to make sure that the value is potentially right. And maybe it's because I used the word new as an example. Maybe that's why it didn't work. So let's run that one more time. I'm going to try to see if I can actually make this work. Oh, I see. So it's because the reason I actually misspelled packaging. So there's an A missing. So let's try that one more time and see if that actually works. Okay, cool. So see, now it actually added new at the end of it. So it's because I literally misspelled Bpackaging because the freaking spelling of it is so annoying. Okay. All right, so now we know that we can essentially search for a given value and then replace it with a new value. And in this case, we replaced it just with the word new. So what we want to do is we want to replace it with nothing. So we want it to just give us the values themselves. So if I do this, then it'll just display all of the values. And there we go. This is all of the stuff that was followed by that .bpackaging XYZ. So now we just want to output this so that we can create some kind of a script to essentially just kind of parse through all of these values and see if there's a way that we can extract the data. The type of file, or I'll just do raw data, and then we'll have a binary extension to the data. The reason for this is because we want it to be raw. We don't want to have any kind of potential confusion later on as we try to process through this. And I mean, it really, at this point, it kind of doesn't really make that big of a difference on what we extract this data to, because it's essentially just going to read this line by line. So that part isn't really that big of a deal. But it might be a little bit more convenient later on if for whatever strategy I have to use to try to now extract the data from this, which is actually out of my depth. So I do need to try to find some information to see how I can go ahead and extract this data or extract the values from this data, and we can hopefully do it successfully. Okay, so the very first thing that I need to do is figure out what kind of data that we're looking at, and it is hexadecimal characters, and we don't need to, I mean, if you want to know what hexadecimal is, you can always go ahead and read up on it, but I need to know what type of character it is so that I can go ahead and try to decode it somehow. And one of the things that specifically we were talking about earlier inside of the exercise is the type of file that we're dealing with, right? And so if we go ahead and remind ourselves real quick what type of password file they had downloaded, it was the KDBX password file, and it was using the KeePass software to actually read it uses KeePass, and you would need to use KeePass also to go ahead and use it. And it actually also, we were given the exfiltration of hexadecimal anyways, so we also have hexadecimal in that answer as well. So there's a few different hints that we've already gathered, and one of them is that it's hexadecimal data. The other one is that the original password file, the protected data file, was a KDBX data file that was protected, and then we have the password as well that we got for that. So we need to essentially reconvert this data from this hexadecimal format back into KDBX essentially, and then from there we would open it up with a tool that can read KeePass or that KDBX extension, and hopefully it'll actually have the data that we're looking for. So this is our raw data binary file, and I'm going to close this out here, and we need to create a basic script that would just convert it for us. So I'm going to clear this portion right here. I will do nano, and I know, so let's see, what would be a good tool that can convert hexadecimal into KDBX or at the very least decode hexadecimal for us. So let's see. Okay, cool. So we can use the bin ASCII data, or the bin ASCII module kind of library that's available for Python, and to be able to convert the data that we have from hexadecimal to something that would be KDBX, which is the KeePass database. So bin ASCII is actually a module that should be available kind of like by default. We shouldn't have to download it in any way. So let me see. I'm going to do like converter .py. So we'll create a converter.py file. We're going to do the shebang bin, and I actually need to know where the Python file is, or where the Python interpreter is. So let me see if I can I need to be able to locate my Python interpreter. Okay, so I have Python 3 installed, and I need to see where Python 3 is located. So it's user bin Python 3. So it's in my user binary location. So that would be the location of my shebang file. So do I still have my converter? No, I don't. So nano converter.py, and then it would be shebang, and then we would do user bin Python 3. That's where it is. Okay, so now from here we need to actually import the bin ASCII library, the bin ASCII module, and then write the script that would hopefully go ahead and convert that data for me. So I completely forgot what the name of my file was. That is the raw data.binary. So that's the name of the file. And now we can hopefully hopefully I'll be able to write a decent script that would make it work. Okay, I want to say that that's it. I can't imagine that. This is a very, very simple script. We have the input file variable, which is going to be the raw data.binary, and the output file, which is the data KDBX. So these are the two variables that we've created. We imported the bin ASCII or bin ASCII module, and then so we're going to open the input file in read mode as the input variable, and then we're also going to open the output file in write mode as the output variable. And then for each line in the input file, we are going to strip that line of its spaces or anything that would be available. So we're just going to take that specific line, and then we're going to use bin ASCII. So this is where the bulk of the work is being done, basically. The bin ASCII unhexlify. I think that's how you write it. I have to verify this. We'll run it. We'll see if it actually works. And then the output file is going to write the binary data, which is going to be each line that has been decoded. So let me just make sure that this is actually right. Hopefully it is. And then we'll run the code and we'll see how it works. All right, so I have confirmed that this is the right script, the right formatting of the script. And yeah, so the main reason why we want to have this in binary is so that this actually can be converted into a KDBX file. We are writing in binary mode, and everything else has been right. So this reference right here for bin ASCII unhexlify is also correct. So we're now going to write that, close that, and cross our fingers. And let's see if we can actually get this file to work. So we're going to use the converter.py, and it's going to run. And now let's see if we have a data.kdbx, which we do. And now we got to see if we can actually open this freaking thing. I don't know if KeePass is actually even installed or how I would even read KeePass. So let's see if we have KeePass over here. Okay, so I just found out that this virtual machine is not connected to the internet, and I cannot download KeePass on here. And to be honest with you, I was not able to find KeePass installed. Oh, I'm so blind, bro. It's literally, I was just about to like copy this on my computer and go ahead and freaking do all of these things to transfer this raw data on my own computer and download KeePass on my own computer and run it. But apparently I can't see or something, and I completely missed this freaking file, missed this software. So we are going to now run the file inside of KeePass, and hopefully it'll work. So we're gonna open the file. I feel so silly right now. You don't even understand. Desktop artifacts and then data KDBX. There it is, and we're gonna open it. It's gonna ask us for the password. Okay, great. So let's go and grab that password that we had over here, which is this whole thing. So we're going to copy that, go there, and we're going to paste that. And okay, company card. Look at that. We got the company card. So we click on that and we have the information. Oh my gosh, this feels really satisfying, yo. This feels so freaking satisfying to actually be able to pull this information. So how do I copy that now? Company card, there we go. Properties, data, account number. There we go. Edit the account number, grab the account number, copy it, go over here. This is it. This is it. Yes, excellent. So this was a nice challenge. I really enjoyed this. It taught me things, and I got a chance to flex my muscles a little bit and practice the skills that I needed to. And there's only a few other rooms that are left in the SOC level 2 or SOC level 1 path for these practical exercises. So as a review for everything that we did, right? So let's zoom back in this. Let me just close everything out so we can kind of move on. I'm so excited that I got a chance to actually even finish this. This was very, very satisfying for me. So what do we have as a review? We obviously just reviewed everything at the beginning. They told us what we needed, and then we went into the email analysis part, and this was very, very easy to do. Most of this information was readily available by just looking at the email itself. So this is the person that emailed her. This is Julianne Westcott, the person that got the email. We had to look at the headers, and we did that by just looking at the email source. So when you open it up inside of the Thunderbird application, you can just look at the source of the email, and then you just search for DKIM signature, and there were 2 segments, and the second one had elastic email in it. And then the name of the file that was inside of the encrypted attachment. So we just had to download the zip file and then not unzip it. Yeah, unzip. Yeah, we had to unzip it. We had to extract the data from it. And from there, we got the LNK file. And then inside of the email itself, they gave us the password. And then we all we literally had to do was just run this link parse, and to get the link file, which is this thing. So you run link parse, give it the name of the link file, and then it'll give you the command line encoded payload, which was just this little long piece of base 64 encoding. So that was that segment. And then to look at, this was a little bit of a heavier part. I think this was the part that took me the most amount of time to go through, and we had to use the PowerShell JSON file as well as JQ to kind of prettify it and then extract some data from it. And so the very first one was the extraction of the domains, right? So first it was the inside of this, they didn't really give us anything except just this piece. And this is what you'll find in incident response, is that the information that you gather kind of stacks on top of each other. So this was the first key piece of information that we gathered that stacked, that was used throughout the rest of this investigation. So if you go through the commands, right, you do cat and then PowerShell JSON and then JQ and then grep for the B packaging XYZ. And that's how we got these various domains that were available to us. And then we got CDN, which was for the command and control, and then files, which is what they used for their file server. The name of the enumeration tool that was done by the attacker was, again, available by simply just going through the web requests. And they didn't do the invoke web requests written out. They did IWR. So that was the one thing that was useful to be able to find that information. And then getting the path of the file, that was the one that kind of was a little bit difficult for me. And so we searched for the sq3.exe first, and then from there we found this portion of it. We found the app data and everything like that with the Plum SQLite. And then the hint that they gave us was to trace back the cd command. So the next thing that we did was we grepped for just the term cd. And then from there, we were able to find the fact that, you know, he first went into the C location, then he went into the users, and ultimately he went into J Westcott. And then if you combine all of that, you get this full path. And then inside of this, you also get to see that he used Microsoft Sticky Notes. Microsoft Sticky Notes was the software that he used to read the file. And then the name of the exfiltrated file, which was, this was a little bit also a bit of a mission for me to try to find. And for that, I want to try to recall the information that I did. But I think for the exfiltrated file was, I was looking for the name of the website that they use. So the B package XYZ, as well as the extension of it, which was the files.bpackageXYZ, and then there were just a few different extensions as well that we searched. So the J, what's her name, Westcott. We looked for J Westcott, and there were a few different, and you can literally go and look at all of the details of this because I outline every single one of these things. So I'm just doing like a review right here. But we found a KDBX file that he was exporting. We found out that KDBX is a KeyPass file. We found out that it's encoded in hexadecimal, and then the final tool that he used for the exfiltration was NSLOOKUP. And then we looked at the headers of the packet inside of the Wireshark, and we looked for, again, B packaging or B package XYZ, B packaging XYZ, and then we found that the very first one was the Python. So we just looked at headers of it, and that was it, the HTTP header. And we narrowed it down for the C2 server, which is the cdn.bpackaging.xyz. And then when we looked at that, we saw that there were only either get or post headers. And then when you're looking at output, so the C2 used the output of the command. So that's usually when you send data. And when you send data, you're using the post request. The DNS protocol was used because he used NSLOOKUP to do the transfer. So he was using DNS protocol. The password of the exfiltrated file was an interesting one. So we had to trace the conversation. We had to trace the originally when we found the very first one that was being done to their files.bpackagingxyz. When we looked for that domain, the very first one was the initial command that was actually sending the data to it or requesting to send the data. And then the second one, the second sequence was 750. I remember that part. That was the one that had the reply. And then we had to just decode that reply. So we used CyberChef to decode that reply, and we got the actual password. And then finally, this was the piece right here. And this was the piece that we had to use T-Shark and then that whole lengthy command. And that was also something that I had to like, not, you know, dust off, knock off the dust or clean off the dust in my T-Shark skills to be able to pull that data. And then we were able to extract the data and kind of filter down the data. And then we used sed to replace that .b packaging XYZ with nothing so that we can just fully extract that into raw binary. And then we use the binary ASCII module Python library to go ahead and convert that into proper KDBX, the proper KDBX format. And then we used KeyPass to open it. And that part was super satisfying. So that was the whole run through. This was very, 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 very cool freaking exercise. I absolutely very much love this exercise. I feel great right now. I'm on a great rush because I feel like I learned a lot from this. So that's great. I hope you were following along with this as well, and I hope you got a lot of value out of it and you were able to accomplish everything that we accomplished, and hopefully you understood what was happening. Hopefully you kind of understood the logic behind everything that we did to get the results and the responses that we got. To get more videos like this one and to get updates in the future about everything that comes out of this channel, I encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. If you have any questions about what went on today, please drop it in the comment section. I totally do understand that this was more of the complex strategies that we've done, and it was more of a complex room compared to everything else that's happened. So unless you've gone through the basics of cybersecurity with CySec 101, and unless you've gone through all of the introductory videos that were inside of the SOC Level 1 playlist, which this is technically a part of, unless you've gone through all of that stuff, you're going to have a hard time to understand what just happened in this video. So you will probably have questions and you will probably need to ask whatever it is. So I respond to all of the questions, but I will most likely refer you to, hey, go watch this video. If you haven't seen that video, you need to go watch that video so that all of this ends up making sense for you. But drop a comment. I always welcome comments. I always respond to all the comments that come in. And of course, go check out whatever videos are available here that would be relevant to what you're needing, or what the information is that you would be needing. Everything is in great detail, so you'll get a lot of information out of it. And of course, like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel, because there's a lot of stuff that's going to be coming out very, very quickly, very soon. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section, and that is it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you, and I will see you in the next video later. In today's video, we are going to take a round 2 with Boogeyman, and he, after we caught him, after we got rid of him, he came back and he has improved his tactics, techniques, and procedures. So it is literally a continuation from the last video that we did on the SOC Level 1 pathway of TryHackMe, and these are the Capstone challenges. So these are the SOC Level 1 Capstone challenges that come at the very, very end of SOC Level 1, and it's a 3-parter. So we take 3 rounds with Boogeyman, and this is going to be officially our 2nd round with Boogeyman. And as the whole thing breaks down, obviously we have the introduction, and then we just have the spear phishing that is done against the human resources department, and all of the questions are just kind of rounded up and collected inside of this one big task that we have over here. So that is how it's going to be played out today. That's the outline essentially of the video today. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master, and each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@hankhacks hackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the Boogeyman 2 room. Alright, here's the update on the scenario. So after a severe attack from the Boogeyman, the Quick Logistics LLC company improved their security defenses, and the Boogeyman has returned with new and improved TTPs, the tactics, techniques, and procedures. In this room, we are going to analyze the new tactics, techniques, and procedures of the threat group named Boogeyman, and the prerequisites are to understand phishing analysis fundamentals and the tools that are used for that. We need to obviously go through Boogeyman Part 1, so if you haven't gone through that, then I don't know, it doesn't make sense to go to Part 2. And then we're going to use a tool called Volatility, which is specific to investigating RAM memory. So the random access memory, also known as volatile memory, is the key element, it seems to be, in this particular video, because I think he has learned how to cover his tracks and not leave anything behind. Very different from what happened in the last video, in the last attack that he had against us. So most likely he's going to be only doing things inside of the volatile memory. And volatile memory, as kind of a reminder for you, it's the type of memory in your computer that gets wiped. It gets deleted every single time that you restart the computer, or if the computer accidentally shuts down or something like that. So it stays there if the computer is asleep, and it'll be recovered when the computer comes out of hibernation. That technically doesn't count as the computer shutting down or restarting. But if the computer does shut down, or if it restarts, anything like that, then you will lose all of the volatile memory. You will lose all of the data that's stored in the volatile memory. So when you're doing incident response and digital forensics, the more important artifacts to recover are the ones that are going to be in the volatile memory. And then after that, you get your disk image and everything else, because those things will stay there no matter how many times you restart the computer. So we are already deployed the virtual machine. This is again inside of TryHackMe, and this is one of the many perks that come available with TryHackMe, that you get these virtual machines that you can use, and there's attack boxes and all of these things, and you can do it in a controlled environment where you don't get any felonies. And that is what we're dealing with. The copy of the phishing email is available to us. The memory dump of the victim's workstation is available to us, and they are stored in the desktop artifacts folder. And we're going to be using Volatility, which is the open framework for extracting digital artifacts from volatile memory. And so this is the basic command, right? So vol-f, and then you give it the memory dump file name. So -f would be the file. And then you need to designate the plugin that would be used for, assuming that it's a Windows machine, there would be a series of Windows plugins or other operating systems. And to be able to get the full list of the plugins, you can just do the -h for the help menu. That brings that up. And I think when you actually do it with the file included, what it does is that it brings you the help menu specific to the file, potentially. Not really sure. And so what do we have? We have Olevba, a tool for analyzing and extracting VBA macros from Microsoft Office documents. This tool is also part of the OL tools or OLA tools. I guess OLVBA, maybe that's how you pronounce that. I just said Olevba. And so that would be, Olevba, and then the document. So Microsoft document, for example. So that's pretty much it. That's kind of like the only intro that we get into this, so that we can go ahead and try to extract whatever information we can get. So this is a big task. This is a very large outline, and we have a lot of questions that are available here. So I am going to open this up in my secondary monitor as per usual, and we're going to keep track of all of these questions and see what we can find as we go along this journey and try to figure out what the heck this guy did. These people, apparently, because it's like a group of attackers, right? So we got to try to figure out what these group of attackers did and what their freaking problem is. Anyways, so here we go. Let's go into the spear phishing that happened against human resources. Maxine is the user that got hacked this time around, and she's a human resource specialist working for Quick Logistics, and she got an application from one of the open positions in the company, and unbeknownst to her, the attached resume was malicious and it compromised her workstation. And usually the way that happens is that there's something in the macros of the document, and then when you open the document, the macros launch, and then whatever command was inside of those macros will actually go ahead and compromise your computer, do whatever it's supposed to do. And obviously in a lot of cases, because you're limited to the type of command that you can put, or the not limited to the type of command, you're limited to the length that you can put inside of the macros fields. So usually what is done is that there's some kind of an establishment of a reverse shell or like a C2 server connection, something along those lines that would allow the attacker from their end to start taking, moving towards their objectives, whatever, taking action towards those objectives. So this is what the email looks like. And of course, we have the attachment, we have the people that it was sent from, etc. And we need to answer all of those questions as we move forward with this. So, I can't, this is actually better this way. So it says, Dear Maxine, I am writing to express my interest in the junior IT analyst at Quick Logistics. As a recent graduate in computer science, I am excited to apply the skills and knowledge I have gained to a professional setting. During my studies, I gained experience in various programming languages, including Java, Python, C++. I also completed courses in computer networking, database management, which have given me a solid foundation in IT fundamentals. In addition to my technical skills, I have also honed my problem-solving abilities and attention to detail through various projects and internships. I am confident that these skills, along with my passion for technology, make me a strong candidate for this position. I have attached my resume to this email, and thank you for considering. This is actually a really great little introductory email. I understand why Maxine would believe that this is, this Wesley Taylor is really a legitimate applicant, and why not open up his resume and see what he got? So the security team was able to flag some suspicious commands executed in the workstation of Maxine, which prompted the investigation. Given this, you are tasked to analyze and assess the impact of the compromise. So what email was used to send it? What is the email of the victim employee? What is the name of the attached malicious document? What is the MD5 hash of the malicious document? What URL is used to download the stage 2 payload based on the document's macro? What is the name of the process that executed the newly downloaded stage 2 payload? What is the full path of the malicious 2 payload? The PID of the process that executed stage 2 payload, PID of the process that executed the parent PID of the process that executed the stage 2 payload. What is the URL download? The malicious binary executed in stage 2. What is the PID of the malicious process and the C2 connection? See, I told you there's a C2 connection. What is the full file path of the malicious process for the C2? IP address of the port, IP address and port of the C2 connection. Full file path of the malicious email attachment based on a memory dump. Attacker implanted a scheduled task right after the established C2 callback. This is for persistence. And what is the command that was used to maintain persistence? And that's it. That's the last series, or those are all of the questions. So let's start from the top. We're going to go to the artifacts folder here, and we're going to open up the EML file. And it's going to most likely, actually, I mean, you can extract it from here as well, but it's probably best to open it inside of Thunderbird, which is our email client here. But from the very beginning, we can get these first series of answers real quick. So it's from Wes Taylor at Outlook. So we're going to copy that and go and paste that. And what is the email of the victim employee? So we need to get Maxine's email address, which is going to be Maxine Beck at Quick Logistics. And we're going to copy that and paste that. What is the name of the attached malicious document? Now for this one, we need to actually open the email inside of, oh, we don't even have Thunderbird, do we? Interesting. So let's see. So if we open this window up a little bit more towards the bottom, we can actually see Microsoft Word attachment, and it is resume Wesley Taylor doc. So we will now copy that and then go over here and paste that. And come on, there you go. And what is the MD5 of the malicious document? So we actually do need to save it. So let me go ahead and click that, and I'm going to just save it. And we will save it inside of the same location, which is the desktop artifacts folder. And inside of that, we'll just save the attachment. And so we will now open our terminal. And you can literally, in almost every operating system that has a GUI like this, you can right click inside of the location that you want and then do open in terminal. And it'll just open that location inside of your terminal for you like this. And so we need the MD5 hash. So where's the file? That's the file, resume Wesley Taylor. So we will do, what is it? MD5 sum, and then we give it the name. So resume Wesley Taylor, enter, and there's the MD5 hash. Very, very easy to be able to get that. And MD5 sum is, I think it's available in all of the Linux or Unix distributions. And then for Microsoft, it is a different command, but it also comes standard with the computer or with the operating system. It's not something that you need to download. You should usually be able to just receive the MD5 hash or the checksum of whatever the documents are or the files are inside of a given computer. I don't know why this isn't processing. I know for a fact that this is the MD5 hash. We got it, resume Wesley Taylor. So why aren't you accepting my answer? There you go. Okay, it took a second, but yeah, it's taking a couple of seconds for it to process. I don't know, is it because the internet here is kind of slow? It's like a weird, it's so weird not being at my, because I moved to Vegas. I don't know if I told you guys this. Over the last couple of weeks, I moved to Vegas, and in LA, I had super fast internet. And now over here, it's not bad. It's 100 megabytes per second download, and in LA I had a gigabyte download speed. So it's a big difference compared to the old days of having dial-up internet and having to get all of that. It's still fast. It's still great, but compared to a gigabyte per second, it's definitely a big drop. So that is. Anyways, that's neither here nor there. Okay, so now, what URL is used to download the stage 2 payload based on the document's macros? And so this is where we go into our command line, and we will now need to be able to receive or we're going to use volatility. And so if you remember, we have the volatility help command that's over here. And so it's going to be the f memory dump raw in this particular case, and this is our raw file that has our memory dump in it. So we are now going to try to see what we can pull from that memory dump that was launched inside of the macros, because I don't want to open this file. I wonder if there is a way that I can actually analyze the document. We do have this, right? So, olevba document.doc. So let's see what olevba actually gives us. It might be able to give us the macros without us having to do anything. So olevba, and then we'll do resume Wesley Taylor. And let's see what we get. That was very quick, so I like that. So here we go. Suspicious, suspicious, suspicious. There's a lot of stuff going on here. So what do we have? We have the open write adobe.stream save to file shell, web script shell, etc., etc. And then the indicator of compromise is this files.boogeyman lol png. I'm guessing this is the full path that I can't. Can I even do this? How can I extract this specific indicator of compromise? Let's see. I think that is the path that they want. That's the answer that they're looking for, because they're looking for the URL that's used to download the stage 2 payload. I believe that's it. Now, the wscript exe and update.js, which is probably inside of the update png, or it's at least from this path right here. This is gonna, it's gonna copy everything. So that's the piece that I'm like, okay, well, how do I, let's see. I'll probably need to do it inside of like a document editor. So I'm just going to open up CyberChef just in case we actually need to use CyberChef at some point anyways. So we will paste it inside of the CyberChef input area, and most likely it's going to include all of the extra spaces and those characters and all that stuff. So yeah, so look at that. So we got to delete all of these extra things. So it needs to be this whole junk right there. That needs to be deleted. And then all of that needs to be deleted. And then all of that needs to be deleted. And where's the rest of it? There needs to be more. Or did I think I cut it off at that. Yeah, so that's pretty much the full thing without the update at the end. So let's try this real quick. If this doesn't work, we might put the update at the end. But I think, nope, that's not it. So stage 2 payload, that it seems to be the thing. So files boogeyman.lol, and then yeah, I think that's it, but I think they might want the update.png. So let's do the update.png at the end of that. Yeah, so they do want the full URL. So that full URL is the https boogeyman is back. That's what that says. Boogeyman is back.lol. Okay, well, whatever, bro. What is the name of the process that was executed, that executed the newly downloaded stage 2 payload? The process that executed it, it could be the wscript.exe seems to be the process that probably executed it. Suspicious open write adobe shelter file wscript.shell. And so by that, we can also conclude that it might be wscript.exe. Let's try that. Okay, great. What is the full path of the malicious stage 2 payload? So now we need to do a little bit of further digging and see what we can find over here, because I don't think it's going to be inside of the macros at this point. Oh, look, we have more information up here. Interesting. I could have just gotten it from here. I went through all of that. Oh my God, dude. Sometimes, honestly, I'm like, bro, what? Okay, so the full path is probably this thing right here, the update.js. So let's see if I can go ahead and copy that. Honestly, sometimes I'm like, bro, what are you doing? Like, what is wrong with you? There you go. What is the PID of the process that executed the stage 2 payload? Oh my gosh. I just want to crawl in a cave under a rock sometimes. This no longer is going to have the data that we need. I think at this point is when we go to the raw dump file, and from there extract the rest of the information. I'm just going to leave that inside of this terminal right here, and I'm going to open up another one because I do want to be able to re-access this information at some point. So we'll just leave this right there. And now we are going to run volatility. So there is the raw file. So we will do vol and then wk and then just press tab, and we'll do -h and see what we can get here. Okay, so there is a lot of stuff that is available here that I don't think this is actually specific to the file that we're dealing with. I think this is just basically all of the plugins that are available, or I'm pretty sure that this is the plugins that are available. I don't think this has anything to do with the specific the file that we're dealing with. We do know that it is a Windows computer based on some of the hints inside of the scenario itself. So we're looking for the PID, the process information, the process ID. So we can look for things like this. So we can look for the PS list, we can look for PS scan, we can also look for PS tree, and see what information that we can generate from that file, the JavaScript file, the wscript JavaScript, or I think it's actually the update.js, based on what the information here is saying is what is the malicious stage 2 payload, what is the path, it's the update.js. So what we're looking for is the update.js attachment that was included and that was launched. So we are going to do this, and then we're now going to Let me zoom in a little bit for you here. So we have the vol, and then we're referencing the raw dump file, and we are going to do the windows dot. Let's start from the very top. So we'll do windows.pslist.pslist like that, and then let's see what we can get from here. And it's giving me a bunch of information, but it's not saying anything. Oh, I think I need to say plugin. We need to actually refer to the usage as we're referring to a plugin. So let's try to do the command one more time. I just need to verify the syntax of the command. Basically, I think we need to actually say plugin inside of the syntax of the command. Let me just re-educate myself real quick. Actually, no, I need to do this. I need to go over here and I need to do a -f right there. And there you go. Now it's actually processing the file. And so it's going to get the process list for us. So that would be the first thing. We can also do PS tree. That would give us the process tree. That might actually be the better one because it does ask for the parent PID as well. And it would be useful to be able to find the parent PID as well as the process ID. I'm just going to let this finish and we'll come back in a quick second. Okay, so we now have the list of the processes and we're looking for the, what is the name? wscript.exe, or we are looking for the update.javascript. I think those were the two names, right? So we have update.javascript or wscript.exe. So let's see which one I can find. This feels like it's not a full list of stuff, but anyways, let's look at it. Let's see what we can find over here. Honestly, I already think that it would be just more useful to get the PS tree instead of this list that we're looking at over here. wscript.exe. Okay, so there we go. wscript.exe, and the process ID is this. So 4260 would be the process ID, and the parent PID is 1120, or the parent ID is 1124, I want to say. So let's see, 4260. And if we look at the columns at the very, very top, we should be able to see what each one of these now. Yeah, so yeah, this is actually useful. So PID and then PPID is what these two columns represent. So for wscript, the PID is 4260 and the parent's ID is 1124. So let's do that real quick. So 4260, and then the parent PID is 1124. Cool. So that works. And what URL is used to download the malicious binary executed by the stage 2 payload? So we need to actually pull more data out of this thing to be able to extract that information. So I mean, there's a few different ways that we could actually do this. So I'm going to try a couple of different strategies real quick, and I will show you the winning strategy. So I don't want to waste time or anything like that. So I'm just going to do all of my various attempts, and then I'll show you which one was the winning one. Okay, cool. So the one that actually yielded a result was the strings command that pulls just all of the strings from it without the binary, or it pulls the strings from the binary, I should say it that way. And from there, we just grepped the Boogeyman is back phrase, because that's the name of the domain that was used to download the first payload. So this is all of the stuff that shows up inside of the raw file. And then we actually see that we have several domains here, or several URLs here that have clearly downloaded documents here. So what was it? The first one was what? The first one was the it's the update PNG. So update PNG was the first one. So there's update EXE, which I'm guessing that's the other one. And then PNG, EXE, PNG, EXE, EXE. Yeah, that's the only one. That's the only other option that we have. So if I right click this, I wonder, can I just copy the link? Copy link address. So let's see if that works. Bring that over here and paste it. Cool, just like that. So what is the PID of the malicious process that used to establish the C2 connection? So in this particular case, I'm guessing we're looking for update exe, and we're looking for the what is it? We're looking for the C2 connection. So we are now, excuse me, we're now looking for, and we are also looking for the C2 connection. So this is a connection that's been established. So that's what we can deduce from this specific thing. So if we go back to our terminal and do the volatility, oh, whoops, let's do that. And then we do volatility, and then we do the name of the file, and then we'll do -h one more time. And from the list of the modules, we have, what do we, oh, the network, this is it, this is the one. So Windows NetScan would be the one that we would be most interested in. The list of the plugins, this is the one that resembles the closest thing to actually finding anything from a file that has to do with network connections. So we'll do the vol-f and then the raw file, and then we're going to do the Windows netscan.netscan, or whoops, I did not do dot, so .net scan, like that. And is that it? Yeah, that's how you do it. Okay, so let's do that, and let's see how quickly this runs. Hopefully it'll be a little bit faster than the other one. So we have, you know, offset, local address, local port, foreign address, foreign port, state, PID, owner, created, and this is the stuff that we're going to pull from this. The progress is at 100, but I don't see anything. So I wonder if there's, oh, there we go. All right, okay, cool. And I mean, literally right here, it says updater exe, and what's the, I need to actually see like the full thing, because this is formatted in like a weird way. So if I pull it like that, there we go. So we have updater.exe, and then the UDVP4, there's no, this is the connection that potentially was established and then closed, I would say. Is there any more information at the end right here? So there, yeah, there we go. So we do also have this one, updater.exe. This was the connection that seems to have been closed that was originally established, and it's on port 8080, and it's by updater.exe. And let's see, the connection was also right here, updater exe, and it was closed right there. Updater exe was closed right there. Updater exe was closed. What else can I find? Those are the only ones that, hold on, let's see what else I can find over here. I think those are the only ones that actually have been listed. Oh no, right here at the top as well. There was another one that I just saw, updater exe, that was closed again, and updater exe, and it was closed again, and it was established on, well, that's Outlook. I wonder if that's actually still the same thing. But so, I mean, we could see that there's multiple connections that have been established and closed. So it's presuming that the connection was made and then the connection was closed. So that's kind of the deduction that we can make from this, the assumption that we can make from this. And that is the full list. So after that, we're done. So updater exe would be the name of the file. And then what is the PID of the malicious process that's used to establish that? So updater exe, and do we have a PID over here? I wonder if I do. I think this is the port field. This is not the actual PID field. Do I have a PID location? Oh, I do. So PID owner created. So state PID owner created. So state PID. So it's state and then PID. That's what we're looking for. So state and then the PID would be right after it. So if we go back down to the updater at the bottom, the state would be this, and then the PID would be right after it, it seems. So what is it? Is it this 6216? So state is closed. 6216 would be the PID. All right, cool, nice. What is the full path of the malicious process that's used to establish the C2 connection? So we're looking for updater exe. So let's run that strings thing one more time. So we'll do strings, and then we'll do the file, and then we're going to grep for updater.exe Let's see what we can get from that. So at the bottom of the output, we have Windows Tasks Updater exe. I'm going to try this one because this is right in front of my face. So let's see if that is useful and what it's useful. Okay, so what is the IP address and port of the C2 connection initiated by the malicious binary? And then we're going to do IP address and then port. So we also had this right here at the very, I feel like we should have been asked this question first. So this is the 128.199.95 IP address, and it's just on port 8080. So let's try that, and then we'll do port 8080. And that is the correct. Okay, so what is the full file path of the malicious email attachment based on the memory dump? The full file path of the malicious email attachment based on the memory dump. The malicious email address or the email attachment, right? The malicious email attachment was the guy's resume, right? Isn't that what it was? So resume application for this guy. And what's the name of the file one more time? I mean, I could have just scrolled up. So it's resume Wesley Taylor, resume_Wesley Taylor, capitalized first letters. So, I mean, what can we do here? So we can do, let's see if there's a, there has to be, I'm sure that there is. So if we do vol f, and then if we do the wk file, and then let's do the h command one more time, there is always something that you can use for files. So if I want to scan for files inside of, boom, right there. So Windows file scan. That's the one that we're going to end up using. So we will do this, and then we will delete that, and we'll do windows.filescan.file scan like that. And then boom. All right, so there we go. Now it's scanning for the files. And process is complete. So it's just going to take a couple of seconds for it to load. And oh, I totally forgot to, oh, no. Cancel that. We're going to get a lot of files that are going to come. So we need to grep for homeboy's resume name. What was his? It was resume_Wesley Taylor. So that's what the full command looks like. So you do the file scan, and then you want to grep for Wesley Taylor's resume. And now it's going to scan for that specifically, and instead of showing me all of the freaking files, which is a lot of files, we are going to only pull the one that has this name in it. Yay! Let's make life a little bit easier for ourselves, huh? And I'm going to shrink this back down a little bit because now I don't need as much of a wide thing anymore. So let's kind of shrink, or let's expand it a little bit. We'll go right here. Boom. Okay, there we go. There's the full path, right? Is that what it is? So users, Maxine, etc., etc. So it would be, this is represented by the actual, I want to say the computer itself, like the host itself. I think that's what the host is right there. So if we just put C and then do \users and then everything else and then .doc, that's basically the name of the file, or the path of the file. So I'm going to copy this, assuming that I can right click and copy. There we go. Excellent. We are going to go to CyberChef. We're going to paste it just so we can do some quick modifications here. Or maybe the 002 is a part of the file name, maybe? So let's try that. So we'll do the 002 as a part of the file name. And maybe that's actually a part of it. So let's see. There is no two backslashes. There's a singular slash. Oh, it is. Okay, so the 002 is actually a part of the file name. I almost deleted this because I thought that for whatever reason it was some kind of a formatting thing. But no, that is. So that is the full file path, and we retrieved it by doing the volume or volatility, not volume, volatility-f, and in the name of the raw file, Windows file scan, and then we grepped for Wesley Taylor's resume name. And finally, the attacker implanted a scheduled task after establishing the C2 callback. What is the full command used by the attacker to maintain persistence? You may use some known keywords that indicate a scheduled task execution to extract this information. So we are looking for a scheduled task, and the keyword for the scheduled tasks. So let's see, what is the, I think it's SCK. No, SC. What's the executable for scheduled tasks on Windows? It's SCH tasks. So SCH tasks.exe would be this the executable for that. So it's SCH tasks, right? That would be the command that we would be searching for, and then from there we would essentially be trying to just kind of get the information. So I mean, I'm sure there's a plugin that we can use to run that. And let's see. Let's try strings just in case it's available with strings and we don't have to go through that whole thing. So SCH tasks. And then let's see if I can find anything like that there. So the strings command was actually very helpful with this. So if you want to create a scheduled task, right? What is it? So implanted a scheduled task right after establishing the callback. What is the full command that they used? So scheduled task create is the command that would be used. And so we have multiple references to this. So we can technically even kind of, and I think this might actually be the command right here. I just don't know exactly where it ends. Maybe it ends between the semicolon. So I want to say maybe it's this. Like this might be the full command right there between the two semicolons. We can also kind of just hone in on this a little bit more. And instead of just doing scheduled tasks, we can just do /create as an additional portion of the parameter, and it'll still run through it, and it'll only pull something that has that /create for us. And there, yeah, so there you go. So this right here, this full thing, and then goes right there between these two semicolons. So you see there's a semicolon right there, and then it starts with scheduled task create, and then this just continues on. It just goes all the way until this other semicolon, and then we have this full thing being the command that would be ran. So let's try it. Oh wow, look at that. Oh my gosh. This one was so much faster than the other one. Wow, dude, round 2, he did not last very long in round 2. Round 1, I was freaking running in circles for a minute trying to figure out what the hell is going on. But okay, cool. We got it. So I gotta say, I'm not gonna get cocky because I know that there's a part 3 to this. So I don't want to be like, oh wow, that was weak and blah 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 blah. But that was kind of like a little bit easier than I thought it was gonna be. I mean that's pretty much it. We're literally officially done with this entire thing. So Boogeyman Part 2 has been knocked out, and for the most part we used 3 different commands, like 3 different series of commands. We used at the very beginning, we used that olevba or whatever it is, OLEVBA. We used that to look at the document, which was his actual resume. So we looked at the resume document and we were able to pull the macros from it, and inside of that we actually had the initial link for that first download and the name of the executable and things like that. So that was a part of the series of commands. And then after we were done with that, we were pretty much just using volatility and strings. And strings comes pre-installed with pretty much every machine, and it just pulls the string values from a file, so that depending on what type of formatting the file has gone through, you can always just pull the string values from it. And strings are just like text values. It just converts anything into a text. You could technically convert a number into a text. So a number would be an integer, and then you could turn that into string value, which is it's read as text value. And so we're just pulling all of those, right? So from there, we're pulling all of those, and then we're grepping for specific names of things that we gathered through the investigation. And that was it. It was like volatility, strings, and then at the very beginning, we used olevba, OLEVBA, OLVBA, whatever. And that's it. That was it was fairly quick. I think the entire recording right now is at 53 minutes. And after I cut away the pauses and my searches and things like that, it'll definitely going to be less than 50 minutes for sure. So let's say 45 minutes, maybe 30 minutes. I don't know exactly how long it's going to be, but this was pretty quick. So all of that to say, this was relatively easy. Again, I don't want to get too cocky here, but this was relatively easy and I enjoyed it. So I hope you enjoyed it as well. I hope you went through the exercises with me and you were able to gather the intelligence and get the information and learn something along the way. If you found this video useful, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. We have one more to go, which is the Boogeyman Part 3, and then we will be officially done with SOC Level 1 until they add more videos to SOC Level 1, or the more challenges and rooms and things like that to SOC Level 1. But we'll officially be done with that. We can go pick up from the halfway point about is where we are with SOC Level 2, and I can go and complete that. And at that point, I'll also be able to start on the new series of content, which will have to do with the pen testing stuff, and it will also have to do with the AI for cybersecurity. So I had to do a little bit of kind of like management of everything that I had in the pipeline, and I just wanted to make sure I finished certain things before we jumped into the AI stuff and everything else. So this is pretty much it. I mean, like this entire channel is centered around all of that information. So if this is your very first time being introduced to this channel, or if you've been here multiple times and you still haven't subscribed, then I do encourage you to like, subscribe, and turn on the notification bell. If you have any questions or anything, drop a comment. I am very responsive in the comment section. If you have any questions about the content of this specific video and this room that we went through, the tools that we used, the commands that we ran, and the information that we gathered, or if you have questions about something else that is inside of this realm, then again, hit me up and let me know, and I am responsive in that as well. And of course, I'm about to tell you how you can get access to me on Discord. So like, subscribe, turn on the notification bell, drop a comment, or join us on Discord, and here's how you can do that. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@hankhackshackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section. And that is it for today. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I will see you in the next video later. In today's video, we are going to wrap up the SOC Level 1 Capstone challenges. This is the very last room and the last task, the last challenge inside of the SOC Level 1 pathway, and it is Boogeyman Part 3. So this is the 3rd round that we're going to take against the Boogeyman. The last 2 rounds, he got his tail handed to him. I almost cursed. This is it. This is the last round. And after this room and after this video, we're officially going to be done with the SOC Level 1 Capstone challenges, and it's literally the very, very last step in completing SOC Level 1. So this is what we have right here, Boogeyman Part 3. And then I guess, I don't know if I'll get another certificate for SOC Level 1 because I finished it once already. So it would be interesting to see how that's going to play out. And so we have the introduction as it usually plays out, and then they give us like a mini little story, a little scenario, and then there's the chaos that's inside, which is essentially just the series of questions that is inside one major task, one big task. And that's pretty much going to be it. That's going to be the whole thing that we're going to do to take care of Boogeyman for one last final time. And the machine, this is the attack box that I'm using right now, and the attack box is going to be used to attack this specific, not really attack the victim machine. This IP address that we've been assigned over here is the IP address for Kibana Elk Stack. So Kibana is a SIM tool, and Elk Stack or Elastic Stack is the tool that is available inside of, it's an open source SIM, open source security information and event manager tool that we can use essentially to go through the events. So instead of using command lines and instead of using a series of tools, in this particular case, we're actually going to be using one main tool. Probably, I think we're going to be using one main tool. And then from there, we're just going to pull all of the data and all of the information for the investigation from Elastic Stack Kibana. So that is the overall intro, or I guess I should say there's a few other pieces to it as well. I'll go through these separately, but that's kind of like the overview of what we're going to be doing today. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, bug bounties, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the Boogeyman 3 room. All right, so here's the final chapter to our Boogeyman story. Due to the previous attacks of the Boogeyman, Quick Logistics LLC has hired a managed security service provider to handle the Security Operations Center, the SOC. Little did they know the Boogeyman was still lurking and waiting for the right moment to return. And in this video, in this room, we're going to be analyzing the new tactics, techniques, and procedures of the threat group named Boogeyman. The prerequisites are these various rooms. So obviously Boogeyman parts 1 and 2, investigating with Elk, Itsy Bitsy, and Sysmon. And all of these are actually available on the channel. So if you go to the channel homepage and click on this search button right here and do a search like Itsy Bitsy, I think that's how you spell it. It comes up. So Itsy Bitsy is the room, and this is like an exercise that we did for Elastic Stack in Kibana, and it's also a part of the 3.5-hour sim course that we did over here as well. So that is available for you. And same thing with Sysmon, and same thing with investigating with Elk. Actually, I think pretty much this compilation video that's available over here, I think this actually has all of the what is it? We have Intro to Sim right here, investigating with Elk, Itsy Bitsy. I believe it has everything. I think Sysmon might be a separate video, but again, you could just find it by just searching on the channel for it. And then Boogeyman parts 1 and 2 were literally the last 2 videos that I did before this one. So that is the prerequisites, more so that you understand how to actually work with Kibana from Elk Stack, from Elastic Stack. And just to have a context of everything that we've done for this freaking Boogeyman group that has been attacking the company, I've already launched the virtual machine that has the Elastic Stack on it. I've already launched AttackBox, which is the browser version of a Linux computer that we're going to be using, a Linux virtual machine that we're going to be using to connect to the Elastic Stack server. You can also just connect to it via VPN. So if you have a membership with TryHackMe, then you can use OpenVPN, connect to the TryHackMe server via VPN, and then from there, as long as you launch this machine, it's this machine right here. This is the button. This is a bright green button. So once you launch that, you will get this IP address over here. It's going to be a different IP address for you specifically, because as soon as I end this video, this IP address is just going to be taken down. So the IP address that you want for yourself is going to be generated separately, and then your Elastic Stack, your instance of Elk Stack Elastic Kibana will be connected to the IP address that they issue to you, and you'll see how we access it. It's very easy. You literally just go to this http:// inside of the Firefox browser or inside of Chrome or whatever it is that you end up using, and the username and password has been provided to us as well. So that's pretty much it. That's the whole setup of the room. That's all the prerequisites and everything that we need for the introduction. So now what we can do is we can actually jump inside of what's going on in this case. And it seems to be that, again, this is just a continuation and they're doing yet another phishing campaign. So let's get the details here. So this time around, the Boogeyman group was able to compromise one of the employees and stayed in the dark. They didn't trip any of the security defenses of quick logistics, so intrusion detection or anything of that sort. And they were actually able to compromise the employee and waiting for the right moment to continue the attack. And using the initial email that we see right here, the threat actors attempted to expand the impact by targeting the CEO, which is Evan Hutchinson. So this email that we see right here apparently is addressed to Evan Hutchinson. So let's see right here. It doesn't say the email address, so we're going to have to actually pull it up, open the email address to be able to see it. But it says, "Dear Evan, we require your urgent attention for the review of an important financial document. Your insights are crucial to proceed effectively. Could you please allocate a brief window for this review? Your prompt response is appreciated. Best regards, Ali Sierra, Chief Finance Officer, Quick Logistics LLC, and Ali Sierra at quicklogistics.org. So that seems like a legitimate email right there, but you can essentially just hyperlink any text to look like that. So it could be pointing to a malicious email address, right? So, and then the email right here is ali.sierra at quicklogistics.org. So that even seems legit. So let's see if that is indeed the email that is supposed to look like. But for the most part, it looks like a good email, right? It looks like it's coming from the CFO, the Chief Finance Officer. And of course, the title of it says urgent financial matter requiring immediate action. I don't know why I can't zoom in like on it anymore, but it says urgent financial matter requiring immediate action. So it's kind of something that is grabbing the CEO's attention. Ali Sierra is somebody that probably exists inside of their company. So, you know, the Boogeyman group has done their due diligence and they've done their research. And usually they do a good amount of research. It's just that we always catch them because we're better than them. So the email appeared questionable, but Evan still opened the attachment despite the skepticism. After opening the attached document and seeing nothing happened, Evan reported the phishing email to the security team. Upon receiving the phishing email report, the security team investigated the workstation of the CEO. During this activity, the team discovered the email attachment in the downloads folder of the victim. So we have Project Financial Summary Q3 PDF over here. So that's basically it. And then in addition, the security team also observed a file inside the ISO payload as shown in the image above. So we can actually see this PDF right here, which it's very interesting. So it has a .pdf extension, but when you look at the type of it, it says it's a disk image file. A disk image file is an ISO file. So it should have technically a .iso extension, but in this particular case, it does not have a .iso extension. Then there is a file inside of the ISO payload as shown in this image where we actually open the ISO. So now we're inside of the DVD drive, right? So when we open it up, we can see that there's a Q3 PDF on here. Now, let me just kind of clarify something for myself. So they investigated the workstation of the CEO. During this, the team discovered the email attachment in the downloads folder of the victim. So this, yeah, okay. So for sure, the first conclusion was right. So they're technically right now in this image, in this screenshot right here, they're still looking at the CEO's computer, and inside of the downloads folder of the CEO, they have this disk image. For a second, I thought that maybe the security team took an image of the CEO's computer, and then that's where they were able to find this PDF document. But that is not the case. They're actually looking at it on the CEO's computer, from what it sounds like. So it was presumed by the security team that the incident occurred between August 29th and August 30th. So these are going to be the times that we're going to zoom in on Kibana. And given the initial findings, you are tasked to analyze and assess the impact of the compromise. And what is the PID of the process, etc. So all of these things, I'm not going to go through the list of the questions. We'll just go through them one by one together. But that is really all of the context that we're going to get on what happened. So we're going to open up Firefox, and then we're going to go to our Elastic Stack instance inside of Firefox, and we're going to start the investigation. And that's essentially it. I'm going to open this up inside of a new window, so we have a full screen version of this, as we usually do with these types of exercises. And I'm going to open up the outline of the course, or not the course, the outline of the questions and everything in a separate window. So we have that. So now we're going to go right here. We'll do http:// and then we will paste the IP address, press enter, and we now have Elastic Stack Elk loading, and our name is Elastic and password is Elastic, and I'll save it, I guess, but it doesn't really matter. So it's going to take a couple of seconds for this to load. And the very first thing that we're looking for in the question says, what is the PID of the process that executed the initial stage payload? So that's the first question. So what we're going to do is we're going to click on this menu on the left-hand side right here. We're going to go into the Discover portion right here so we can see this real quick. So on the menu, we have Discover. And then usually when you click on Discover, it says there's no results or whatever. The thing has actually been loaded for us. So let me actually see if I can find that real quick, because it should say also what index that we're using or what file has been loaded for us. It doesn't. So let me click on this D right here, and okay, that's not there either. In either case, usually when they give us, oh, there we go. My bad. It's literally right on the page. So winlogbeat is the index that we're looking at in this particular case. And it seems to be that's the only index that we have available. So that's all good. Usually when you load something inside of any SIM software, it gives you the most recent or the smallest chunk of time in the most recent period. So you have the last 15 minutes. So this is the first thing that we need to adjust. And it's August 29th and August 30th. So that's basically what it is. So when you click on that customize or adjustment portion, it gives you different ranges. So you can do from 15 minutes ago to now, or I can go to absolute right here and then change the time to where I need it to be. So I need it to be 2023. I need it to be August. And then it's going to start from August 29th. So I'll do August 29th. And then the timestamp is basically going to be 00 August 29th. So that's when it'll start. And then we will go to on this now button, and we're going to do this also absolute. And then again, we're going to go to 2023. And then over here, we're going to go to August. And then it's going to be August 30th, which is right there. And then I'm going to do the last timestamp, which is 2330. So we're going from the beginning of August 29th, 2023 to the end of August 30th, 2023. And then we're just going to click update, and we should have some data. So there we go. We have 28,000 hits that are available on this particular time. So now we have everything loaded, okay? So let's jump into the actual investigation here. The first question is, what is the PID of the process that executed the initial stage 1 payload? The only information that we really have is the fact that there is Evan Hutchinson, which is the CEO, and we have the name of the file, which is this project financial summary Q3 PDF. So I can go ahead and basically, you could just search for a file name, right? And from there, you can kind of see what shows up. So the very first thing that we could do is we could just search for this. So what is it? Project financial summary underscore Q3.pdf, like that. So there we go. That's the first thing that we have right here. You could just search for that and then see what actually narrows down this thing to. So it went from 28,000 to 4 hits, right? So we have now 4 hits in this particular case. So we have all of this data that you see right here. And from this data, there are different things that we can look at, because as you can see, it's kind of just a bunch of jumbled up stuff that's gathered together. And then on the left side, we can essentially just look at specific columns or specific data points that we can pull, fields that we can pull, that will then organize all of these 4 hits that we have based on the information that might actually be interesting to us. So for example, the file path, this is a common one. The host name is another common one. The script block for PowerShell is another common one. The process command line and the process name, parent process, and of course the winlog event ID. So now when you do this and we zoom out, now we have a little bit of interesting organized information. So the PowerShell file script block is irrelevant. There's nothing in here. So I'm just going to delete that to kind of make things a little bit organized here. We have the time, we have the file path, and that seems to be also relevant. So I'll just go ahead and delete the file path. There's an X button right next to all of these things, so we can just remove those columns. So we do have the host name here, and we have the process command line, the process name, process parent command line, and then the winlog event ID. Those are the columns that actually have values that would be of interest to us. So the question is, what is the PID of the process that executed the initial stage 1 payload? So there are a few things that we can use to see what the initial command was, right? The initial thing was. You can literally just look at the timestamps. So initial meaning first. So you want to see what was the first thing that was launched, basically. And it goes from, yeah, so this is the early ones, and then the one at the top would be the later ones. So this would be the very first thing that has been launched. This is the computer that it was launched on, quick logistics. This is the command that it was launched. mshtaexe would be the executable, the process name that's available over there. And then Windows Explorer exe is the parent command line, the parent process command line. So the what is it, mishta exe, whatever, that's the thing. So now I need the actual PID field so I can be able to pull that information real quick. So let me find the PID field real quick. All right, there is a field called the process PID, as we can see right here. So process PID would be the one that I put as the column. We have 6392 as the answer over there. So let's try 6392. Let's see if that is indeed the answer. And what do you know? It actually is the answer. So there you go. So process PID is 6392. The host name, which will probably be useful to us, is going to be the workstation 0051. That's the host name. Let's see if we can actually find the username as well. Usually there is a field that's associated with the user that this belongs to. There we go, username. So if we add the username in this particular case, let me add that. Boom. And then when you actually highlight the username, I don't know if you saw that pop-up that came up. So when I click on the username, we can see that the 5 values that actually belong to Evan Hutchinson. So Evan.Hutchinson, and then we see it on the right here as well. So Evan.Hutchinson is our user. And let's actually also get the IP address that would be relevant to this guy. So I can, instead of scrolling, I can always just do IP. And then we can see destination IP, DNS resolved, host IP, and the host IP would be the one that I would be interested in. So I will do host IP over there as well. And we will be able to get that information. And it has the 1010, 15, 159, etc., etc. So I'm just going to start a little text document on my other monitor here to just note these things, because I feel like they will be useful to us as we go along this exercise here. So let's note these. I'm going to note these, and then we'll just move on to question number 2. All right, question 2 says, the stage 1 payload, can I zoom in here? The stage 1 payload attempted to implant a file to another location. What is the full command line value of this execution? So if we go here, we have our series of events, right? So we have mshta, or whatever this thing was, that was the very initial stage 1 payload that was downloaded, and it ran. And then the very next event that took place was this thing right here that also has to do with the project financial summary Q3, etc. And it's this thing right here. So we have the Windows system xcopy, and the xcopy executable is actually something I believe that is used to copy files from one location to another one, and moving files around the system, so to speak. So that is the full command that we have over here. It's under the process command line. So I'm going to just copy this. We're going to copy xcopy is what we're going to do. So we're just going to grab that full thing and right click on that. Let's click copy, go over here, drop it, press enter. Cool. There we go. So that is question number 2. Now, question number 3. The implanted file was eventually used and executed by the stage 1 payload. What is the full command line value of the execution? So we're just moving down the line here. So this was eventually used and executed by the stage 1 payload. So if we go at the next event in line that we have over here, it is this one. This is the very next one. So we have the run DLL executable is the one that ran, and it took the file and actually ran it. So we're just going to copy that, boom, and then come back here, and then we're going to paste that, press enter. There we go. We're making pretty solid progress. All right, the next question, question number 4, says that the payload was established a persistence mechanism. What is the name of the scheduled task created by the malicious script? So we're going to go back over here, and it's going to be basically this last item that we have, and it is going to create a script, so or a scheduled task, right? So he's using PowerShell. He's gonna run schedule task action, execute run DLL32, argument user local temper, deregister. I need to actually look at that thing because there's more value here. So let's see if we can kind of expand on this a little bit. So I will remove the winlog event ID. Let's see if that'll actually help us a little bit. And I've already noted the IP address and the username, so I'll just remove those guys too. And so, all right, so now we have a full view of this thing. So what do we have? The new scheduled task, where is it? We have the DLL register, review.data, the new scheduled task manager, daily at this time, new scheduled task setting, new principal, username, and then task action, trigger, principal, So what do we have? The task review input object deforce. I want to say it's this thing. So register scheduled task review. I would like to say that that's the name. So there's also, again, this isn't something that I'm not shy about, that we can always use to kind of understand what's going on, right? So we can always just go to one of our friendly tools, which is our friendly AIs. So in this particular case, I'm just going to use Gemini, and I'm going to paste the command, and simply I'm just going to say, what is the name of the scheduled task that is being created by this command? And that's it. And so just to kind of give you an idea, right? So it says, there we go. So the name of it is being, it's called review. This is specified in the register scheduled task part of the command. If you really wanted to understand what was happening with that, you could literally just say, can you please explain the command in detail for me? The full command, right? So the full command in detail for me, and then I'll go ahead and do that, and I'll just paste the command one more time. And then so what it's going to do is it's going to go through the whole thing, and it's going to give you a great understanding of what the command is doing and the various elements of it, etc. So this is beyond the scope of this video. I'm not here to try to explain to you the very details of what this full thing is, but if you want to make sure that you really understand what's going on and not second guess yourself or be unsure about the answer like I just was, it's probably a good idea to go through these types of situations and actually review these commands to see what's being done. So I am going to do it. It's just that I'm not going to sit here and explain it, because I just showed you how to go ahead and retrieve that information for yourself. And one of my goals always is to just kind of give you, teach you how to fish, so to speak. I don't want to just spoon feed everything to you. So we're going to try to find the answers for this investigation, but you can easily just go ahead and pull that information, go to your favorite AI chatbot, and then from there have it explain everything to you, and you'll see what is going on. And it just gives you more context. It gives you a stronger frame of reference for everything else that you're going to be doing as you study cybersecurity and develop your skill set. So the answer is indeed review. And now we can move on to the next question. The execution of the implanted file inside the machine has initiated a potential C2 connection, a command and control connection. What is the IP and port that's used by this connection? So one of the things that we got at the very, very beginning was that they kind of hinted that you need to know about Sysmon. And Sysmon is something that has event IDs and it has event names that are associated with it. So we need to obviously pivot because we ran out of hits on this particular one. So we need to actually adjust our overall search query here from the project financial summary into something else. So we know that the tool that's being used is PowerShell to actually run these commands and do the things that they do. So we can actually search for PowerShell.exe. Let me make sure I spell these things correctly. and then we can say and, right? So you can essentially combine queries like this, right? So you can say PowerShell.exe and the event dot, let's see what I can find as far as categories or, you know, various extensions of this event are concerned. We can even actually do this. So I'm gonna erase everything else. I'm gonna press enter. Obviously it's gonna give me way more hits because anything that was done on PowerShell is for a lot of things that can be done. So anything that was done on PowerShell is going to obviously show up. So what we're going to do is we're going to clear our fields, right? I'm gonna clear all of my fields over here, and I'm going to look for any potential event correlated type of a category or event. I think it's a provider or something that would be available to us because we're looking for the Sysmon stuff, anything that's available for Sysmon. So if I click on event provider, so we see Windows, Microsoft Windows Sysmon is the name of the event provider. So we could do and event provider, event.provider is going to be Microsoft Windows Sysmon. So let's do Microsoft Windows. Oh, whoops, I need to separate it by dashes. Microsoft Windows Sysmon. There we go. And it actually kind of gives you the automatic fill as well. If you have a general idea of what you're looking for, it'll help you do that. So so we do PowerShell, Microsoft Windows Sysmon. It doesn't really narrow it down much. We still have 7,000 events that we need to go to. So the main thing that we're interested in is a connection, right? So when you think about a C2 connection, it's essentially establishing a network connection for you. So we can go, I'll just do it inside of Gemini since we're already kind of starting this conversation. So I'm interested in the event IDs, right? So what Sysmon event ID would be related to a C2 connection. And we can just do that. And then it'll give you potential event IDs. So there we go. So the most relevant one is Sysmon event ID 3, which is for network connections. And here's why, so on and so forth. So we're looking for network connections basically. So we will go and do event ID. So that would be the next thing that we're going to kind of combine for here. So we will do and, so we're adding another filter on top of that. So it needs to be PowerShell, and it needs to be the event provider Sysmon and the event code, because it could be event ID as well, I think actually. So but we'll do event code, and then we'll do 3 in the event code, see what shows up. 7,123 hits. So that's definitely not what I am interested in, or maybe I don't know. So let's try event ID. Let's see if it gives us anything better for event ID, and we'll do 3 on that, and nothing shows up for event ID, so it has to be event code. So we'll do event code, and that's what it is. And this is all the stuff that's available over here. So we do have PowerShell, we have all of these things. There should be some other stuff that we can potentially kind of organize. So let's see maybe if we can do and user would be what's his name, Evan Hutchinson, right? Hutchinson, like that. So let's see if anything shows up for Evan Hutchinson. Nothing. Or it's not user, I think it's username. I think that's the thing that I messed up on. So I'll just cut this off real quick and see what other information I can find, because there has to be a way that we can narrow this down even further to at least the host that we have. Or yeah, it's username, so that's my bad. So let's try to do and user.name, and then that would be Evan. There we go. So we actually have Evan Hutchinson as one of our people over here, and so we'll do that, and we'll press enter. 2,459 hits, so there's still a lot going on. So let's see what else we can narrow this down on. Since we are looking for a C2 server connection, we can go ahead and narrow this down by an IP address that we're connecting to. So if we go to right here, we have something called the destination IP. So if we go to the destination IP, we have this thing, which is not recognizable. This is the IP address of the CE. No, it's not the IP address of the CEO. One of these should be the IP address of the CEO, but we have this is the big one that there's a lot of conversations that are going out to. So that seems to be interesting. So let's see if we can actually narrow this down even further. So if I actually go ahead and click on this, so if I click on that, it'll add it to my query at the top right here, or right here, excuse me. It'll add it to my filters at the top right here. And from here, we can go ahead and press enter. Let's see if it'll narrow this thing down for us. So let's click on destination IP to add it to our field. So we actually do see everything is the destination IP that we just filtered. Okay, so that's good. So we need the port as well. So let me see what we can find for destination ports. We'll go ahead and do that and add that. So we have destination port is port 80. So 162 or 165.2.3. I'll just copy this because it's easier. So we'll just copy that IP address. We'll go over here, and I don't want my machine to expire because that would suck. Okay, so that is actually the answer. So it is the 165.232.170.151 on port 80. So that one's good. So let me just add a time right here. I really don't want this thing to crash in the middle, and that would suck. And we would have to go through this whole thing again, and it's a pain in the butt. All right, so we got the machine extended. Okay, great. So the machine is extended, and it's also extended on my second window. So that's a little like pro tip for you. When you extend the machine on one window, if you have it open in another window, you need to double check and verify that it's also running on the second window, because if it expires on the second window because for whatever reason the page wasn't refreshed or something, and the second window thinks that your machine expired, it'll just kick you out. Okay, cool. So there is that question, the execution of the implanted file, and we got it by kind of narrowing this thing down. And as I was looking at my second window, of course, my machine shrunk as well. So we got it by narrowing this down by looking at all of the PowerShell events, and then the event provider is Windows Sysmon. The event code is the 3 for network connections. And we also just honed in on everything that was being done for Evan Hutchinson. And then we looked at the destination IP address to see what was available. And the bulk of the data, the traffic that was going to destination IP addresses was the IP addresses, this external IP address right here. So it narrowed it down for us from Evan Hutchinson and the communications, I guess, that Evan Hutchinson's machine is having with all the other IPs. And it just happens to be that the destination IP, the big one, is that 165.232, and you just add the destination port at that point, and it just shows you the destination port. So we are good on that. So now the next question. So the question says, the attacker has discovered that the current access is a local administrator. What is the name of the process used by the attacker to execute a UAC, a user access control bypass? So the name of the process that was used by the attacker to execute it, and the attacker has discovered that the current access is a local admin. So we need to try to see what we can user access control. I think it's user access control or user account control. I believe that's what it stands for. So we need to kind of hone in on the IP address that was used, this destination IP address that has that C2 server, and the payload that is being used to execute all of these commands, essentially. And we're going to find that payload. Let's scroll up because we can refer to everything that we've discovered in the investigation so far, right? So the Xcopy was used to take this review.dat or review.dat, which at first glance it kind of looks like a database or like a data file. But that would be one thing that would be a hint to us, and then we can kind of see, just based on narrowing that down, what other actions were essentially performed, and we can kind of just take it from there. So let's go ahead and review the review.dat. So let's go over here. We'll just delete this whole thing, and then we'll do review.dat as the file name and see what we can get. And it says there's no, I need to remove this destination IP address as well. So we're going to remove that. And now we have 39 hits that are available. And I'm going to remove the destination IP. I'm going to remove the destination port. And now we have all of this data that is available to us right here. And the thing that we're looking for is the name of the process that's used by the attacker. So we'll go ahead and add the process command line right here. We'll also add the process name right here. And then we will do the parent process command line as well. And we'll do the process PID. Why the hell not? Let's make sure that we have all the information. So at first glance, let's see what we find here. We have PowerShell that's been executed. We have the FOD helper. We have who am I that's been executed. That's interesting. That's an execution, or that's a command that's usually indicative that somebody's trying to get some information about their privileges and the permissions that they have, especially when you're looking at, when you're considering like a pen testing type of an environment, or at the very least when you're trying to do some kind of an investigation. When you do a pen test or when you do an investigation towards somebody that's trying to hack you, you find these things that the who am I gives you the actual user that you are, and net.exe is actually also something that I believe is trying to look at, for example, so this is the actual command, but then he's trying to look at the local group administrators and the users and the who am I dash all or / all that would potentially be, okay, well, who am I and what are my privileges that I can execute as the current user that I am. So all of these things are actually very helpful, and they're indicative of what this person is doing or what they're trying to do. So the question is, what is the process that was used to get this UAC, the user account control? That's the big thing that we're trying to narrow down from this review.dat file, or this review.dat portion. All right, so this is essentially the end of the list, the end of all of these events. So we have the original X copy that was correlated to the review.dat, and the very next one is the run DLL 32 that is looking at this command. So what do we have? We have the DLL register server and then the PowerShell executable. And I think that for the most part, there's either that and there's the cmd.exe, net.exe, who am I, FOD helper, and then again PowerShell. So we have essentially just a handful of executables that could potentially be the answer here. But specifically what we're trying to do is we're trying to see if any of these things can be used for user access control or user account control privileges, or changing the privileges, because that is what the question said. So it says, what is the name of the process that's used to execute a UAC bypass? So let's try to get some information about our executable. So the X copy, we know what it does. We know what net.exe does. We know what was the other one? Who am I exe does. We know what PowerShell exe does. So FOD helper is something that's interesting here. And of course we have the run DLL executable, and that's pretty much it. Like, those are really the only ones that are available. So I'm going to just copy this to use it exactly. And then what we're going to do from there is we're just gonna go refer to our handy dandy resources here. Okay, so I mean, based on the information from Gemini, FOD helper has been known to be exploited to perform user account control bypasses, and also the run DLL exe can be used in UIC bypass techniques. Though it's not a direct single-step bypass like others, it's more often used as a component within a larger exploit chain. So both of them could technically be it. So then another thing that we could do is we can go to MITRE, and we can look at the MITRE attack framework, and then user account control. So I think I could do user account control, right? Either that, or let's see if we could do UAC maybe. And none of those things work. So there has to be a way that we can actually search for this, because I know for a fact that we can try to see what is going on, elevation, or there you go. So you have abuse elevation control mechanism. That could be a thing that we could do. And if we could go over here, UCMD download method technique to do these things. And so let me do a little bit of research on this page, see if there's anything that might be useful to us. Okay, so this is actually very interesting. So if we go back a little bit and we're looking at the abuse elevation control, right? So if we go, and again, just to kind of show you how we got here, this is basically the attack matrix. And under privilege escalation, there's a whole category under privilege escalation. And we're specifically looking for something that has to do with account controls or account manipulation that we see right here. So the very first one that I clicked on was elevated or abuse elevation control mechanism. And there is something for Raspberry Robin, which has to do with the variation of these things to abuse Windows auto elevate backdoor by bypassing UAC while elevating privileges. So when we click on Raspberry Robin, we can see all of the techniques that they've used. And at the very top, you have bypass user account control. So they'll use this legitimate Windows utility called FOD helper exe to run the process. So that is most likely the answer that we're looking for. So let's go over here. Let's paste this. There we go. We actually have that answer. Great. So that it was like we had to take a couple of turns to get there, but we definitely got there. So all right, moving on to the next question here. Now they have a high privilege machine access and the attacker attempted to dump the credentials inside the machine. What is the GitHub link that's used by the attacker to download a tool for credential dumping? So I mean, really all we're doing here is just searching for GitHub for this one. So we're going to do GitHub, press enter. So let's see what we get for GitHub. It says nothing. Oh, I still need to, let me see. No, there's nothing else that I got to do. So what did I do here? GitHub, maybe it's github.com maybe? Like maybe I have to do it specifically. Oh, there you go. So github.com, I actually have this information and the IP address could potentially be useful for me. I do need a process command line. I mean, for this, it's literally right here. So it's like invoke web request, HTTPS, etc., etc. And it's Mimikatz. Mimikatz is a tool that is very commonly used for credential dumping. So we could just take that. So let's just use that. See if that works. Yeah, that one was kind of a gimme. Because in the question, they kind of tell us exactly where the answer would be, which is the GitHub repository. So if we just go to github.com or if we search for github.com, we'll be able to find the link that's used. And if you just know Mimikatz or if you've done any kind of pen testing or junior pen testing, anything of that stuff, Mimikatz is a tool that is used for credential dumping. It's like a very powerful tool to use for credential dumping. So all right, after successfully dumping the credentials inside the machine, the attacker used the credentials to gain access to another machine. What is the username and hash of the new credential pair? So username and hash of the new credential pair. So we are going to go and now we're going to start searching for Mimikatz. And yeah, right? Mimikatz with a Z. Yeah, so we're going to start searching for Mimikatz and let's see what we can find here. So now we have 41 hits with Mimikatz. I do want to start kind of doing a few extra filtering here. So we're going to add a filter and we will use the CEO's IP address as our first filter. So let's see, it's going to be host.ip. And there we go. And we're going to operator is, and then the value is going to be the CEO's IP address, which I saved. So the CEO IP address is 10.10.155.159. And there we go. So we got that. So now we have 12 hits. Excellent. Okay, cool. So now we want the username and password that was generated, right? So I believe so, yeah. Okay, so we want the username and password that was generated. So we're just going to go through these 12 hits. It should be a fairly simple little thing to do. Let me see what I can find here. Okay, so for this, I want to do a few things because Mimikatz just by itself is actually showing us the Mimikatz trunk.zip and all these things. So we want to see the one that actually has to do with the executable. I also removed the parent process command line columns to make it a little bit easier. So we have a couple, literally actually 7 hits, and there's only 2 of them that actually have a process command line that's running. So the first one is the privilege debug secure LSA logon passwords, and I believe this is getting just all of the hash values of the users that are available inside of it. And then this is the next one that they ran. So secure LSA, user IT admin is the user, domain is quick logistics, the NTLM is a specific value for the hash values inside of Windows. So I think we can just do that right there and just highlight that hash value. And so what do we want? We want the name, which is itadmin, and then we're gonna dump the hash like that, and there we go. Nice. Okay, cool. So we are making more progress here. We still have a handful of questions to go, but I think we're pretty much at the halfway mark, it seems like. Okay, so moving on to the next question. I have no idea what question number we're on, but moving on to the next question. Question says, using the new credentials, the attacker attempted to enumerate accessible file shares. What is the name of the file accessed by the attacker from a remote share? So he's trying to enumerate file shares. Now, file shares can actually be enumerated a few different ways, and we can kind of try to see what potentially can take place. So let's see if I just do share like this. Let's see what shows up with just searching for share. Okay, so just by kind of browsing and scrolling through these things, there's a few different commands that actually stand out because it shows, you know, things for like shared click to run and then common files, Microsoft shared, etc. But then there's this invoke share finder command that's actually interesting. And so we can kind of start filtering down, and we can even filter down by the host machine, because we know technically what the host machine of the CEO is, and we can even look for commands that were ran using PowerShell. We can even look for commands that were using the GitHub, right? So it says, after getting the contents of the remote file, the attacker, no, I'm sorry, right here, using new credentials data to enumerate accessible files. What is the name of the file that's accessed by the attacker from a remote share? So a remote share, so let's see if, let me actually just, I'll do invoke share finder as the thing, and then we'll see what that gets us. Okay, invoke share finder actually increased our results. If I remove that filter that we had for the IP address, it even increases it further, and it goes to 509. So let me see. Let's do the host name of the CEO's machine. So it's host.name, and that would equal to the workstation like that. And then we'll do 0051.quicklogistics.org. So that would be one thing. And then we can do and, let's say, invoke share finder. Let's see if that, yeah, it still goes down to 221. I think it does the same exact thing as the IP address. So that part is whatever. Let's see what else we can add to this. So if we do PowerShell as another thing, so PowerShell.exe and invoke share finder, let's do that. Okay, now we're getting somewhere. So we're getting 128 hits. So that's kind of narrowed down a little bit more. We still have GitHub inside of this as well. So GitHub is showing up pretty frequently as well. Oh, that's interesting. So GitHub is still showing up pretty interesting. So let's do, we'll do, and let me kind of do one of these things. Well, we'll do GitHub inside of the asterisk, and we'll do invoke share finder. So if we do GitHub inside of the asterisk, it'll essentially show us anything, because this has, you know, GitHub user content, and it might be github.com, or it might be any of those things. So if we do that, now we have 39 hits. Okay, this is getting good. So what do we have? So the attacker attempted to enumerate what is the name of the file that was accessed by the attacker from a remote share. So now let's actually look at the command lines. So I kind of removed everything, right? I just wanted to see what's available in our situation here. And now we're narrowing this down one more time. So then we are running these things. So we have, this is the file. So there you go. At the end of the GitHub user content domain, we see PowerView.ps1, which is a PowerShell script. PS1 is the extension for PowerShell script. So let's see, PowerView.ps1, not PS12, PS1. That's not it either. So what is the name of the file? I feel like that should be it. Isn't that it? That's interesting. Okay, so this was it was like a little bit of a shot in the dark. So what I did was I just removed everything. I kept the the host name. I kept the PowerShell, and then I added just this file. So asterisk file asterisk, just to see if anything shows up. So we have 170 hits, but when you kind of scroll, you can actually see there's this PowerShell file system. So it's cat file system. It's actually concatenating the contents that are in this particular location. And then we have IT automation .ps1, which is inside of the IT files, which would technically be something that I think would be using that IT admin username. So we have a few different commands that are run after that, but there's a series of commands that are done because he's also looking at, ls file system of the IT files, and then he starts looking, or they start looking for the IT automation PS1. Let's try it. Let's see if this is actually the answer. That would be interesting if it was if it was the answer. So let's try that. Cool. Okay, cool. So they attempted to enumerate all of the accessible file shares. So this is what that means. When you say enumerate the file shares, you're running ls on the file system, right? So you're essentially trying to see what is inside of the file system. So file system, and then let's see if we go down further. No. Okay, I think that, let's see if we can find even anything else. It seems like everything else has to do with the GitHub stuff and everything that's going on that would have to do with like a file being in the name, but kind of ls file system is like a dead giveaway that they're trying to list everything that's inside of the file system in this particular host and then inside of the IT files. So that's a pretty good one. All right, so next question. After getting the contents of the remote file, the attacker used the new credentials to move laterally. What is the new set of credentials discovered by the attacker? So let's go and do this. So we're going to go and delete this portion right here. Press enter. It's going to give us 2,986. And what we're going to do is we're going to go to the username element, and let's see what I can find if there's anything that's being displayed. Just if we click on usernames, let's see if we can find a number of usernames potentially for us, and maybe it'll actually show us that. So if I click on username, we have Evan Hutchinson, system administrator. Okay, that's definitely not it, because that would be implying that somebody was already logged in. So they would be looking at the username of the computer that's already logged in. So another thing that we can search or narrow down this from, we could look for credential. So if I do credential, because I see credential, and that's kind of a really good tip. It's a really good tool to try to find that. So it goes from 2,900 to 70 hits. Okay, that's very good. That's actually very, very useful to try to narrow this down right here. So let's see inside of these. Oh, boom, right there. You can see it. You could even see it right there. So quick logistics, Alan Smith, and then convert to secure string, tricky password, 497. Look at that. Okay, so certain keywords really help in this environment, honestly. So Alan Smith, and then we do the tricky password. Is that not it? Yeah, tricky password. Isn't that what it is? So let's see. Oh, I see. The format is, I think that's actually the computer. So it's quick logistics and then /Alan.Smith and then the password. I see. Okay, there we go. Interesting. Okay. So we needed to include the actual name of this is like the domain name, or the host name. It's not the host name, because the host name was workstation 51. So this would be the domain, and then that's the user, and then that's the password for Alan. And if we go over here, yeah, you can see it right here. So quick logistics, Alan Smith, that's actually the full username. All right, cool. Next question we got is, what's the host name of the attacker's target machine for the lateral movement? So if we go down here, we should be able to see it's like something to do with workstation. So there we go. So computer name is workstation 1327. So we can do workstation like that, and then we do 1327. Oh, really? Okay. So let me see. Oh, I see. I'm missing the N. So it's WKSTN. WKSTN. Okay, there it is. All right. It's like, dude, it can't be anything else. Okay, cool. So using the malicious command executed by the attacker from the first machine to move laterally, what is the parent process name of the malicious command executed on the second compromised machine? So we're going to narrow this down on workstation 1327 now. So let's go ahead and do this right here. So we'll do boom, and we'll do 1327. and PowerShell and credentials. Oh, it's only giving me 14 hits. And it actually has 14 hits using the keyword credential. That can't be right. So let's do this, and then we'll just delete the credential portion and press enter. Let's see what we can find. So 2,756. Okay, that's a little bit more like it. And we want the name of the parent process of the malicious command executed on the second compromised machine. So let me remove this column that I have over here as my filter. And we want something that has to do with the processes that were executed, which would technically be process creation, process executed. So we're going to go back to, what was it? It was the provider, or event provider is what we're going to do again. So we're going to do event provider equals Microsoft Windows System Monitor, so sysmon, Microsoft Windows sysmon. There we go. And then we want the, let's see, so the event ID for a new process creation. And the event ID for new process creation on sysmon is event ID 1. So we are going to go to here one more time, and then we're going to do and event code is what it was, is going to be 1. We're going to press enter. See how many we get. We got 184. So it went from 2,700 to 184. That's very useful, honestly. So now what we want is the parent process ID. So I'm going to do process command line right here. I will do process name as well. And then we will do the parent process ID, or parent process name as well. So we'll do process name. We'll do parent process command line. And then we need the parent process name. So I'll just search in the fields for parent.process. Or let's see, parent process name, right? Or process parent name. There we go. So process parent name. And there it is. So we have, this is the process parent name. It should be on the very, very last piece right here. Yep. Process parent name. So the question again is, to move laterally, what is the parent process name of the malicious command executed on the second compromised machine? Okay, so after a little bit of scrolling, we can see that this one kind of seems a little bit fishy, especially when you have the encoding option right here, and this is like an encoded command. Very obviously, it's an encoded command. So if we break this down and go through here to try to find that value that's inside of the encoded command portion. So let me try to get that. Look at this. This is massive, right? So we have the process command line or the process arguments. And any of these can actually be expanded here as well. And that is a massive, massive value right there. So I'm going to try to copy this whole thing. Hopefully I can get the full piece. So let me see. I'm going to highlight the bottom, and then we'll scroll all the way up, hold shift and click. There we go. Now we've highlighted the whole thing. We're going to copy that, and we're going to go to our favorite friend, which is the Cyber Chef. And we're going to paste that. I believe it's base 64 encoded because it has that double equal at the very, very end of it right there. So I think it's base 64 encoded. So we will do from base 64 as our script. Oh, that's definitely not it. So let's see. There needs to be something, because the encoding is it's very obvious that it's an encoded command. Usually it gives you some kind of a hint as to what it could potentially be. So let's see. Okay, so asking our friend Gemini what it would potentially be, because when I did the first layer, nothing showed here. So it seems to be multiple layers of obfuscation. So we have the first layer is base 64, then Unicode, then XOR, and then ASCII. So let's see. In essence, it's multi-layer obfuscation, hide the true intent, to try to analyze this, decode base 64, and then deobfuscate the Unicode, and then understand the XOR encryption and trace the PowerShell execution. So, okay, boom. So there we go. We actually got some really, really good stuff. Look at that. So we have from base 64, which is where it took that. And then it says remove null bytes. That's the next operator. So I only have those two used. And from there, we actually have it. If PS version table major, and then it literally just shows us the rest of the command. And then from base 64 string, it's taking that, and etc., etc. So I think for the most part, we actually did decode this. So this is a full series of commands that he's running, and I don't even know what it is that he's doing. So that's the piece where I'm like, oh my gosh, So we can technically now take this and go into this and be like, this is what we got. Okay, so this is what we got. What can you see? And then let's see what it says. Okay, so there we got. So there, the first is doing a version check, then service point manager, web client creation, user agent, target URL, proxy settings, decryption key, decryption function, cookie, payload, download. So he's downloading something else again. Initialization vector, encrypted data, decryption and execution, and then C2 communication, obfuscation, etc. Very, very interesting. Very, very powerful stuff. Okay, so what was the question? My machine almost expired again because I'm just losing my mind here. So add another hour. I do not want to lose my session with this machine. We're getting so close to finish this. I really don't want to lose the session. Okay, so we added another hour to this and we should be fine here. Let's make sure it's also the same thing on my secondary monitor. And it's great. Okay, so cool. So what even was the question that just sent me down that rabbit hole? So it says, from the mission, what is the parent process of the malicious command executed on the second? So the parent process, this is what I need to find over here. This is where the information is from the packet that I opened up. So I'm going to collapse the packet again and try to find the parent process of this. I literally just kind of went down a freaking rabbit hole, dude. It is the WSM prov host. So we're going to take that and we're going to copy that, go over here. Let's see if that's the answer. That is the answer. Great. The attacker then dumped the hashes and the machine was the username and hash. So we'll go back over here and we'll keep all of these guys right here for the most part. Let's see if we can, I think we should be able to just kind of hone in on the Mimikatz, right? So that's the big thing that we want to try to find. So there should be, I want to say I could even do and then we'll do Mimikatz.exe. Let's see if that brings us anything. That brings us 12 hits. And so there we go. So secure path or secure sec URL SA administrator domain quick logistics, and then the NTLM hash is right there, and then NTLM hash. So this is what we got. We'll go ahead and copy that, and then the administrator is the username. Cool, there we go. After gaining access to the domain controller, the attacker attempted to dump hashes via a DC sync attack. Aside from the administrator account, what account did the attacker dump? Okay, so looking for the DC sync keyword, I just did Control F on the results right here. So we have the workstation 1327. All of that stuff is pretty much exactly the same, and we're looking at 184. And he took a control of the domain controller, right? So after gaining access to the domain controller, that's what we need to find out, is what is the name of the domain controller. So right before they run DC sync, this is the file system of DC01. So domain controller 01.quicklogistics.org implies that is the name of the domain controller. So now that we know what the name of the domain controller is, we can start kind of narrowing down what potentially we can find in regards to events that were created, right? Processes that were created. So basically we can just kind of hone this down now, and we can turn this into DC01, because that would be the host name, because they took control of the domain controller. So now it goes from 180 hits to 54 hits. And the question is, aside from the administrator, what account did the attacker dump? So now we're going to look for a Mimikatz run of we're going to look for Mimikatz being run inside of the domain controller. So that's another thing. So I'll just go right here and I'll do again Mimikatz.exe, and then there's only 2 hits that hits with Mimikatz.exe, and then we have the administrator username. And what is this one? It says backup something, backup. What does it say? Backup DA, I think. Backup DA? Is that what it says? Yeah, okay, so backup DA. Oh, backup domain administrator. That's what that stands for. I was like, what is that? Okay, cool. So backup DA, that is the user account that they used. And so after dumping the hashes, the attacker attempted to download another remote file to execute ransomware. What is the link used by the attacker to download the ransomware binary? Okay, so for this, we can now get rid of the Mimikatz portion, and then there's something, so there's like an acronym for invoke web request, which is IWR, which is the thing that I've been seeing a lot. I don't see invoke web request happening frequently. I see IWR happening, and it's just an acronym for invoke web request. So, you know, there's the Mimikatz download that we had earlier, and then we have this other thing right here, the FF Silly Tech Ninja ransom boogie, so it's like the boogie, and then the out file is boogie. So where is it? It's the invoke web request ransom boogie. I just need to be able to get that full link because it's like being blocked by that thing. So we'll just expand on this, and then we'll get that link, and I think that should be the actual link that they're looking for. And assuming that that's it, that's pretty much it. We're done with this entire investigation, and we are officially also done with the SOC level 1 exercises. So there we go. Invoke web request, Silly Tech Ninja, ransom boogie exe. So we can just go ahead and take that part and copy that and go back here and boom. And here we go. Fingers crossed. So there it is. That is officially the last portion that is done. And so I got a badge. I'm going to generate my badge real quick because I slayed the boogeyman, and that should be pretty fun to be able to disclose. I also wonder if they will give me another certificate because technically I've already completed this. So I wonder if they do give me a new certificate. Let's see. So we do have the view certificate button back here again. Nope. It is the same certificate. It's still dated April 9th of 2024. So that one is definitely not it. But who cares? We are officially done with this. There is a little thing at the bottom right here that says use this path to work towards the career in cyber. So we have a security analyst career that's available. So I wonder what happens if I click on that. It'll open this up right here. So becoming a cybersecurity analyst, and it gives us some good information about that. And I have not read through this, so I'm curious what this will be like, and I will definitely go through that. It's a pretty hefty page. There's a lot of good information about it. But I mean, we're done. We're officially done with SOC level 1, or I guess I shouldn't say that because they'll probably add something else in the future, and then I'll be like, oh, we're not done, and we have to go back and do it again, or do the rest of whatever's in here. So that was it. We're officially done for now with SOC level 1. If you found this video useful and you would like to get more videos like this in the future, I encourage you to like, subscribe, and turn on the notification bell, and drop a comment in the comment section below, especially if you have questions about what we went through today, or if you have questions about anything else that we talked about in SOC level 1, or anything else that we talked about on this channel entirely. Definitely also make sure to check out the rest of the stuff that's on the channel. So all of the playlists are under the playlist section. So for example, there's the SOC level 1. Where is it? It's somewhere on the screen. I know. Boom. There's SOC level 1. And then there's also SOC level 2, which I have not completed because I'm about, I think, like maybe 40-something% in the SOC level 2 pathway. And then I went to CySec 101 because Darnell Knight requested that I go and do something for CySec 101. So I did all of that, and we completed the CySec 101 stuff. And then there was the Linux Plus that came out, Security Plus came out, and then of course I'm working currently on Pentest Plus, which is going to be coming out very soon. And there was another plus one that we did, Network Plus. That's the most recent one that came out as well. So there's a bunch of videos that's on the channel, so go check it out. You can always click on this search button and search for the videos that you're interested in. And of course, make sure that you like, subscribe, and turn on the notification bell, and drop a comment in the comment section below so that you get your questions answered, and of course you get notified the next time that a video comes out on this channel. If you're serious about your CySec training and want to get access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me, bug bounties, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/ discord.gg/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section, and that is it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I will see you in the next video later.